Hi guys, welcome to this video on SQL full course by Intellipaat. Now before we begin the session, make sure you subscribe to our channel and hit that bell icon for further notifications. In this era, data is very important. The amount of data is growing exponentially. Today, our best estimates suggest that at least 2.5 quintillion bytes of data is produced every day. SQL is a computer language that gives orders or instructions to the database. If you want to create a database, store data, update or delete data, there are different commands known as SQL. It's extremely manageable and simple to learn the language. SQL is flexible as it works in the information-based frameworks from Oracle, IBM, Microsoft and so forth. Now take an example of Facebook. While making a Facebook account, you see a registration form that you have to fill so that after clicking on the submit button, all the information filled by you has been stored in a database. So in a database management system, all works are accomplished with the assistance of SQL. Now let's see today's agenda. We'll start with Introduction to Database. Then we'll learn how to install SQL and how to create a new user. Then we'll see SQL Server Command types. Fourth, we'll also learn SSMS and DDL Statements. Fifth, we'll learn Aggregate Function, Indexes and Encapsulation. Sixth, we'll see SQL Application. Seventh, we'll learn how to become a SQL Developer. And finally, we'll wrap up with SQL Interview Questions and Answers. So without wasting any time, let's get into the video.
We live in a world which is surrounded by data, right? So what is data? In my opinion, data can be considered as the facts which are basically related to any object which we are talking about. So, data can be age. Well, age is a data. You can put that in numerics. You can put that in a form where people can take note out of it and sense out of it, because age can be anything from 0.1 all the way till 100 and much more as well, right? So age is a numeric in which we can gauge something and get something out of. And then if you're thinking about the other forms of data, again we have video data as well, right? So video is what we call as unstructured data. But then if you do not know what unstructured mean, do not worry. At this point you need to know that pretty much video is a form of data as well. And then there are other data as well. When you think about all the data we generate by leaving messages to each other on WhatsApp, or leaving tweets on Twitter, sharing photos on Instagram, or putting some updates on our timelines on Facebook. So all these stuff and lots more is what we call as data, guys. So this brings us to the question, what is a database? You might have heard of data. So if you've heard of database, guys, head to the comment section and put down the comments. As usual, we all love an interactive session. And you guys are very good at it as well, guys. So head to the comment section and put your opinions down. So what is a database? Well, a database is basically nothing but a very systematic collection of data in the most simplest terms. So why would we go about needing the systematic collection of data? Well, it's pretty much to support some sort of storage where we can hold the data, maintain the data, and eventually we can we have to have the ability to manipulate the data in a very easy way, to be honest. So to give you examples of what databases actually are, if you guys remember, when we were a couple of years ago, we used to get these telephone directories where there used to be all the numbers. It's called yellow pages in a couple of countries as well. So that is a very good example of a hard copy of a database. And the contacts option on your mobile phone right now is also a database. Well, then coming to power generation. Power generation, you might not know, has a huge database of what power is being consumed by what house and whatnot, because again at the end of the day you get billed for the power you use, and this data goes to your local electricity power supply board. And again, this forms a very big database as well, because pretty much they need to know what the power they're generating versus what's being used, and many other details as well, guys. And then coming to social media, as I just told you, uploading images, uploading statuses, uploading stories, whatnot. So all of these are stored in a database. in secure data centers, what we call, especially when it comes to social media and the privacy things. So pretty much, all of these are stored in the database, and it is stored securely, guys. So basically this brings us to the question, why would we ever go about needing a database? Well, I've pretty much tried to keep this session very simple, and these are the reasons that I could pretty much think of why pretty much we would need a database. The first thing, in my opinion, is that we need a database because managing large amounts of data is a hassle. Because you might say, you know what, I can store data in a spreadsheet and it's going to be fine. But then when you think about very, very large amounts of data, large chunks of data, and throw it all into one sheet and make it work, it might not work, or it might be extremely difficult even if it works, right? So, let's say the size of the data increases from a couple of, tens of hundreds of records to thousands and millions of records. So when this happens, it will create a huge problem if you're using spreadsheets to maintain this data, and at the end of the day it is going to hurt with respect to efficiency, time, and whatnot as well, right? So this is the first point of why you should need a database. And the second thing is the accuracy of the data, because when you think about it, doing data entry pretty much into a spreadsheet sounds very easy, but then it becomes extremely difficult to pretty much track how accurate the data is on the spreadsheet. Because at the end of the day, if you cannot have a method where you can validate the spreadsheet to find out if your data is accurate or not, it doesn't make sense. And again, think about this: manual validation of thousands and millions of entries and verification of the same are pretty much near impossible. And even if they were possible, pretty much it brings the efficiency right down to zero, right, in my opinion. So this brings us to the third reason of pretty much why we would need a database, guys. So in my opinion, again, it's the ease of data uploading, because with the database you have very good amount of flexibility to pretty much update the data present, manipulate it, play around with it, create it, delete it, whatever you want at your convenience. So you do not have to wait for the person who created the spreadsheet go through millions of entries and do all of that. So again, the best advantage of a database is that multiple people can edit the data at the same time. This brings up the efficiency and pulls it from 0 to 100, almost 100 in my opinion, guys. So what do you think about the efficiency when it comes to the database technologies of today? Head to the comment section and do let me know. So on that note, this brings us to the next reason why you should consider a database. It is pretty much because of data security. Because we do have passwords for spreadsheets and whatnot, but then the data is considered to be less secure, and it makes it gullible, because everyone can pretty much get access to all of these files. They can do some changes, remove whatever they want, or add whatever unnecessary stuff, and it hurts the data at the end of the day. But then with databases, pretty much you can have something called as security groups, privilege accesses, and so much more. So at the end of the day, here you can pretty much restrict access to a certain number of people, certain people with the privilege to access the data, manipulate the data, and whatnot. So your data will be in good hands at the end of the day. So what does that mean? Well, adding on to that, this brings us to the next point, which is data integrity. Data integrity is one of the big questions today when we are storing data in spreadsheets as well as databases, because again, we've already spoken about how data can be gullible when we've put it in spreadsheets, but then when you put it in a database, you are assured of accuracy. Number one thing, it is extremely efficient. Number two, and number three, your data is consistent, because multiple database service providers today pretty much go about giving you very good integrity checks, very good access controls, privilege accesses, member accesses, and so much more. So this brings us to something you might have heard of, or you might have used in college, or you might not know as well. It's called as DBMS. Well, DBMS pretty much means Database Management System, guys. So what is DBMS? Well, DBMS in the most simplest terms is basically just a collection of programs which enables the user, whoever is using this particular DBMS softwares, to go about accessing a database, creating a database, manipulating the data, deleting the data. So basically this gives the user an interface where he or she can talk to the database and pretty much work with the database, edit the database, delete the database, and do whatever the person wishes to if he has the right access. And this basically gives the person a very good interface, guys. So I have three facts for you with respect to the database management systems. And the first thing is that DBMS is not a new concept. It was first implemented pretty much in 1960. So that is how old a database management system is. And then when you can think about it, the person who pretty much gave us the first DBMS system pretty much is called as Charles Bachman. And his IDS is considered to be the first DBMS. IDS is basically integrated data store, is what Mr. Charles chose to call his first DBMS machine, guys. And then the third important fact is that today we know that the database technologies have evolved so much, and all of the functionalities have been given, and these functionalities increase every quarter, every year, every month. And then the database systems today are so powerful, it drives millions and millions of gigabytes of data every single day. Yes, millions and millions every single day, guys. I can say millions of millions as well, because the world, the entire world is basically a big data problem. So having a place where we can handle all of these, store all of these, and manipulate all of these is always a blessing, guys. So this brings us quickly to the introduction to SQL. Well, so what is SQL? Well, SQL is one of the standard languages we use when we go on about dealing with relational databases, which can be used to create, read, update, and delete database records, guys. So these are some of the operations we can perform. So what does SQL stands for? Well, SQL is simple. It stands for Structured Query Language, guys. You're going to find out why we call it the query language in just a moment. But then you read the term relational databases. So what is a relational database? Well, a relational database is basically just a type of database that stores and provides accesses to all the data points which are related to one another. Well, how are these data related to one another, guys? So basically, when we call it a relational database, there has to be some relation with respect to the data. Using SQL and all the DBMS, we call it the RDBMS because it's relational database management systems. Here we have the data organized in tables, which you'll see in just a second, and then we map the data so that the database knows what's important and what's not, and we do this using something called as keys. Well, keys such as primary keys, candidate keys, secondary keys, all of these provide relation between one column of the data to the other column of the data, guys. You'll see all of this in a couple of moments. But then coming to a little bit more about relational databases. Well, relational databases are pretty much based on what we call as a relational model, where we pretty much map one concept to another, the other concept is mapped to another, and we have these interdependency, interrelationships which are built throughout the data, guys. And then this makes it very intuitive and extremely straightforward. Pretty much it gives us a very straightforward way of representing the data in the form of tables, as I just mentioned. And then the other good thing about the relational database, as I already told you, is that each row has something called as a record, and there is some unique ID called as key as well. Again, we're going to check all of these in the upcoming slides. And then we have something called as columns, which any data table will have. And then these columns basically hold all of the data, and each record in this column basically is mapped onto a unique thing. And then we go on about establishing something called as interdependency relationships and much more among all of the data present, guys. And if you're wondering how SQL is pronounced, it is pronounced as either SQL or it's called SQL, guys. Pretty much you will find developers, enthusiasts, and many others either calling it SQL or SQL. So whenever you heard of the term, whenever you hear the term SQL, make sure to map it into SQL, guys. It's pretty much simple and straightforward.
All right. So first, what we do, let me just show you how you can start the installation. So here, if we go, you don't need to register yourself to download this SQL Server. So go to this page, SQL Server 2019. Just click on Try Now, and once you scroll down, you will be finding the Developer Edition. So as I told you, it's a fully featured free edition. So you don't need to procure any license or anything. You can download and install on your laptop. Okay, and just click on download. What it does, it's going to download a file, and you can see it's around 5.7 MB. Okay, and this is not actual installation file. Let me show you. You can see here, this is the downloaded file. Okay, and after you download this, what you need to do, you just right click on it or just double click on it. So here it will ask you whether you want to do the download the media and then start the installation, or you want to directly start the installation with the basic. You can see here the basic will be doing that entire installation with the default configuration. Okay, And the second thing is custom. Like while installing, there are some certain features. Usually this will be taken care in the DBA sessions. Usually all this installation will be taken care by your database administrators. So as a developer, you really need not to know the inside of, what are the configuration, how do you configure and all the stuff. So don't worry about it. And the third one is it will download the media, which is like offline software, and then you can install it anytime. Okay, so I would recommend you to go with download and then download the ISO file. The reason I'm saying downloading ISO file, now let's say if you want to install this software again on a different machine, you just need to copy the ISO file. So you can do this offline. It's a kind of having an offline software in your hand. Okay. So once you click on the download file, select the ISO file and click on it, it will download a file like this. I'll show you. Okay, you can see here. This is the disk. This is what she was also referring. So this is the DAV file. It's an ISO file, disk image file, using which we will be able to install SQL Server on our laptops. However, before doing that, we need to take care of something. First thing, before you start the installation, I would recommend you to restart your machine first. Restart your laptop. Sometimes what will happen during the installation, it will ask you to restart the machine. So before you start the installation, restart your machine and then start the installation. And also do one thing, create a user for SQL Server service alone. Okay, so I'll show you how to create a user before installation. Just go to your PC, right click on it, go to manage. So which will take you to the computer management on your Windows machine. And here go to local users, and under the users, create a new user. Okay, it's like create a new Windows user. So in this case, I already logged into this machine using my login. However, I want to use a different user for SQL Server. So that's where I'm actually creating a new user. So for this, you have to go to the computer management that you can access by right clicking on your my computer. Manage option is there, and then you will go to the local users and groups. So in the users, create a new user. So here I would like to create a user with the name SQL admin. Okay, you can see the username is SQL admin. And I'm using the same SQL admin 123 as a password. Okay. So uncheck this option, user must change the password at next logon, which means that whatever the password that you set, it will be used. Now, if you check that first option, what will happen? When you try to log in with that SQL admin, it will ask you to reset the password because that is giving you flexibility to reset the password. So in this case, uncheck all those options at the bottom and then just username and then password, create. Okay, it is saying it does not meet the requirement of password policy. So let me quickly change that. So I'm going to use so what I did now, I just created a new user, right? So this is a user. Now what I'm going to do, I'm going to add this user to groups. So in my groups, there is a group called administrators. So to that group, I'm going to add this new user that I just created. So what you can do on the user itself, go to the properties of the user and then make him member of. So here, okay, go to advanced, find now. Here you can find the group name administrators, which means I created a user and I made him admin of this laptop. Okay, so the same whatever the user that I created, also he's also a part of administrators. Okay, this is only one thing that you need to do before you start the installation. The reason I am doing this because this is how we do in real time. We will not be using default settings. So if you configure like this, it will be even tomorrow when you change your password, you need not to go back and change your SQL Server service password. So that's where I recommend you to have a separate user for SQL Server. And you don't need to log in with that user. Okay. All right. So we have created the user, right? Now let's start the installation. As I told you, after creating the user, restart your machine once. The reason I'm saying sometimes, during the installation, SQL Server give you an exception that you need to restart your computer. So don't panic. just restart your computer and then start the installation again. Okay. So now I already restarted. I don't think now it will give me that exception. All right. So the next thing what we do, we have to install, right? So right click on this ISO file, disk image file, just mount it. So just go to the installation on the left side, go to the first one. So basically, I'll give you a small, introduction. What is a standalone cluster? Okay. So in real time, what will happen? There will be something called high availability. You would have heard about this high availability, disaster recovery, and all, right? So it is nothing but, let's say you have some ticket booking system or some software you have where you have to make it available for people 24/7. So in this case, what will happen? Let's say you have one server where you install your software. And what happens if that server goes down for any reason? Let's say if you want to do some updates, and as part of your Windows updates, you may have to restart that server. So for a brief period of 10 to 30 minutes, your server has to go for reboot, right? So during that 30 minutes, your system will not be available for end user, which sometimes people won't accept it. So in order to make your system 24/7 available, what you need to do, you have to scale your servers. Scale in the sense, instead of one server, you would be having multiple servers and you will be clustering them. Okay. And then when you're doing, let's say on the active node, when you're doing the updates, you will be moving all your services to passive node. What will happen in real time, in order to have multiple systems, like, to scale your system and to have a proper, complete 24/7 online system, people usually having configure multiple lab or servers together, and they will be configuring their applications, in order to do failover and failback. So your SQL Server is compatible for that, clustering. That's where you will be also sometimes installing clustering. So that is again a DBA topic. Since we are doing it on a standalone laptop, so we'll go with the first option. So click on the first option, and this is where it will be asking you to choose which edition it is. So as I told you, just choose the developer. You don't need to enter any product key. So just select developer and then click next, because it's a free, right? So you'll not be adding any key. Normally, if it is an enterprise edition, you will have to enter the product key. So now click next, and then just simply accept terms and conditions. Now what it does, it will do the check. Okay, it will check whether this, all the required hardware requirement is matching or not. So it will do all the checks. You don't need to do anything. Your SQL Server installation setup will take care of everything. And if there are any errors, it will show you. If there are no errors, it will simply ask you to go to the next step. So it is actually verifying all the, whatever the downloaded file that you downloaded, right? It is verifying whether that all the contents in that software is intact or not. So if there is any issues, then it will show you. If not, it will ask you to go to the next. Okay, so what SQL Server installation does, it has verified whether this system is now good enough to start the installation. You can also see all the status you can see here as passed, like, it is checking whether domain control is available. It is passed, and the consistency of registry keys is passed. And it is also saying that upgrade support is passed, and you can see there is a warning. So warnings you can ignore. The reason you can see here, Windows firewall, it is giving a warning because on this laptop I disabled a Windows firewall. So that's where it is giving a warning. So if there is anything failed, if you click on that failed, like, you can also find a hyperlink. So you can see here, the moment I click on it, it is saying that the Windows firewall is enabled. Make sure appropriate ports are open to enable remote access. So it gave me a warning. Even that warning have a clear, it will also give you the link how you can fix it. Okay, so that's what the best of SQL Server. It has a very well documented, database system. So, and if you see anything failed here, just click on it. It will show you the reason why it is failed. Mostly you will not. That's where if you restart your SQL Server and start the installation, you will not finding any failed status. You will be seeing only passed and warning. Warning you can actually simply ignore. Now click on next. So this is where you will have to select the features. Now, as I told you, this is completely a DBA topic. Since we are installing, this SQL Server for a practice of TSQL, I would recommend you to just install the first one. Okay, just install the database engine, and the rest you can actually ignore. Replication and all, these are all fully DBA topics, and also you can install the full text. And other than database engine and full text, don't install anything. And in the shared features, install SQL Server Connectivity SDK. So other than that, the rest you can actually ignore. Okay. And instant root directory, it is going to the default path. Don't change anything. Click next. Okay. And once you go to the next page, so this is where it is asking you to that whether you want to have a default instance or named instance. So this is again completely a different off DBA topic. Okay. So I don't want to go depth in this. Let's just go with the default instance. Okay. Now, if you already have a default instance, let's say you already installed default instance one time, and again you are installing SQL Server, that time your laptop will not accept two default instances of SQL Server. So then what you can do, you can give a named instance and you can give a name to it. Like you can give any name, SQL1 or SQL2 or any name you can give. Okay. So, but in this mission, I don't have any SQL Server instances configured so far, which I had earlier. I already uninstalled it. So I'm going for the first time for the installation of default instance. Now it will accept. So don't change anything, just select default instance and click next. Or if somebody is not comfortable, creating a user and all, don't worry, just start and just click on install. Okay. So here also what I'll do, let's not configure, and I don't want to, whatever the user that I created at the beginning, right? Forget about that user. Okay. So let's not make it complicated. Just use all the default options and install. Now grant perform volume and maintenance task. Don't ask me what it is. It is again a different topic. So just don't change anything. Just click next, and then your installation will be done. Even though don't use that user which I used. And only thing that you have to use is Windows authenticated mode. Okay. And in the directories, okay. So here you have to add administrator, just click add current user and whatever the current login on the laptop. Now on this laptop, I currently logged in with my, VA my login name is VA and it is on my domain opcom. So that will be taken automatically. So you can see here, I currently logged into this mission as VA and whatever you can see here, Vijay Irua. So the same will be taken automatically. Or if you want to make someone else as an administrator, you can always add it. So as I told you, like let's say if you have, we have created SQL admin, right? And if I want to add that SQL admin as that user as an admin of this instance, I can do that. Okay. So it's up to you whether you want to make use of or not. Just click on add current user, select Windows authentication mode, add current user, and then don't change anything, testdb, max, DOP or anything. Just leave all that to default and click next. That's it. Your installation will be done. So it takes a couple of minutes and it will be installed. So basically, it's like on a single machine, you can have multiple instances of SQL Server. Sometimes what will happen, you will have you just started an organization. So usually where this SQL Server and everything will be installed, they will be installing all these things on servers, right? So sometimes, like you cannot have multiple servers, due to cost, right? So you might have only one big server where you have enough resources to run all your production, dev, and everything. So in such cases, instead of creating having multiple servers in a single server, you can have 3 instances of SQL Server: one for development, one for testing, and one for production. So at the time, as my SQL Server can be installed only with one default instance, the rest should have 2 different names, right? So first one you can install as a developer, a default instance, and the next for the testing you can install as a test instance and as a named, and production as a named, or all 3 you can install instance as a named instances. So usually your DBS will take care of all this stuff. You don't need to do installation in real time. So now the difference between, let me explain the difference between SQL Server and SSMS. Okay. SQL Server is a service, your database, and SSMS is nothing but SQL Server Management Studio. So your SSMS is a interface which you can use to connect to your SQL databases. Okay. So you can see all that whatever we have selected, the full text and semantic is succeeded, database engine is succeeded, browser and writer also succeeded, and overall the installation is successful. Now let me close this, and you can also close this.
Mr. Vijay, I have one question.
Yeah.
There is one option, right? Windows authentication and SQL authentication. Can you brief about it?
That's a DBA topic. Okay.
Okay, it will be covered in future.
Yeah, it will be covered in DBA if you are looking for DBA topic. Basically, as part of security, that will be covered in DBA. Okay,
Okay.
don't worry.
Okay.
Installation is done. You can go back, close everything. So if you want to check whether the installation is successful or not, go to your start, and here you can find a folder called Microsoft SQL Server 2019. You can see here, and here, as I told you, there is something called Configuration Manager. Just click on it, which will open the configuration of your SQL Server. You can see here, and in the SQL services on the very first one, here you can find what are the services that you installed. So we can see our SQL Server is currently running, okay, and it's currently configured with the default option, so it is not using that new login we created. So just look at these two things, SQL Server and running. We are fine with that, okay. So it is running. Now, how you connect to this SQL Server? So you have a laptop, you installed SQL Server. Now, how do you connect and create databases in the SQL Server? So for that, you need to have a interface. So that interface is nothing but SQL Server Management Studio. So just go to your Google and download SSMS. Type SSMS in Google. Okay, the very first link, download SQL Server Management Studio. And then this is the file that you need to download. This is the file that I previously downloaded. Now just SSMS setup ENU. Just right click on it and then run as administrator or open the file, which will take a couple of minutes and it will install. Okay, you don't need to do anything, just click on install, which will automatically install your SSMS. All right, so once you download it, install it, and this is how it looks. So just go to, after installing it, you can find it in your start, okay, Management Studio, or you can search for SSMS, which will open your SQL Server Management Studio. And this is the one which you can actually help you to connect your SQL servers. So even local server, or if there is a SQL server installed on some remote server somewhere in a different location, this is the only interface that you can use to connect to the databases. Okay.
Just a quick info, guys. Test your knowledge of SQL by answering this question. What is the full form of SQL? A. Structured query list. B. Sample query language. C. None of these. D. Structured query language. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
So once you open SSMS, this is how it looks. This is where it is asking you the server name. So in generally what will happen, you are develop DBAs, when you join any organization, they will share, okay, this is the server for development. And in this, you can find all your development databases. Even they'll give you login also. Like if you have to connect with SQL authentication, they'll give you a password and login name and password. Sometimes, they'll make you, a default Windows authentication, they'll make you a user, and using your local login, you can directly connect to your databases. So that's how the security part will be taken care by DBAs. So they'll just give you the server name and they'll say that this is where your databases exist for your development or production or anything. Okay. So now let's say in my laptop, I installed only the default instance, right? So to connect to your default instance, you have to use the server name, or you can also just type localhost. So localhost is nothing but your server name. If you don't know the server name or your laptop name, you can use localhost, or if you know the laptop name, you can use the laptop name. In my case, the laptop name you can see here. If I go to my computer, on properties of my computer, you can see this is my device name or my laptop name. So I can use either this name, or if you are unsure that, or simply can use localhost. Yeah. So whenever you are connecting to the default instance, you just simply use your server name or your computer name. Or if you don't know the computer name, you can use localhost as well. Okay. Now authentication, it's your DBAs will give you the login. Sometimes they'll say that okay, connect your using a login and password. They'll share the login and password. So at the time of using login and password, you have to use SQL authentication. Sometimes what they do, if you are in the same domain, they will add your domain account to the SQL Server as a login, and that time you can use Windows authentication. Okay, so you need not to worry as a developer. You need not to worry about the difference between these authentication types. Your DBAs will share all this info with you. They'll share the server name, they'll share the login name and password if it is a SQL authentication. If it is a Windows, you can just connect using your current login. Now just connect with Windows authentication. Automatically, you will be on your SQL Server instance. So this is where you can find all the databases in databases folder. And if you see, as of now, it is empty. Okay, so we are not going to talk about system databases and the stuff, but if you see on the databases folder, you cannot see any databases as of now. It's an empty instance because I just installed. Now, how do you create databases on it? It's pretty simple. So whenever you want to create a new database, now you might be wondering that why I mean, you will not be having a chance to create a new database every time. So usually in real time, what will happen? You will have one database and everyone will be working on the same database. Okay. But as a practice, and if you want to start creating a new database, what you need to do, simply go to this database folder, right click on it. Okay, let's not go with the UI, let's go with the query. Okay, so first thing what you need to do right after connecting it, just click new query. Whenever you open and click on new query, your SSMS will open a session. Okay, a blank white page will open. You can see this is a session. And observe one thing here, every session on SQL Server will have an associated session ID. So in this case, you can see the session ID is 68. Okay, and if I open another query window on the same SSMS, you can see there is a session ID 52. Now you might be wondering why there is a huge difference between 68 and 52. You just immediately, so background, maybe somebody would have already connected to the SQL Server from their machine. They would have opened a new session. So this will be handled by your SQL Server internally. You did not worry about it. Okay. So every session will have an associated session ID. And at the bottom, if you see, you can find which login is currently accessing this particular session. Okay. You can see here. And you can also see which version of what SQL Server it is connected. You can see 15.0 is nothing but SQL Server 2019. If it is 14, that is SQL Server 2017. If it is 13, then that is SQL Server 2016, like that. Okay. And here you can see the current database for this session is master database. So here you might be wondering, what is this master database? In SQL Server, there are a couple of system databases which are pre-installed by SQL Server itself. Okay, your master database is the heart of your SQL Server, which is where it is maintaining all the login details. Now, every time when you open a new session, based on your default login configuration, your session will be opened on that database. Now, in SQL Server, there are 3 types of commands. First one is the DDL. Okay. Data definition language. And next one is DML. Okay. Data modification. And third one is DCL, data control. Okay. Now first I'll just quickly walk you through what are these DDL and DML. Okay. So DDL is like any let's say when you're writing any SQL statement, if it is starting with create. So create means which is going to create an object. Let's say whenever you start with create database, which is going to create a database. Create table, it is going to create a table. Create a view, it is going to create a view. Create a login, it is going to create a login. So all these creator, it's going to define something, right? That's why this create statement will come under data definition language, DDL. Okay. And alter means if you already have a database, or if you already have a database object, okay, let's say database or database name, table or view or some login, anything, any object that already created. And if you want to alter any of its properties, you can use alter statement. So that's where alter, again, it's going to modify something, the definition of an object, right? That's where it comes under data definition language. And third one is drop. Drop is it's going to drop that. So first, let me show you how you can make use of create, alter, and drop. So first, let us start with the create statement. So as I told you, whenever you want to create a table or anything, okay, so where these tables exist, if you remember, usually you have a database, and inside the database, you can have multiple tables. Okay, multiple database objects, not only tables, like, let's say tables, store procedures, views, and the stuff. There will be so many database objects. Based on their type, we will be creating those. Now, let's say first, let me create a database. Now, if you see, we already have few databases. You can see master, model, MSDB, and TempDB. You can see the folder name. It is system databases, which is nothing but your SQL at the time of installation, your SQL Server has created these 4 databases for a different reason, okay, which we need not to worry about at this point of time, which will be, again, it's a DBA topic. Now, where actually we create the databases for users. Let's say we are creating an application, let's say some ticket booking system or some other system where you want to store the data. First, what you do, you as a developer, you will be creating a database. Now, let's say I want to create a database with some name. Let's say I want to create a database with a name called Sandbox. So how do I do that? Simply, first you have to, since you're defining a new database, right? Your statement will start with create database Sandbox. Okay. So now who is creating this database? As a user, I'm creating this database, right? That's why this is called a user database. The previous ones which are already created by your SQL Server system, that's why they are called system databases. Now we will not be using any of these databases. Those are all created by system. Your SQL Server will be maintaining and doing some stuff on those system databases. So all these sessions data will be stored on the master database. Okay, so your master database will be capturing all this info about your resources and all the stuff on the master database. So, but always keep the statements in caps, like create, alter, drop, so that it will be easy for you to read TSQL. So I always prefer to keep this select from some common syntaxes will be there, right? I prefer to keep them in caps. The moment I execute this, you can see a database has been created. Okay, now you might be wondering that where this database is created. Okay, that's again, how you handle your data. So whenever you create a database, usually that database files will be created on your file system. Like wherever you have drives, right? You have drives on your machine, right? So now in this case, I am keeping everything on my default path. So if I go to the program files and Microsoft SQL Server, since I am using default instance, if I open this, MySQL in data folder, you can see the new 2 databases that we just created. You can see Sandbox. We just created one database, right? So it has 2 files, one data file and one log file. So every database will have 2 files minimum, one data file and one log file. So that new database that we just created, you can see here, the Sandbox. This is our database, and the database files are created on our file system. Okay. So if it is your server and wherever you mention the path, they will be going and creating there. Since I did not given any extra details here at the time of creating my database, everything is going to the default location. So the default location is wherever you have configured your program file. So that will be a TBA topic, don't worry. So this is how we can create a database. Now, if you see here, and as it's a fairly new database which we just created, you will not be finding any tables there. It's just a new database that we just created, right? And no views, nothing. Now we have a database, right? So let's say I want to use this Sandbox database to store some information. Let's say I want to store information about employee. Okay, let's say we have an employee and we want to store that employee info on this database. Okay, now let's say while creating this employee table, what are the things that we need to consider first? Let's say the reason why we create the table is to store the data, right? And to store the data, let's say if we want to store the data about employee, what we need to have? First, we need to have the column names, right? So what kind of data that we want to capture for that employee? First, we want to make a list of those column names. Like in the Excel file earlier, we checked, right? So in order to store an employee info, what columns we usually maintain? Employee ID, first name, last name, let's say DOP, something like that, right? So first we will define column names, and after defining the column names, then we will be inserting data onto the Excel file. The same way, whenever you want to store some data onto a database table, first you need to define the table. So how do you define a table? Since you are creating a table, so previously when we were creating a database, we used a statement like create database and then database name. Now, since I wanted to create a database table, what I need to use? I need to use create table and then table name first. So create table, and let's say I want to capture information about employees. Let's say employees is my table name. Okay, and then as I told you, what things that we need to store employee data? We need to have the first list of columns, right? Okay, so in this case, first let's say I want to store employee ID. So this is my first column name. Now, not in Excel file, we just define the column name, and then we will not define any kind of data type. We will not say Excel, we should store only this kind of data, because Excel is fairly straightforward. When you are storing the data, you can directly open the Excel file and you will be able to store any data. For an employee ID, you can either insert numeric values, or you can also insert alphanumeric values. But in real time, usually employee IDs mostly will be, let's say, numeric values. Let's say if you decided that, I should insert employee ID only in, let's say, ID as ID, then what do you have to do? You have to tell your SQL Server that employee ID should accept only numeric values. Then you have to define a data type for that employee ID. So in this case, employee ID, I want to store only numeric values. I want to define the data type as int.
Just a quick info, guys. Intellipaat provides Microsoft SQL certification training in partnership with Microsoft. The course link of which is given in the description below. Let's hear what our customer says about the course. Did you get any promotion or appraisal in your current company after completing the course?
Yeah, I just recently become as a lead in my organization. So after completing this course, because I have other 2-3 projects I have completed with the success story. So yeah, I got a promotion.
Now let's continue with the session.
So there are different data types again. In numeric itself, there are big int, small int, bit, big int, something like that. Okay. To create a table, first what we need to, there are 3 things that we need to remember. One, table name, and then the list of columns. And we also need to remember the data types. Now, why we need to have the data types? I'll give a simple example for it. Okay. So let me put the example like this. Let's say I'm creating a new account in my live.com. Okay, let's say in Outlook, I want to create a new user. So usually, how do you create, even in Gmail also, how do you create a new user? Usually you go to the sign in. So because first time if you want to sign in, now here what it is asking 3 things. So in this empty string, you can either, using your email ID or phone number or Skype. If you have a Skype ID, using either of these 3, you will be able to access or sign into this. Now, let's say you don't have a new account. Let's say if you want to create a new one, let me just go to the create new one. Now here you can see what it is asking here. It is asking you to enter some email account. Before creating it, it is asking you to give some name for your email. Let's say this can be alphanumeric, right? Usually you can have an email ID with different things, right? I mean, you can have a combination of only alphabets, or you can also have a combination of alphabets and numerics, and sometimes you can only have an email ID with numeric values, right? It's up to you. So this is where this column can accept different. I mean, there is no restriction here that you should give only numeric value, that you should only give alphabets. So it can be combination of both as well. So this in the background, when you are storing this while creating this account, imagine that this information is going to be stored on. Let's say there is a database called live.com. On that database, you are going to store this information for this particular account. Now, wherever you are having this email ID column, which means it's going to accept all kind of data. I mean, that can have both numeric and alphanumeric. So in this case, what we can do, you can create the data type as char or varchar or varchar max. So because it's going to accept only characters. Let me give you this example. Let's see here, I want to give some user ID as combination of both. Now, obviously, you can see here, it is saying that your email address need to start with a letter. Okay, so it is saying that although I can accept alphanumeric, there is a condition that it should start with only letter, not with the number. So let me change this. I'll move this side. Now, if I go to next, you can see we're trying to create a new account, and now it is asking a password. Now again, right, passwords can be both alphanumeric, right? Which means in the background where this data is being stored in this particular database, for that password column, they might be using a data type as char or nvarchar, whatever it is. Hope you are able to follow me. Okay, there are different data types. I'll show you. Now let's say if you are going to store, you can see here exact numerics. Let's say if you are going to store only the numerics, then you can have this kind of data types: big int, bit, decimal, int, money, numeric, small int, small money, tiny int. Now you might be wondering that what's the difference? Let's say only for numerics, why cannot have only one data type? Why there are multiple data types? The reason is the way that SQL Server stores the data depends on the data type. Let's say if I am going to use let's say big int, or let's start with int. Okay, so usually if you give the data type as int, which means it can store the data in 4 bytes. When SQL Server stores the data in the back end, that int will be stored as 4 bytes, and the maximum numbers that it allows is there is a restriction. So it can only allow numbers up to a certain level. So beyond that, it cannot accept upper limits. Let's say if I'm inserting a big number, let me put it this way. I'll show you a simple example. So I'm creating a table test, and you can see I'm going to create this on the sandbox, not on the master. So if I'm creating something on the sandbox, there are 2 ways that you can do. So always mention use. Now I want to do something on the sandbox, right? So start like this, use, and then give the database name, select the sandbox. Okay, now you can see the moment I execute this along with go means go to the next one. So when or you can remove the go also, no issues. So use sandbox, you can see the moment I use sandbox, my connection will change to sandbox. Okay, not my connection, my session will change from master database to sandbox. So now you can see here, first I'll give you an example between the data types. Okay, first I'm creating a small table, create table. I'm giving the name as, let's say, table 1. Okay, as I told you, every table should have columns and data types, and so you have to define. Let's say I'm creating this table with only one column. Let's say column as ID. Okay, and I'm telling this ID column should accept only int values. Okay, and also I'm saying that this column should not have null values. Okay, then in that case I have to say not null, which means this column cannot be null. If you try to insert empty, it will not accept it. If you say null, it can accept null values also. Okay, so that's how you will tell your SQL Server how you have to define your data type. Now you might be wondering that how do you know that which data type that I should use? Now all this comes like a requirement. Your client will tell you. Let's say if you are defining or if you're building a new project, a new database, whoever is interacting with your client, your project managers or your immediate team module lead or someone, they will interact with the customer. Okay, customer will tell you that, okay, or your development team will tell you that, module lead will tell you that, okay, I wanted to create a table. Okay, that table should have these many columns, and he will give you the column names also. And then he will also tells you that, okay, this column should accept numeric values. Then you will ask him in return how many values that this column should accept, whether this should accept a bigger number or is it going to accept only one number. Let's say if he says that, okay, this is going to have only one number, like 0 1. Let's say there is something called status where you want to store only 0 for failed and 1 for success. So on across all the data you will be storing only 0 1 0 1 1 1, something like that. In that case you can create that data type as bit rather than int. You can create it as a bit, because when you create the data type as a bit, your SQL Server will be storing the data as only 1 byte in the background. So you will be able to save some storage, and also it will benefit you in terms of performance as well. So this, don't worry, this will be given by your module leads or whoever is going to handle your project requirements. They will tell you all this. They'll say that, okay, this is our table name. They'll simply give you this requirement as this. They'll say, okay, this should be the table name, and this table should have these columns, and this should be the data types. Or if they ask you to define the data types, then you will ask them in return, okay, for employee ID, or is it going to be a numeric value, or is it going to be a combination of both numeric and alphanumeric? If they say that it should have alphanumeric, then what you do, you will define the data type for that employee ID as character. Okay, so I mean, that's what I'm saying. Yeah, although you can see there are multiple, only for numeric you can see there are multiple here, around 9 different data types are there. Now you will not be using all that. Okay, so based on your requirement, you will be choosing the right one. Now let's say if I am going to have only 1,000 employees in my employee table. Imagine this. Let's say I'm going to have an employee table, and I know that at any point of time my company cannot have more than 10,000 employees in future. Okay, then what I'll do, since I'm going to start from 1 to 10,000, right, which I can store across int. So if I go ahead and define big int there, what will happen in the background is, if you define the data as big int, your SQL Server will be storing the data in 8 bytes. Although you're inserting one number in the background, only to store that one number, your SQL Server will reserve 8 bytes. So you'll be losing space of 7 bytes. In terms of performance also, that will degrade the performance. So since you know that you're going to store very small numbers, small limits, then what you can do, you can go ahead with only int. Now if somebody says that, okay, I should have an alphanumeric, then what I'll do, and if that alphanumeric ID cannot go beyond 5-6 characters, then what I will do, I will define that data type as char6 or char7. So which means that you're setting a limit for that character storage. So first I'll show you a simple example. Okay, so I'm going to create 2 columns. First column with ID, column name is ID, or let's call the column name as employee ID, and it's going to have the data type as int. And the second column is going to have a column called name or first name, and the data type is, let's say, character 5. Okay, the reason I'm using here, you can see for these things I'm defining character, and then since it's going to be a string, I know that I'm going to store some characters, then I have to define the length, how many characters I'm going to store. So that's why you have to give a number here. But for numeric data types, the length is fixed. Your SQL Server knows that what is the storage and what is the fixed length for these numeric data types. That's why for numeric data types, you don't need to give the length. But for these characters and nvarchar and other data types, you have to define the length of that string as well. Which means that here I'm saying my SQL Server, when I'm trying to insert data into this first name table, it cannot accept anything beyond 5 characters. Okay, that's what the restriction I put as of length. Now you can see there are 2 columns. One is employee ID, which accepts only int. Okay, and the second column name is first name, which can accept characters. So characters means it can accept both alpha and numeric values. Okay, now so you can see create table, and then I'm starting with an open bracket and then defining my column names with a comma separated along with their respective data types, and then I'm closing that with a close bracket, and then semicolon is to say that, okay, this is the end of this particular command or this statement. Now what I'll do, highlight this entire statement, first do the syntax check and then execute it. Now you can see this table is executed successfully. This command is executed successfully. Now we have created a table with 2 columns. Now if you go to the sandbox database, if you refresh it, you can find, since I created this database table on sandbox, you can see here. So before you create anything, make sure that your connection is on that database. Now if I create it on some other connection, the table will go ahead and create on that database. So here I created on the sandbox. Now if I refresh my database, right click on it and refresh it. If I go to the tables, you can see the new table that we just created. And if I expand this table, you can see in the columns, those 2 columns that we just created. You can see here employee ID, int and null. Null we will discuss. And first name, it is accepting 5 characters. Okay. Now let's try to insert some data. Okay. So how do I insert the data? To insert the data, we have to use DML language, which means data modification language, where insert, update, delete, those are the DML, which means when you want to modify the data, you will be using the modification can be an insert or modification, update or delete. All right, so let's quickly check this. Now we have created this table, right? Now let's say we want to, as an employee ID, let's say if I want to insert something onto this table, let's say we want to insert the very first record. So how do you do that? Insert into, this is the select SQL statement to insert the data. Now I want to insert the data into this table 1, right? So first we have to give the table 1, the table name. So automatically that will come if on SSMS, it has IntelliSense enabled. It will automatically list out the tables available on the database. So highlight and select it. If it won't come, type the name. Okay. So if that object is not there, SQL Server automatically tells you that the object is not there. So insert into, give the table name. And then since I want to insert the data onto the table 1 on both the columns, right? So first give the column names. So I want to insert the data onto employee ID and first name. So I have 2 columns in the table, and on both the columns, I want to insert the data. So insert into table 1 and then give the column names. You don't need to give the data types here. Just give the column names alone, and then values. So in the values, then you will be giving the values for each individual columns in the same order. So here I will be, let's say my employee ID is going to be 1. Okay, always give the data in single quotes. And then let's say my first name is Vijay. Okay. Now close bracket. Now if I execute this, you can see I'm trying to insert data for both employee ID and first name. And the same order, my employee ID is 1 and first name is Vijay. So the data that I'm going to insert, I'm going to give it in the single quotes with comma separated as in the same order as our column names. The values will be in the same order. Okay. Now execute this. One row is inserted. Now you can see it accepted because you're saying that employee ID should be integer. Okay, so whatever that we are inserting for employee ID, it is a numeric value, right? That's why it accepted it. And the characters, first name I'm inserting characters, right? The SQL Server accepted it. Now let's go ahead and read the data. So how do you read the data in SQL Server? Select star from table 1, which means I'm trying to read the data from the table 1. Now, if we go execute the statement, select star from table 1, you can see the data that we just inserted. 1 is the employee ID, Vijay is the first name. Now, let's insert one more record. Okay, this time, let's insert characters for int and see, employee ID and see what will happen. Okay, so again, we are inserting a second record, right? So I'll say insert into, give the table name. And since we're inserting the data for both the columns, let's say employee ID and first name, employee ID, comma, first name, and the values that we are going to insert. So give the command values. And here, this time for employee ID, I'm trying to insert some alphanumeric, okay, or numeric. First, let's try with the alphabets. So I'll give ABC, okay. And then here, I'll give a name like, let's say Raz, and let me execute this statement. So since we define that, you can see here conversion failed when converting the varchar value ABC to data type int. Obviously, it won't accept, right? You already, at the time of creating a table, you told SQL Server that employee ID should be only int value, numeric value. Now here you are trying to insert alphanumeric, alphabets. So obviously your SQL Server will not accept it. Now let's try with alphanumeric. Yeah, now I'm trying to insert one more record this time. Okay, the previous one is not inserted. If you go ahead and check, because there was an error, right? So SQL Server if there is any error, then your automatically SQL Server will roll back that change. So here, because of that error, SQL Server did not accept that, right? Conversion did not accept. So basically, that record wouldn't have processed. If you go back and check, you can see it still have only one record. This is how your SQL Server or your RDBMS maintains the consistency. So they will follow, there is something called ACID properties. So basically, if there is any error, SQL Server will not carry forward the transaction. So here in the previous transaction, you can consider this piece of work as a transaction. In the previous transaction, since there was an error, SQL Server did not process the record.
Just a quick info, guys. Test your knowledge of SQL by answering this question. Which of the following is not a valid aggregate function? A. Count. B. Sum. C. Max. D. Compute. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
Now, let's try with the last, this one. Even here, I'm trying to insert alphanumeric, but my employee ID accepts only int, right? So obviously, this one also will give the conversion error. Okay. Now, what we do? Let's change this. So I'm going to have one more insert statement, and this time I will be using ID as 2, exactly as numeric value. And here in my in my name, I will try with more characters. Let's see what will happen if I try to insert a bigger name. So I'm trying to insert some like A, B, C, D, E, F, G, H, I, J. Okay. Now let me insert. Now you can see a string or binary data would be truncated in table sandbox, column first name, truncated values A, B, C, D, E. You can see it is accepting now only the first 5 characters. The reason is at the time of defining my data type, okay, for the first name, I mentioned that it should be characters, but it should accept only 5 characters. Okay. So this is how we can put a restrictions at the time of defining tables. So now what we do, we'll focus more on the DDL statements rather than DML like insert and update. So as I told you yesterday, DDL is nothing but data definition. So where usually this create alter, drop. So these are the statements that whatever the statement starts with these commands called DDL statements, wherein they are going to define an object, and they can you can use the same alter statement to alter an existing object, and then if you want to drop an object in a database, or if you want to drop a database, you can make use of drop statement. So first, let me start with a new database again. So how you can actually use create to create a database. So the one which we already have the sandbox, right? So let's drop that first. So before SQL Server 2016, in order to drop an existing object, you have to check that existence of the database in the master database. Now, from SQL Server 2016 onwards, they made it very easy. So whenever you want to drop any object, and if you want to check whether the object exists or not, you can use a command called if exists. So let me quickly show you. So now the sandbox is already exists, right? So if you want to if you want to drop an existing database and create a new one, how you can do that is drop database if exists, and then give the database name. So here the database name is sandbox. Now what this command does is, first it will check whether this database exists or not. Okay, let me comment this 3. So this statement, what it is going to do, actually, this is going to drop a database. However, it is first going to check whether the database name with sandbox is already exist in this instance or not. If it exists, then it will drop it. Okay, if it won't exist, then it will not do anything. So this if exists is nothing but it is checking for the existence. Now what this does, the moment I execute this, since the database is already there. However, if you look at the error, what it is saying that that cannot drop the database sandbox because it is currently being in use. So why it is currently in use? Because if you look at my current session 65, it is currently opened on sandbox database. And also there are few other sessions already opened on the sandbox database. So let me first go ahead and change my current session to something else. So because the session is already open on the sandbox, you will not be able to drop it. So it's always better to close all the connections and then drop. So usually when you want to drop the database in real time, instead of doing a drop database statement, you can also just right click on the database, go to delete. Okay. And here there will be an option you can see at the bottom. So this option is nothing but when I say, when I check this, the last one, close existing connections. If there are any existing connections open on this database, your SQL Server will close all those connections and then it will drop the database. You can also script this out. So you can see this is how it looks. The script looks like this. So first it is checking for the backup history. Then if there are any connections, it will check those. Close all the connections. That is not been scripted out, but usually all that been closed, and then the database will be dropped. So let me just cancel this. Now I'm going to execute this drop database statement. And now you can see connection I changed to master. Let me execute now. Now you can see the database, the command has been completed successfully. And if I refresh my SQL instance, you can see the database has been dropped. Now what we do, let's create a new database with a different name. Okay. So how do you create a database? Again, you have to use the same DDL statement. So in these 3 DDL statements, create is the one which we can actually, using which we can actually create databases and database objects. So here to create a database, the statement is like this. Create database. Since you are creating a database, so you're going to mention like create database and then the database name, testdb. So here I'm creating the database as with the name testdb. So the moment I execute this, a new database with the name testdb has been created. If you refresh your databases folder, you can find it here. Okay. Now what we do, let's go ahead and create some tables in this existing database. So let's say on this test database, I want to create some tables. Okay. Now how do you create a table again? Again, you have to create a table, you have to make use of an existing, you have to make use of the DDL statement, which is create, right? So first we'll have to change our connection to, since I want to create a new table on testdb, so I'll have to change my connection to testdb first. You can see intelligence is not yet coming. So what you do, press Ctrl Shift R on your keyboard multiple times. So what this does, it will update your SSMS, which will automatically identify if there are any new databases. It will be able to identify all that. That it's not updated yet. Yeah, that would be no issues. So I'm saying use testdb and then go. So go is like I'm just selecting only that use testdb and executing. You can see after I execute, you can see this connection will change to a testdb database. Now it is on master. Automatically the context of this connection will be changed to testdb. You can see now it is changed to testdb. Now I can start creating objects in the testdb. So let's say first let me again use a create statement to create a table. So create table. Let's create a table with the name employee. Okay, just create a name with the name employee. So this is our table name. And the difference between the earlier create statement and this statement, earlier we were creating a database. That's why we mentioned create database. And this time, as we're creating a table, we're mentioning create table and then table name. As I told you, your table requires columns and then multiple. It will have multiple columns, and then we should also have a data type for each column, right? So we will start with that. Now, let's say I want to create the first column as employee ID, and I would like to keep the employee ID as, let's say, int. And then if you don't specify null or not null, that means, if you don't specify anything about null, then by default, your SQL Server consider that as null. And if you specify something explicitly, now let's say I want to make sure that there should be no employee ID in the table. Like let's say if you're inserting data for employees, there should be no record without an employee ID, which means that you are saying that every employee should have an employee ID. So in that case, what I have to do, I'll have to make sure that this employee ID column will have data always. So I'll say not null, which means it's not going to accept any empty values. Okay. Now let me just create another column with the first name, and this time I'm going to use char 10. And again, if you want to make your first name as not null, you can actually use again not null. Or if you just leave it by default, that will consider as a null, which means that first name column can insert null values. Okay, let's do with the null. Okay, and then let's have a last name, another column with same char 10. Okay, and this is also I'm explicitly mentioning null here. For the above one, I'm not explicitly mentioning it. Okay, even though if you don't mention anything, by default, the SQL Server consider that as a null. Last name, and then we're going to have one more column. Let's say username. Okay, wherein again I want to have it. Let's say this time I want to use varchar 10. Okay, now I want to make sure that every employee will have a username. Okay, now so these are the 4 columns that I wanted to see on this table. So the moment I select all this and execute, all right, now if you see here, if I go to the database and refresh, and here you can see we have created a new table employee, and here you can see in the columns for employee ID, we explicitly mentioned not null, right? So that's why it captured not null. However, for the first name, if you see here, I did not mention anything. But by default, if you don't mention anything, your SQL Server is going to allow null values into that column. You can see here for first name, although we gave the data type as char 10, and you can also see null. We did not define anything here, but still the SQL Server consider that as a null. The default is null if you don't specify anything. But if you want to make that column, not null column, then you have to explicitly mention that. Okay. All right. Let me show you the difference between this null and not null. Okay. Now what I'm going to do, I'm going to insert some data. Okay. So to make you understand what is null and not null. So let me quickly insert some data into this table. So now I'm using a DML statement. So the insert is like we already define a table. In order to insert the data or update, delete, we have to make use of DML statements. What are those DML statements? You can DML statements like insert, update, delete. These are the DML statements. Okay. So now I'm making use of insert to insert data into an existing table. Here the table name is insert into. This is the statement to insert the data, and then you have to mention the table name. So here the table name is employee, and then in what columns that you wanted to insert the data. Now here I wanted to insert the data into all the columns. Let's say there are 4 columns, right? I want to insert the data into all columns. So let's do this. So I'm going to select each column individually, employee ID, first name, last name, username. You can look at the statement here. I mentioned all 4 columns, which means that I'm going to insert the data into all columns into the table. And let's start with the values. So let's say first employee ID 1 and employee, let's say Vijay, and his last name Y, and then his username, let's say this one. All right. Now you can see, you can also look at the order for employee ID. You have to insert the values in the same order as your column names that you define in the brackets. Okay. Now I'll go ahead and execute. Let us go ahead and read the data from the employee table. Here you can see the new record that we just inserted. Since we inserted value for all the columns, you can see all the values are inserted. Now what we do, let's insert values only for few columns, not for all columns. Let's insert values for only few columns. Let me write a statement like this: insert into, okay, table name employee. Now this time what we do, let's insert data only into employee ID and first name. Let's ignore inserting data into last name and username and see what will happen. Okay. So I'm inserting data only into employee ID and let's say only the last name, not even the first name, employee ID and last name. Since I'm inserting data into only two columns, so obviously I have to give only those values. So here my employee ID is 2, let's say, and last name is, let's say, A. Now you can see the difference between that above query and below query. In the above query, I was inserting data into 4 columns. That's where you can see 4 values here in the same order as your columns. Here, I'm inserting data into only 2 columns. That's why you can see only 2 values. Now, you might be wondering that what will happen to other 2 columns, like first name and username. What will happen is it will try to insert null, although you are not inserting any data. So what SQL Server does in the background, it will try to insert some null value into this. Now, if your column is going to accept null, then it will that statement will execute. If not, it will fail. So let me try and execute the statement. You can see the difference now. The moment I execute this, you can see it is saying that cannot insert value null into column username. So it is telling only, although that you are inserting data into employee ID and last name, and the remaining columns are first name and then username, right? So first name it is accepting because you already told SQL Server that it can accept nulls. But for the last name, sorry, username, since you mentioned not null, your SQL Server is not accepting if you're trying to insert the data without any value there. Okay, that's why this statement has failed. Now what I need to do in such cases, this is how your SQL Server ensures the integrity. Now, since you already made it clear to SQL Server that whenever somebody is inserting data onto this table employee, it should always accept values for username and then employee, because both of these columns are defined as not null. So now what I'll do, I'll go ahead and add username here. And let's say for username, I'll add some record here. Let's say ABC. Okay. Now if I go ahead and insert, this second record will be inserted. Although you are not giving any data for first name, since your first name can accept null values, your SQL Server successfully executed this statement. Now if you go back and verify the data, select star from employee table. Now you can see, although we inserted only 4 rows, you can see here, data into 4 columns. Employee ID we have inserted 2, and last name we have inserted A, username we have inserted ABC, but we did not insert any value for first name. Still, since your first name column accepts null values, that's where your SQL Server inserted null value into this. So this is how you can control your data. So based on that, along with your data type, you have to also need to mention whether that column will accept null values or not. So this is about nulls and not nulls. Now, let's say you already have a table, right? Okay. Now, let's say to this existing table, you want to add one more column. Let's say you want to add a column called phone number. Then in that case, what you do, or let's say you want to make even the first name mandatory. That let's say you want to convert, you want to make sure that even the first name, your SQL Server should act. You have to ensure that every record should be inserted during the insert statement. So which means that you want to make sure that every column should have not null. Now what we need to do, let's say you want to make sure that all the columns should, when you are inserting the data, you should insert the data for all the columns. So in that case, what you need to do, basically you have to again make use of another DDL statement, which is alter. So now we are trying to alter an existing object, right? So let me show you how we can alter an existing column as well in an existing table. Alter table. So let me just copy that table name employee And then let's say now we want to make sure this first name was also not null, right? So what we have to do, there is an existing column which we want to alter it, right? So after alter statement, we also need to mention alter column. Okay, and which column that I want to alter? Existing column, first name. So copy the column name, and then I want to use the same data type. However, I want to make it not null. So I'll say not null. Now let me go ahead and execute. Now, do you think this statement will execute? It won't execute. Let me show you the reason as well. So I'm trying to convert the existing column as not null. Okay. So previous it was null. Now it is. I'm going to convert it to. I'm going to alter it to not null. Now if I execute this, it is saying that cannot insert value null into a column f name. If you look at the statement, we are not inserting anything here. We are trying to alter an existing table. But why this error is coming? Because already there are 2 rows in the table, and out of 2 rows, one of the column is one of the row is already having a null value for first name column. So without updating that, your SQL Server will not accept it. So it is clearly saying that whatever the column that you are going to alter to not null, that column is already having data of null. So that's why it's not accepting it. Now, how do I change that? So first you need to update that record. Okay, so let's skip that updating first name to not null. Let's focus on last name. Okay, so I'll try to alter table employee. Alter column last name. Okay, so say I'm not going to alter any data type, so I'm going to use the same data type. So let's say cat n, and this time, since I want to convert that from null to not null, let's select that not null. Now if you go ahead and execute, this will execute. The reason because the existing 2 records on the table, I mean on the last name already we have some data. There is no null data. Now it has been converted to not null. If I refresh the column list here, you can see. So before refreshing, you can see here, it was null before. Now after this alter statement, I refresh it. Now you can see this has been changed to not null. So this is how we can actually alter an existing columns on the database, on a table. Now let's say we discussed like how you can alter an existing column, right? Let's say if there is a requirement to add a new column. Let's say tomorrow, like someone comes and says that okay, on this employee table, let's have another column where you're going to capture that employee's phone number. So in that case, what I need to do, I have to add one more column, because as of now, if you see, there are only 4 columns and there is no column which can capture the phone number. So we need to add one more column to the existing table. So for that, you cannot drop a table and recreate it, right? Because already there is some data in that column, right? I mean, on the remaining columns, you can see there are already 2 records, right? In real time, your existing table might have already millions of records. So you cannot simply drop and recreate everything. Since you want to add a new column, what you can simply do, just use an alter statement to add a new column. So let me show you how we can add a new column. Alter table employee. And since I want to, here we're not going to alter an existing column. We are going to add a new column, right? Simply use add. And so since I want to, now you don't need to explicitly mention column there. Just simply say add, and phone number is my column name. And in phone number, I want to capture numbers, right? Let's say I want to capture big int, okay? And again, I want to make sure this phone number should be not null. Now, simply alter table name, and you're going to say add, and then column name and the data type for that column, whether it should be null or not null. Now, when I execute this, then now it is saying that alter table only allows columns to be added that contains nulls or have a default definition specified. Now you can see the reason why it is not accepting this, because now what will happen? Let's say we already have 2 records, right? Okay, you can see we already have 2 records. Now what I'm trying to do, I'm trying to add one more column, which means it has to accept null values for an existing column, right? I mean for the existing rows, right? There are already 2 rows, employee 1 and 2. Now if I want to add one more column called phone number, then in that case, what will happen? For that existing 2 rows, it has to insert null values, right? But here, what I'm trying to do, I'm trying to make it not null. That's why your SQL Server not accepting it. So you can only add columns with null. Okay. So whenever you want to add a new column, always make sure that you add that with only null, not null. Or what you can do, I mean, if you want to make it a not null, first add it as a null and update the data and then make it not null. That's the other way of doing it. So let me just show you how you can add it. Click execute. Now you can see a new column has been added. If I refresh my columns, here you can see this table is having 4 columns. Sorry, 5 columns. The new column, which is a phone number, has been added. Now, if you go back and read your table, select star from table name, select star from employee. Now you can see there is a last column, phone number. So for these 2 existing records, it has inserted by default null value because you just added new column in between, right? So for previous existing data, it has to make it null. Okay, now how you can insert the data? Let's say if you want to update an existing record, that we'll discuss later on. Now let's focus on this. Now let's say if you want to insert one more record, even to the, let's say third employee, you have to do like this: insert into, you have to give the table name employee, and then you have to explicitly mention all the column names. Now look at this. Sometimes you don't need to, let's say if you are going to insert the data for all 5 columns, here you don't need to explicitly mention any column names. You can leave it as it is, like you can leave it with 2 close brackets, and you can simply insert values here. So for the first, but you have to ensure that you insert the data in the same order as your column names. So here the first column is employee ID. Okay, so 3, and then let's insert one more. Let's say a new employee with the name Raj, and then his first name is Raj, and what is the next column? Last name. So let's have the last name as R, and then the username is okay, and then we want to insert even phone number this time, right? So as it is a small int, you don't need to put it in single quotes, or it's always better to put the data values in single quotes. It's up to you how you want to do it. Now you can see. Okay, all right. Let me execute this. Okay, now we can look here. It is saying that parameter supplied for object employee, which is not a function. You need to remove this. So you are directly inserting the data into all the columns. So you don't need to explicitly mention the column names. So even by doing this also, you will be able to insert the data. So here I did not mention the column names because I am inserting the data into all the columns. Okay. So if you are inserting the data into all the columns, need not to mention the column names in brackets. If you are inserting the data a specific set of columns, then mention the column names and try to insert the values in the same as your column order. Okay, now this is how you can actually insert the data into all the columns. Now let's say later on you decided that okay, you don't need to have a username on this username column on this table. Let's say you want to get rid of this username, you don't want that column anymore on this table. So how do you do that? This time we already discussed, like first 2 statements we discussed how you can create and how you can alter. Now what the third requirement is, I want to get rid of this column called username. I no longer need it. So in that case, you have to drop that column, right? For that, what you need to do, you have to use alter statement, alter, because you are drop is like dropping the whole object. Since you are altering an existing object, so that even the dropping of a column will comes in under altering object. So you have to use like this: alter table. Let me copy the table name. Alter table employee, and then drop. You have to explicitly mention what you want to drop. Let's say drop column, and give the column name. So here column name which I want to drop is username. Just copy it and mention that. Okay, you don't need to mention the data type or anything because you're just dropping that column, right? You're not going to define it. So you can see now that column is being dropped automatically. Okay. Now, how do you drop a table? Let's say I even if I go and refresh my columns, you can see that the username column has been now dropped from the database. Sorry, from the table. Now from this database, I want to even drop this table. I don't want this employee table. So in that case, what you can do, you can make use of drop statement. So that is like drop table. You just need to mention the table name, which is going to drop the table. Now, if I go and refresh my database, you can see that the table, under the table, you can see the employee table has been dropped. So when you drop the table, all the existing data also will be dropped because your data is associated with the table, right? When you drop the table, the data that is there in the table also will be dropped from your database. That's where we have to be very careful, especially when we're dealing with drop and create like delete and drop, that kind of stuff. All right, now so I'll quickly show you something about select. Okay, so what I'll do, I'll go ahead and create this table again. Okay, so let's create the table and let's insert the data again, and then I'll show you how you can make use of selects. So I'll give you a little basics about how you can retrieve the data from an existing table. So what I'm going to do, I'm going to create the table again, which we dropped. So the table is been created. You can see here employee, because I used the same create statement which we used before. Now let me go ahead and insert the data into this existing table. All right, let me also add column. So I'm using all these alter statements, which is going to alter all the existing data. You can see here. Now we have 5 columns here. Okay, and let's go ahead and quickly insert some data. Now, so we have created the table, right? Now let me go ahead and insert the data. You can see as of now we have inserted 2 records, and I'm going to insert one more record here. Okay, it is saying that there are fewer columns. Yeah, because now we have one more column added, that is a phone number, right? So let's go ahead and insert. It has to have a first name here. Okay, and then last name and also phone number. I hope I went add it. Let me add it. So I added. Okay. Since your phone number can accept null values, so I can insert null here directly. Okay. Now let me insert third row. All right. Now I'll open another session. Okay. So here we have a table called employee, right? So if I go ahead and read the data from employee table, you can see select star from, if you give the table name, if you execute this is going to give you all the data in the table. Okay. Now we're actually discussing on select statement. So observe something here. So here what I did, if you look at the statement, I mentioned select and then I mentioned star. So this star is nothing but you are telling SQL Server star is like I want to retrieve the data for all columns. Let's say if the table is having 10 columns, instead of mentioning each column name, what you're saying that you're simply telling SQL Server that select star from means you are telling SQL Server to retrieve data for all columns. So that's where when I use select star, it is giving the data for all 5 columns. Now let's see if you want to retrieve the data, like if you want to retrieve only employee ID, first name and last name from this table. So how do you have to write it?
Just a quick info, guys. Intellipaat provides Microsoft SQL certification training in partnership with Microsoft. The course link of which is given in the description below. Let's hear what our customer says about the course. Did you get any promotion or appraisal in your current company after completing the course?
Yeah, I just recently become as a lead in my organization. So after completing this course, because I have other 2-3 projects I have completed with a success story. So yeah, I got a promotion.
Now let's continue with the session.
Select from employee, and then before from start giving the column names that you want to retrieve. So now in this case, I want to retrieve employee ID and first name.
Just a quick info, guys. Test your knowledge of SQL by answering this question. What is the full form of SQL? A. Structured query list. B. Sample query language. C. None of these. D. Structured query language. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now let's continue with the session.
Last name. Now this query, you can see if I execute, this query is going to give us data only for 3 columns. Although this table is having data for 5 columns, but while reading the data, I want to read only the 3 columns. So whatever the columns that you mentioned in your select statement, the SQL Server is going to give the data for only those 3 columns. Now, if there are, like let's say if your requirement is to fetch all the data for all the columns, then you can make use of star. Okay. Now, without star, let's say if you want to pull the data for all the columns, what you need to do, you have to mention all the column names in the same order. Now, let's say in your select statement, instead of if I start writing like this, let's say first from employee, I change the order of the columns. Let's say first I want to fetch the first name, so I'll give the first name in the first column, last name, and then let's say if you want to fetch phone number. Okay. Now you can see first you are fetching the phone number, sorry, first name, and then last name, and then phone number. Okay, so this is how you can make use of columns in your select statement. So if you want to retrieve the specific columns, you have to explicitly mention those column names. Or if your requirement to fetch the data for all the columns, you can make use of star or asterisk. Okay. Now, how do you apply filters? Let's say you already have data. Now, if I again do select star from employee, as we know that this table is having 3 records, right? Okay. Now let's see. I'm trying to find information for employee ID 3. I don't want to read all the data on the table. Let's say imagine that if your table is having 1 million records, okay, or 1 lakh records, 1 lakh employees are there. Now, if your requirement or if you're searching for one specific employee, so how you can do that against a database or table is, so you can use select statement. So in your select statement, after table name, you have to mention where employee ID equal to, let's say I'm looking for employee ID 3, then employee ID 3, which is going to give me only that particular record. So your database, your SQL Server, what it does, based on your where clause, the condition in the where clause. So the condition here, if you see, I'm trying to search for the data for employee ID 3. So your SQL Server will fetch the data only for that particular employee ID 3. The remaining it will not show you. Although data will be there in the database, but since you are searching for only one particular record, so based on that, you filter in the where clause, your SQL Server will be fetching only that particular record. Okay. Now let's say, how do you apply multiple filters? Let's say I want to fetch data based on employee ID as well as let's say first name, or let's say I'm looking for the first name. First, let us do this. I'm looking for first name. In this case, select star from employee where first name equal to Vijay. So now what it is going to give me? It is going to give me the record. So here it is automatically giving me the record wherever the first name is Vijay. It is giving me all the data. So he has employee ID 1. Now let's say if you want to put filter on 2 columns. So in that case, let's say where first name equal to Vijay and let's say employee ID equal to 3. Now if you observe something here, I applied 2 filters here. One is first name, other one is employee ID. Okay. Now if you look at the first name is Vijay, employee ID is 3. What is the employee ID of Vijay? It is 1, right? However, here we're trying to search for the data for employee ID 3 and first name Vijay, and in between there is something else you need to observe. That is AND. This is the operator, that AND operator. Now what you are telling SQL Server to check that, this condition is on both the columns, and you are telling SQL Server both filters have to be true. Like AND means it has to have a first name Vijay, and if the employee ID is 1, if both the conditions are true, then it will retrieve the data. In this case, you can observe first name Vijay is there, but for Vijay employee ID is not 1, which means 1 is going to be, the first condition is going to be true. However, the employee ID for this Vijay is not 3, right? So the second condition is going to be false. So in this case, your SQL Server will return no values. So it simply is not returning any values. The same query, if I go ahead and make both conditions true, in this case, first name Vijay and his employee ID is 1, both are true, right? Now, in that case, what SQL Server does, it will give you the exact record that you are looking. So your SQL Server will be able to do all these things in the background without, you don't need to worry. All you need to just pass the filters, and if those filters are matching, or if you, based on the operator, if those filters are is going to true, then evaluate true, then it is going to give you the data. So same statement, the above one, instead of AND operator, let's use OR. So when I say OR, it means that either of these conditions has to be true. When we say AND, both conditions has to be true. Then both conditions has to be satisfied. Then you will get the data. In the second case, what I'm doing, I'm saying first name equal to Vijay, which is true. Employed equal to 3. Obviously, for Vijay, employed is 1. But here, the difference is the operator. Here I'm saying R. Either of the conditions has to be true. Now, in this case, both can be true. I mean, Vijay has, there is a first name Vijay and there is an employee ID 3. Now, what it is going to give me, since I'm going to evaluate two conditions as true using R, it is going to give me 2 records. Now, in this case, if you say employee ID 4, obviously it is going to return only one row because the second filter or the second, after this operator or the second filter is going to look for employee ID 4. Obviously, that record is not there in the database in this particular table. It's going to return only whatever is going to be true. That for that particular true, filter, it's going to retrieve the data. So this is how you can make use of filters in your select statements. So this is one of the things that how you can actually retrieve the data from an existing table. Okay, now let's move on to the next topic, which is a DML statement. Let's say you already have a table and you want to update the data or delete the data or insert the data. Okay, so what we do again, we already discussed, as I told you, these are the DML statements: insert, update, and delete, right? Now let's discuss like how we can insert the data. We already discussed a little more on insert as well. Like if you want to insert the data for all columns, you have to explicitly mention all the column names, and then your values has to be in the same order as your column names. Okay. If you, let's say if you give first name, last name in a reverse order, then if you give these names in it, then the data will go to that particular order. So always make sure that in your insert statement, if you have multiple columns, then the data should be in the same order. Okay. So let me show you how we can update and then delete the existing data. Okay. So I'll do one thing. I'll open another session. So now if you see, we already have a table called employee, right? Let us first go ahead and read the data from employee table. Okay, so I think it has 3 records that we inserted. You can see there are 3 records, 1, 2, 3. And every record, if you look at employee ID 1, first name is there, last name, username, and phone number is null. Okay, someone asked me like if I insert and delete, what happens? So first, let us look at the first. There are 3 DML statements, right? One is insert, which we already discussed. One more is update, how we can update the data, and third one is delete. Okay, so let's first update the data. Now let's say if you look in this existing data, employee ID 1 doesn't have a phone number. Okay, he doesn't have a phone number. Now you decided to update his phone number. So how do you do that? You have to make use of update statement. Update, then give the table name, which whatever the table that you want to update. Now here, what I wanted to update on this employee table, I want to update phone number. Okay, so then you will be using set and give the column name, phone number, and give the value. Let's see if I want to update the phone number of, let's say phone number to this particular value. Okay, now the requirement is I want to update the value for employee ID 1, right? So you have to explicitly tell your SQL Server where employee ID equal to 1. Now you might be thinking that what if I don't want to mention where? Now in this case, what will happen is if you execute the statement, all the data, the existing the date, all the columns, on the phone number, all the rows will be updated with this particular number. So if you don't mention where clause, which means you're telling SQL Server, go ahead and update the phone number for all rows, all existing employees, go ahead and update the phone number to this particular record, value. So which is going to update the entire employee column. Now, if you want to explicitly mention, update one particular employee ID, then you have to use that in the where clause. You should say where employee ID equal to 1, which means this value will go ahead and update only to employee ID 1. Let me show you. Now one row has been affected because we were only updating one record, right? So if we go ahead and read the data back, select star from employee. Now here you can see earlier it was null, a number has been updated here. Okay. Now again in the where clause you can put multiple conditions. let's say if you want to update the employee ID for both, let's say I want to update the employee ID for 2 as well as, let's say, okay, let's do this. So for employee ID 2, I want to update his first name as well as his phone number. So in that case, what I need to do, again, same update statement, update employee set. Now here, two columns that you want to update. One is phone number, other one is the first name. So let's first update the first name equal to, let's say, okay, and then you want to update the phone number, right? So, and you have to use a comma, okay, and phone number to some value. Let's say you can use something. Since you want to update this for second employee ID, where employee ID equal to 2, which means it will go ahead and update the record for employee ID 2. It's going to update the first name as well as the phone number. Now, if you go back and check your table, here you can see the second record, which was A, and the first name was A, right, before. Now it has been updated to Dan, and then you can also see the phone number got updated to the value that we have given. Now, let me show you this. What happens if I don't use where clause? Okay, let's go to the previous example again. Update table name, employee, and set. Let's say I want to update phone number again, and this time I'm updating phone number with a different series. You can see some random phone number. And here I'm not going to use where clause. Okay, observe here, there are 3 different phone numbers here, right? Now in my update statement, I'm not using any where clause. I'm simply saying update employee, set phone number equal to so and so. And if I execute this, what happens is all the data in the phone number column will be updated to this particular value. So if you go back and read, you can see all the phone numbers are updated with the value that we tried above. You can see all have been updated with the same value. So that's where when you're doing updates, if the update is with the specific to one particular record, make sure that you use that filter, using where clause, you can update to that specific employee. If you don't use where clause, what will happen? That whole column data will be get updated with value that you're going to update. Okay, now let me show you deletes. So how you can make use of delete. Let's say set is not a data type. Here set is like a command which is going to tell set this particular column to this value. If you just look at the statement, you will be able to understand. Update employee, set phone number. And set is not a data type. Set is a command which is going to set the value to that that value for that column to this number. Okay. All right. So I already shown you like how we can update 2 columns in one single update. Yeah, you can see here, right? You can update 2 columns. Okay, if you want to update 2 rows, then you have to put condition, in the where clause. You have to make sure that it's going to pick those 2 columns. Like in this case, if you want to update employee ID, phone number. Okay, let me do this. Let's say for both employee ID 1 and 2, I want to update a different phone number. Then in that case, what I need to do? Update employee set phone number. Let's say I want to update a different phone number for both employee ID 1 and 2, where employee ID equal to 1 and employee ID equal to 2. Then in this case, or not and it will try to, you can see 2 rows got affected. If I go back and read the data, both for first employee ID 1 and 2, the data has been updated to the value that we used. Or you can also use where employee ID in as well. Sakshi, I'll make it very clear for you. Like if you want to update more columns, make sure that you where clause will fetch all those columns. Like if you want to update for 3, then add employee ID 3 or employee ID 3 or employee equal to 3, which is going to update the data for 3 columns. Because see, it depends on how many columns this where clause is going to pull. Okay. Now let's say you have 100 columns, and out of 100 columns, there are some 100 rows, and there are some 50 rows which you want to update. make sure that your where clause will fetch those 50 rows. So how do you do that? First, write a select statement and see how many rows it is going to fetch. Now, let's say if I want to fetch the data for employee ID 1 and 2, how I do my select statement? Select start from where employee where employee ID equal to or employee ID in 1 comma 2, which is going to fetch me both the employee IDs 1 and 2, right? Now use the same where clause in your update statement. Just copy this and replace this where clause. Right, so this is how we can make use of update statement. Now let's discuss about deletes. Let's say if you see this table is having 3 records, right? Select star from employee. Now you might be having a question like, can I delete one particular data in like, let's say I have a 3 records, right? For employee ID 2, I have, let's say, last name as BC. Now you might be thinking that, can I delete this particular last name? So deleting here is nothing but updating. I mean, delete is like deleting the entire row. Now, if you want to make some particular column value to something else, what you need to do, you have to insert something there. Either you have to change it to null. So you cannot delete one specific column. So deleting a column is not possible. So deleting in SQL Server is deleting the entire row. Okay. Now let's say if you don't want to see the last name for Dan as BC, then what you need to do, you need to update it to some other or make it null. So that is an updating. So you can only update rows, but even update column values. But when it comes to deleting, the SQL Server will delete the entire row. Okay. Now let me show you. Let's see if I want to get rid of employee ID 2, then what I have to do, delete from employee. Now here I want to delete one particular employee ID 2, right? Again, I have to use where clause, where employee ID equal to 2. Now here you can see one row has been affected, and if I go back and check on the table, you can see that second record has been deleted physically from the table. Okay. Now let me just insert that second record again. Okay. Now see what will happen in real time. Okay. So now you can see the record which was there in between 1 and 3 has been deleted, right? Now if I go ahead and insert another record into employee table, let's say for employee ID values, let's start with 2, and again Dan, his last name was I will mention as a BC, and username was ABC, and let's give some random phone number. Okay. Now we are inserting one more record with employee ID 2. You can see the row has been affected. If you go back and read the table, okay, now you can see that the record has been inserted, and now it is in the same order. Usually, now this ordering is come because by default your data is being sorted on the employee ID, because you can also check that how. But now you can see that came in between, which means it is getting sorted because of a column property. But in general, if you insert any record, that will be stored after the existing record. Okay, that sorting, how it happens, I'll show you after a couple of minutes. Now let me quickly show you how we can delete data from whole table. Okay, so let me show you that. Well, I'll do this on the same employee table. Okay. So we have employee table, right? Now you can see this has 3 records, right? So now let's say if I want to delete the data from the whole table, okay? Now what there are 2 ways that you can do. One, you can use delete from employee. And since you want to delete all the data, you don't need to use any wait condition here, because you want to delete the data from whole table, right? You can use delete from employee. This is one way of doing it. And there is one more way of doing it is truncate table employee, which is also going to delete the whole data from the table. However, the difference between these two is truncate is very fast. The moment you execute truncate, even if the table has billions of rows, your SQL Server will delete that in a fraction of a second. The reason behind this is, as I told you, someone asked me, right, what if I delete, okay, can I roll back? Basically, if you do truncate, you will never be able to roll back anything. Even if you have a proper log backup, your truncate will not be logged. So you will not be able to do any kind of rollback if you do truncate. Whole data will be deleted from your table, and even if you have a proper immediate log backup, then you will not be able to retrieve the current data. So that is one drawback with the truncate, although it is very fast. Even if there are billions of rows, you will be able to do it in a fraction of a second. However, where in delete, in truncate, you cannot be able to put filters. Let's say if you want to delete, let's say I have 1 billion rows, and out of 1 billion rows, if I want to delete 10 million rows quickly, using truncate, you will not be able to do it, because your truncate will not accept where conditions. Where your delete can have filters. Like let's say if I want to delete only the first or 2 employees, I can use this like this, where employee ID in 1, 2, which means only 1 and 2 will be deleted. However, we will not be able to use the same where clause in truncate statement. You can see here, it will not accept, because your truncate simply go and truncate all the data. That's where, and it is not going to log anything. You will not be able to recover anything. So truncate will be used only if there is a very big table, okay, and you really don't want to roll back or retrieve the deleted data, then you can go with the truncate option, wherein delete will be very flexible. Like if you even delete, and if you want to roll back for any reason, using delete you will be able to do it. So that's the main difference between delete and truncate. And one more thing, if there is a foreign key references, let's say if this employee table is being referenced by other table, then in that case you will not be able to truncate data from employee using truncate statement. So truncate will not work with the foreign key references. Okay, now what we do, let's discuss more about references, data integrity. Okay, so I'll use couple of existing statements with me. So I'll show you how you can ensure the data integrity. Let's say I'll give you a simple example. Now let's say there is we have a employee data. Okay, so for each employee there will be a manager. Imagine this way. Now when you try to insert an employee, now imagine that you are inserting some data where that manager itself is not there in your company. So then it's a kind of it's not a proper data, right? So in order to ensure an appropriate data or proper data, in order to ensure the data integrity, there are certain things that you can follow in SQL Server. So having a primary key and the stuff, they'll ensure that your data will be you are following the data integrity. So I'll give you a couple of examples. Maybe you will clear with that. So first, let me create a table again, a new table. What I'll do, I'll quickly drop the existing database. So I'll close all these sessions. Okay, now I'm also going to drop this testdb which we just created. So in real time, we will not be dropping databases and all, because once you create a database, we will be working against the same. Okay, so since it's a test machine, we can drop and recreate, and we can do whatever we want. Now what I'll do, I'll quickly take that session here. So now let's go ahead and first create the database again with the same name testdb. So I'm going back, and on this instance, opening a new session. Now here, if you see there is no database called testdb because we just deleted it, right? I'm going to create it again using create statement. Now if I refresh, you can see we got a new database called testdb. Now if you go ahead and expand the tables, as of now, if you see there are no tables. Okay. Now what we will do, let's create a table. So here I'm creating a table called employees again. Now here you can see I'm creating a table called employees, and these are all my column names. You can see employee ID, it is going to have a data type as int, okay, and it is going to have a first name, data type as varchar 30, and again it's going to be a not null, okay. Last name, hire date. So let's not discuss on the data types because we already discussed a lot. And there is a data type called money as well, where you're going to insert the data for salary column. Okay, now I'm going to create this table. Now, usually what happens if you take in any organization, usually those employee IDs for all the employees will be always unique, right? Okay, so if you want to ensure that uniqueness on your data, let's say if you want to tell if somebody is inserting data into employees table, they should always insert a unique employee ID. That employee ID should be always unique. There should not be any repeated employee ID. So in that case, how you can restrict users inserting duplicated data. You have to put a constraint there. You have to tell your SQL Server, don't accept duplicate values on this particular employee ID. So how do I do that? For that, you have to create a unique constraint. So in SQL Server, you can create a unique constraint which will not accept any duplicate values. Let me show you. Again, what we're doing now, we are trying to alter the existing table. The table is already defined. Now the existing table, I want to put an unique constraint on employee ID column, where I'm going to alter my employee ID column. So I'm going to use alter statement. So here, alter table, and then I'll be giving the table name. Now what we wanted to do, we want to put a constraint. Constraint in the sense, I'm going to tell this table that, always insert unique values into, let's say, employee ID. Let's add a primary key first. Okay, let's discuss this first. Usually SSN will be always unique for everyone, right? So I want to ensure that SSN number should be unique on this table. So in that case, I want to create a unique constraint on this SSN so that whenever I'm inserting a duplicate SSN, your SQL Server will tell that, okay, this SSN already is there. So you cannot insert same SSN again. So that's how you can ensure the data integrity, to avoid duplicate values by using a unique constraint. So for that, all you need to do is, when you are altering an existing table, alter table employees. Yeah, let's imagine that as a credit card, okay, SSN or credit card or Aadhaar card, whatever it is, okay. Let's in Aadhaar, let's think in Indian way it's Aadhaar. Usually Aadhaar will be always unique, right, for each one of us. So let's say I'm trying to make it no one can have a same number, same SSN number. So in that case, I have to tell my table upfront that, make this as a unique column. So for that, I have to create a unique constraint on this SSN column. To do that, what I'm doing, I'm altering the existing table, same alter statement I'm using. Now what I'm doing, I'm adding a constraint. I'm not adding a column. The column is already there. On that column, I'm trying to put a constraint. Okay, and that constraint type is unique, which is going to accept only unique values. For that, what I'm doing, add constraint, and to that constraint, give some name. Okay, you can give any random name. Since I'm creating this constraint on employee table and on SSN column, so I'm trying to give the name as UNQ underscore. You can give any name. It's up to you. Okay, and then you have to give the constraint type here. So here, unique is the constraint type. There are different constraints in SQL Server: primary key constraint, default constraint, unique constraint. So since we are dealing with uniqueness of data in that particular column, as I want to create a unique constraint, you can give the constraint type here, and in the brackets you can give the column name. So here you can see, again I'll repeat, alter table, give the table name. Okay, leave this DBO, which I'll tell you later again. Okay, don't worry about the DBO stuff. Alter table name, and what I'm doing now, on existing table, I'm adding a constraint. So add constraint and give a name to that constraint. Any name, whatever you feel right for that constraint, give a name to it. And then the constraint type, what type of constraint that you're going to add. Since I want to add unique constraint, give unique as a type, and on which column that you want to add this constraint. So here I want to add constraint on SSN column. Now, when I go ahead and execute this alter statement, you can see, if I go ahead and refresh my tables, oh, I'm sorry. We were doing all this on the master database. We need to do it on testdb, right? Okay. So first, let me create the table.
Just a quick info, guys. Test your knowledge of SQL by answering this question. Which of the following is not a valid aggregate function? A. Count. B. Sum. C. Max. D. Compute. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
And let me alter. Okay, now if I go ahead and refresh my table list, we can see the employees table. And if I expand this, you can see these are the columns, all the columns that we already created. Now, since we created a unique constraint, right, you can find that in constraints folder. Sorry, in keys folder. So here in keys, you can find that unique constraint or unique key. Okay, now what this does is, whenever you are inserting data, it will ensure that if let's say, let me show you as an example. So I'm going to insert first record into this table. Very first record, insert into employees, and let's insert the data for all the columns. So I'm just dragging and dropping it rather than typing column names. So in the same order, let's insert values. So here, first employee ID, I'm inserting 1, and first name, let's say A, okay, and last name, let's say B. Let's give some hire date. Let's give hire date as 2020. Well, okay, and let's also give some manager ID. In this case, let's give manager ID also as 1, and SSN number. Let's give SSN number as 1, 2, 3, 4. Okay, and salary as money, let's give as 100. Okay, now if I go ahead and execute this statement, now if you go back and check the table data, employees, you can see one record has been inserted. Now, since we have a unique constraint on this SSN, now let's try to insert another record into the table. And this time what we do, let's try to insert the same SSN and see what happens. I'm just going to copy the whole insert statement, okay? And let's modify the data, only the values part, okay? B, or let's say C, B, 1, and employee, okay? And I'm going to use the same SSN number 1, 2, 3, 4. Okay, and if I try to insert, you can see here, it is saying that violation of unique key constraint. So it is violating that existing unique constraint. So what the existing unique constraint was doing, it was trying to check the existence of the duplicate data. You can also see here, cannot insert duplicate key in object DBO employees. The duplicate key value is 1, 2, 3, 4. It is telling you that there is already 1, 2, 3, 4 which you are trying to insert. So how your SQL Server is controlling or ensuring this data integrity, because you already created a constraint on it. So here your SQL Server is making sure that always the SSN number will be unique. Hope you are able to follow me. Okay, so this is the unique constraint which will ensure the data on the column will be always unique. Now let me, in the same thing, instead of 1, 2, 3, 4, I'll insert null. Okay, now you can see your SQL Server will accept this insert statement. Yeah, I'm sorry. It is not accepting because it is not going to accept null values because you already, that column is having a not null there. Okay. Now what we do, you have to must insert some unique number. So here, let's say 1, 2, 3, 5 is my SSN number. Now you can see second record will be inserted because it is unique from the existing one. Okay, this is how you can ensure you can have unique constraint where you can ensure no duplicate values inserted into the column. Now, there is one more constraint in SQL Server, which is a primary key. Okay, now I will give you a simple difference between primary key and a unique constraint. Many will get confused. I mean, both look, I mean, see, basically unique constraint means, I'll write it here. Okay, so if someone asks you, this is the only answer that you can tell them. Unique constraint will means the data on the column, wherever you have the unique constraint, right? It should be unique, which means that it cannot accept any duplicate values, which means it can accept one null value. Okay, it can accept one null value. Let's say if you have 100 rows in a table, if that column is having, SSN column is a unique column. However, based on your not null, if that column type, data type, if the column is going to accept null values, even though if you have any constraint, it can accept only one null value, up to only one, nothing. I mean, even if you try to insert one more null value, since it's already there is one null, it's going to be a duplicate null value, right? So unique constraint can have, all unique values along with one null value, wherein if there is a requirement that you should not even have a null value in the column. So let's say employee ID, there should be always unique employees and it should not accept any null values. So in that case, what I have to do, I have to make it a primary key. Okay, so for that you need to create a primary key constraint. So primary key constraint in the sense, I'll give a simple example for it. So let me create another small table for you with a unique constraint. So I'm creating a table called test table, and here ID int, okay, nullable, okay, or let's make it not ID, column 1, okay, column 1 int nullable, and column 2 int again nullable, okay. So there are two columns. Now what we do, let's create the table. Now on this test table, first let us create a unique constraint. I'll show you how unique constraint is going to work, the difference between unique and primary. Alter table, test table, and then what we need to do, since we want to add a constraint, so you can say add constraint, and then you have to give a name for the constraint, right? So in this case, I want to create a unique, so unique test table, and since I want to create that unique constraint on column 2, so I'll say column 2. So this is the name of that unique constraint, okay. You can have any name, again there is no, and then you have to give the type of constraint. So here in this case, the constraint type is going to be unique, so I'll say unique, and then the column name that you wanted to have that unique constraint, so column 2. Now what this will do, you can see it's going to create a unique constraint on column 2. Okay, now let's insert the data into this table. First I'm insert into test table values. I'm inserting 1, 2. Okay, first I'm inserting values as it is, or let's insert 1, 1. Okay. Now if you go ahead and check, select start from test table, you can see one record inserted, 1, 1. Okay. Now what we do, since it cannot accept any duplicate values, right? Now if I go ahead and insert one more into the same table, insert into test table values 2, 1. Now again I am trying to insert 1 for column 2. Okay. Now this insert will fail, saying that there is already a duplicate key. Yeah, even at the time of creating a table, you can also define unique constraint. It's not that you can create the unique constraint later on. Even at the, like let's say for the very first time when you are creating a new table, while defining the table itself, you can create a new constraint. I'll show you that as well. I mean, to give you some understanding, I'm doing this way. I'll show you how you can create unique constraints even at the time of creating table itself. Rather than altering the table, you can also create a unique constraint while defining the table. In the create statement itself, you can do that. Okay, so here you can see the second insert has been failed because 1 was already there. Okay. Now what we do, let's insert null into this test table values 2, null. So as I told you, unique constraint can accept only one null value. If I insert this, it will accept null value. Now if I go down and read the table, we can see 2 records. The first record is column 2 is null, sorry 1, and for the second column record, the column 2 value was null. So it can accept one null value as well. Now if I try to insert one more record, insert into test table values, let's say 3, and this time again I'm trying to insert null. So already one null is there, right? So SQL Server consider that null also as a record, as a value. Now you can see it is saying that there is already a duplicate value which is null. So which means your unique constraint can accept null values, but only one null value, nothing beyond that. Okay, that's the main difference between the primary key constraint and unique constraint. So many will ask you that what's the difference between unique and primary key, wherein your primary key only accept null unique values. It won't even accept one null value as well, wherein your unique will ensure the uniqueness of data. However, only one null is allowed. So that's the main difference. Now how do you define a primary key is, I'll show you. So to define a primary key on existing table, again the same alter statement, alter, let me make it caps, alter table. Now let's define primary key on let's say table 1, or let's go to the previous example and do it. Okay, so we'll do the previous, the original table. Now you can see here we have employee ID, right? So let's create a primary key on the employee. We already created a unique constraint on SSN column, right? Now this time we'll create a primary key on the employee ID column. So as I told you the difference between unique and primary. Unique will not accept any null values, wherein one null value, wherein primary key will not accept any null values. So how do I create a primary key on existing data? Simple, alter, same alter statement, table employees, and then since you are adding a constraint, you will say add constraint and give a name to the constraint. So here, as I'm going to add a constraint called primary key. So I would like to give the name as PK. You can use any name again, as I told you, employees. Since I want to go, I'm going to create this on employee ID column. So I want to keep the constraint name as PK underscore employee ID. And this is where you define which type of constraint it is. So since I want to create a primary key, so I'll say primary here, primary. And then since you want this primary key on employee ID, you just give the column name employee ID.
Just a quick info, guys. Intellipaat provides Microsoft SQL certification training in partnership with Microsoft. The course link of which is given in the description below. Let's hear what our customers says about the course. Did you get any promotion or appraisal in your current company after completing the course?
Yeah, I just recently become as a lead in my organization. So after completing this course, because I have other 2-3 projects I have completed with the success story. So yeah, I got a promotion.
Now let's continue with the session.
Okay, now if I execute this, now a primary key will be created on this existing table. If I refresh my keys folder on a database, you can see one unique column is there and also one primary key is there. Now I'll show you the difference between primary and unique again. So here, now primary key means this employee ID column always have unique values. So which means it's not going to accept even a single null value. Now if you try to insert a null value to this table on employee ID, you can see it will not accept. Insert into, although we have not null, I mean we already have a not null. Even if it is a null, you can still create a primary key. Okay, so but it will not accept. So you have to make sure that column is going to be not null, which is not going to accept even a single null value. So definitely if you try to insert a null value, it will fail. Employees, and let's drag the column names here, and let's start giving values. So let's try to insert one null value and see what happens. So I'm going to give height rate as 0101, and employee ID is going to report to 1. And since we have to keep that SSN as unique, so I'll give a different number 1236, and salary can be anything, like let's say 125. Now if I go ahead and insert, it will fail because you're trying to insert something onto the primary key where it is not going to accept any null values. Or if you try to insert an existing, let's say already 2 is there, right? Now if I try to insert 2, again your SQL Server will tells you that because of the primary key constraint, it cannot accept the duplicate value 2. So you have to, if the column is a primary key column, then you have to always enter unique data. So this is how your SQL Server ensures the uniqueness of data. So the reason you will be having primary keys and unique constraint, because when somebody is trying to insert the data onto the database, all these checks will come into place. So they will ensure that your database will be inserted with the proper, appropriate data. So that's where these relational databases will have all these things in place. As yesterday we were talking about NoSQL databases and all, right? So the main difference between these two kinds of databases is your relational databases will ensure the data integrity is followed. Okay, so whatever you define, others will be able to insert the data in the same way. Let's say if you say employee ID should accept null values, then if somebody try to insert null values, it will accept it. Then if you alter that to not to accept any null values, then your SQL Server will not accept if somebody try to insert null values into that particular column. So that is how you maintain the data integrity on a table by having this constraints, like unique constraints and primary key constraints, like in terms of duplicates. And you can have primary key on multiple columns as well. Like let's say while creating the primary key, you can create a primary key on composite columns. Like let's say if you want to make employee ID and first name, like the combination of employee ID first name should be always unique, then you can, at the time of creating primary key, you can do that, create it on 2 columns. So that is called composite key. So you can have a composite primary key across multiple columns. Now on a single table, you can have only one primary key. You cannot have multiple primary keys. See, you can have a primary key with combination of columns, okay? But on a single table, you can have only one primary key. You can understand the difference. On a table, only one primary key is allowed. However, that primary key can be on one column or on multiple columns as well, like that combination of multiple columns, okay? Now, let's say if I try to create another primary key on a different column, you can see, let's say I'm going to create another primary key column on, let's say we want to create it on first name. Okay, let's take the first name. We already have primary key on employee ID, right? Now I'm trying to create the primary key on first name as well. You can see it is saying that it's already having a primary key defined on it. So you cannot have multiple primary keys on a single table. However, as I told you, it is possible that the same primary key can, you can have the same primary key on multiple columns. Let's say you can drop the existing one, which is there on the employee ID. Then you can create on the combination of both employee ID and first name. That is possible. That is called a composite primary key. Okay. So that case, I mean, in real time, you will be doing that, because I have worked on composite primary keys where in terms of partitioning. So I had to make a composite primary key. It is possible. I'll give you the reason why it is actually won't accept multiple primary keys later when we talk about indexes. But now I can simply tell you that on a given table, you can have only one primary key. Okay. Now, let me talk about one more constraint in SQL Server, which is a default constraint. Okay. So I'll put it this way. Now, let's say you have employees data, right? Let's say you have multiple employees. Now, I mean, let's say there is your HR will tell you that, okay, no employee should have his salary less than 100. Let's say if somebody try to insert salary for an employee less than 100, they will tell you that, okay, you should not entertain those inserts. You should, no employee should have less than a salary as less than 100. Then in that case, what I have to do, I can create a default constraint on my table. So which means, sorry, not default, check constraint. So at the time of somebody is trying to insert some data, it always check that rule, whether that rule is, is followed or not. If that rule is not being followed, then insert will fail. If the rule is being followed, then insert will happen. So I'll give you a quick example for it. Maybe you'll get clarity on it. So how do you create a check constraint is, here the requirement is you should not allow any employees, any new employees or existing employees with salary less than 100. Okay, so that's the requirement. So for that, I'm going to create another constraint on the table. That's going to be a check constraint. So how it works is very simple. Same alter table. Let's copy the table name. And again, add constraint. So give a name for the constraint. So since I wanted to add a check constraint, so give the name as CHK. You can use any name again, as I told you. And now I wanted to have this constraint on salary, right? So I want to even include that name in that. So even just by looking at the keys, you will be able to simply tell that, okay, this on employee table, this primary key is on employee ID. So looking at the unique name, you can simply say that employees table is having any constraint on SSN column. Okay, so that's why I usually prefer to keep names like this. So by simply looking at the name itself, you'll be able to figure out so on which table and which constraint it is, what type of constraint it is. So now here, since you wanted to add a check constraint, you'll say check. So if it is a unique constraint, you will be saying unique. If it is a check, you will be mentioning check. And here I want to ensure That's the salary shouldn't be, or always the salary should be always greater than 100. You can mention like this. Okay, which means if you try to insert any new record or update an existing data, where this I mean, if you try to update the salary less than 100, or if you try to insert any new record with the salary less than 100, your SQL Server will not accept it. Sorry, it should be less than 100. Yeah. Okay. Okay, it's saying that conflicted with check constraint. Okay, let me quickly. Okay, which is already okay. Check constraint, check employees. The conflict occurred in database. Okay, let's keep it. Let me copy from here. Okay, I'm sorry. It should be like this: check greater than or equal to 100. Okay, which means either it should be either equal to 100 or it should be greater than 100. Okay, now you can see the constraint has been created. If you go ahead and refresh, sorry, it will be there in constraints now, not in keys. So here you can see the check constraint is created. Now let's try to insert data. Okay, I'm copying that above insert statement. And this time let's insert fourth employee. Okay, and I'm going to change his date of joining to something else, and manager 12 and 1237. So here let us first try to insert the data, since it's going to accept salary only that is beyond 100. Now let's try to insert 99 as salary and see what happens. So because of the check, before you execute this statement, the moment you execute it, usually what happens, the SQL Server will go ahead and check whether the salary that you're inserting is against the rule that you created or not. The rule is that you should have the salary above 100 or equal to 100, right? If I try to insert 99, obviously it will say that the insert conflict statement conflicted with check constraint. The conflict occurred in the database testdb on column salary, because 90 your check, it is trying to check whether that salary is above 100 or not. If it is above, then only it will accept. Since it is below 100, it is not accepting. Now if I go ahead and change it to some other value beyond 100, now you can see that insert will execute. Okay, so this is how your check constraint will ensure the data will be inserted appropriately. Okay, so let's say if the requirement is like the data should not be less than so and so value at any given point of time, then you can create a constraint. So basically, you don't need to manually identify that. Your SQL Server will be taking care of it on your behalf once if the constraint is enabled. Okay, now let's talk about the final one. In terms of the available constraints, so let's talk about on a given table, the final constraint is default. Default in the sense, let's say if you are not going to insert any value, your SQL Server is going to insert a default value for it. Okay, let's say in this case, if you look at this table, now for every employee there should be a manager ID, right? Now if you don't know who is his manager, and if you want to always for those employees who for which you are not aware of the manager ID, and if you want to always map him to one particular employee ID, you can create a default constraint, which means if you are not inserting any data, the default will be inserted automatically. Okay, I'll show you that. So how do you create a default constraint is, let me copy that. Yeah, it's very easy, simple. I mean, same alter table employees. I'll copy this. And then now, since we want to create a default on employees, right? And on which column that we wanted to create? So we want to create on manager ID, which means if I'm not inserting any manager ID, let's say I wanted to insert that as a 2 or 3 or whatever the value, or it's a 0. In that case, what I have to do, I have to give a default value here. So I'll say default 0 for which column? Let's say manager ID. So I'll say manager ID here. Now what it is going to do, the moment I create this constraint, if I refresh my constraint, you can see the default constraint here. Now let me quickly show you when you do insert what happens. So here I'm going to insert the fifth record, and this time fifth employee, and let's change the values here 2, and this time what I'm going to do, I'm not going to insert any value for this manager ID. So I'm deleting that value for manager ID and also deleting this column here. Okay. So I'm just inserting only the data for employee ID, first name, last name, hire date, SSN, salary, excluding manager ID. Okay. So since you're not inserting data for manager ID here, so what you told by default, it should consider 0 as manager ID. So if I execute the statement will, okay, so it is saying the violation of primary key because I need to change, SSN to 1238. Yeah. If I execute this, that record will be inserted. Now, if you go back and check the data, select star from employees. Here you can see for the 5th employee, you can see here that manager ID is inserted as 0. But did I mention anywhere in that insert statement manager ID is 0? No, because if you don't mention anything, you already told SQL Server that consider that value as a 0 by creating a default, right? So automatically 0 is inserted. I mean, the use of default constraint is, let's say if you're, I mean, like if you're not giving any value for a specific column, okay, and if no value is given, then you want to insert some random value or some default value automatically. Then what you can do, you can create that as a default constraint. Now in this case, what I did for manager ID, if I'm not going to insert manager ID, then I wanted to use 0 as default. So I created this default constraint. Then what happens when I am not inserting any manager ID, automatically 0 is inserted as a default value. So default, whatever the default value that you defined here will be inserted even if you don't mention anything in your insert state for that specific column. Okay, so now let's discuss on a foreign key constraint. Okay, so what I'll do for that, we'll create multiple tables. Okay, foreign key is nothing but it's kind of referencing. Like let's say I'll give a real-time example. Okay, then we will discuss on it. So let's consider this case. We have employee data. Okay, let's say we have data like this: employee ID. Okay, and we have employees like 1, 2, 3, 4, 5. Let's say there are 5 employees. Okay, and let's have a first name A, B, C, D, E. Okay, I'm just giving a random simple example. You can actually relate that in real time as well. So there won't be much difference in how you apply foreign keys in real time. So we have employee ID 1, 2, 3, 4, 5, and their first names are A, B, C, D, E, F. And each employee has a manager. Okay. Or let's say each there is something called department ID. Okay. Okay. Now let's say in this organization, imagine this. There is a department column, department table. Okay. So here I'm creating another table. Imagine this as a table: department ID and department name. Okay. So this is one table where we have few departments. Let's say first department is 1, department ID 1, it is dev, and department ID 2 is a DBA. Okay. Now this is 2 sets of tables. Imagine this like this. There are 2 sets of tables. Okay, one table is I'll put this like this. The first table name is, let's do like this, employee. Okay, or employee info, and the second table name is department info. All right. Now, so I mean, if you just look at these 2 tables, all right. So now we have 2 tables, right? One employee info, one department info. So now usually there are 5 employees. In general, all these 5 employees, maybe they all belong to the same department, or maybe few of them belong to one department and then other could be belong to department 2, right? That's how in real time, right? Maybe one belongs to department ID 1, employee ID 1, and employee ID 2 belongs to department ID 2, and again 3 belongs to department ID 2, and the rest 4 and 5 employees are belongs to department ID 1. So now this data will make you sense. Like if someone asks you, employee ID belongs to which department, how would you say that? By looking at the department info table, you'll say that okay, this guy belongs to dev team, right? And by looking at if someone asks you who belongs to DBA team, then you can look at both the tables. You can say that okay, employee ID 2 and 3 belongs to DBA team. So now if you look at both the data, it is making a lot of sense to you, right? Now what I'll do, I'll go ahead and insert one more employee. Okay, let's say employee name is F.
Just a quick info, guys. Test your knowledge of SQL by answering this question. What is the full form of SQL? A. Structured query list. B. Sample query language. C. None of these. D. Structured query language. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
And I will insert his department ID as 5. Now, can you tell me which department this guy belongs to? This employee ID 6 belongs to which department ID? We are not sure, right? Because we have only 2 departments, 1 and 2. Now you inserted some another new employee, and you told you mentioned that this particular employee belongs to department ID 5, which is not there in your company at all. So this is kind of this data is not making any sense to you. Okay. So now the first thing allowing this insertion of this 6th record is itself is wrong. You should have to put some restriction there. You should only insert employees, department IDs where those department exist in the department info table. So you have to put some check there, right? So that check is nothing but foreign key references, which means now you will create a foreign key constraint on these tables, where you will say that when somebody is trying to insert a new employee, and if they're trying to insert any department ID which is not there in the department info table, don't accept that insert. So you have to put some check there. That check is nothing but foreign key constraint, which will ensure that which will not allow you to insert any data or any department ID which is not there in the department info table. So that foreign key is going to refer, this department ID on this employee info table will be referring department ID on department info table. So that's such a way that you have to create a foreign key, and whenever somebody try to insert anything onto this employee info, it won't accept it. So I'll show it as an example, then you'll be more clear on it. But I hope you got some idea with this. Okay, let me, same thing will apply as a tables, okay? So I'm going back to this database again. So this time what I'll do, I'll create the same what we discussed in this example, same table I'll create with the same values, okay? First I'll create both the tables, create table, let's say first table is employee info, and this is going to have 2 columns. One is employee, 3 columns. Employee ID is going to be int. Let's say, let's not talk null, not null. Okay, let's forget that topic. So let's make it first name as, let's say, char 10, and we'll have one more column which is a department ID, which is int again. Okay, so this is the table employee info. And now let's create one more table, department, and create table DEPT info, and this is going to have 2 columns. One is department ID, which is going to be int, and department name, which is going to be some characters. Okay, let's give it as a char 10. Okay, so now we are creating 2 tables. All right, so now we have 2 tables in database, right? If you go and refresh, you can find both the tables. Yeah, you can see here there are 2 tables, employee info as well as department info. Okay, so there are 2 tables. Now what we do, first let us insert some data into the department info table. So let's insert 2 departments into this. So I'm going to use insert statement here, insert into department info, and then both the columns. So here columns is department ID and department name, and then values 1 comma dev. Okay, let's copy this and also insert again another record to let's say DBA. Okay, 2 records have been inserted. Now if you go and read the data from department info table, you can see there are 2 records. So there are 2 departments in this organization. Imagine this way: one is dev, another one is DBA, and department ID 1 belongs to dev, 2 belongs to DBA. Now our requirement is we should not have any employees insert without, other than these 2 department IDs. We have 2 department IDs, 1 and 2. We should insert only those employees. We will be able to insert only employees with any of these department ID, nothing more than this department ID. So in that case, what I need to do, I have to create a foreign key constraint. So where that constraint will be referring to tables. So here that foreign key where we have to create, since we wanted to ensure the integrity on the employee info table, we have to create the foreign key on the employee info table. So already the table is defined, right? So I'll simply go ahead and alter it. Alter table employee info. So I'll copy the query rather than write it. So same, it's like the way that we do. Okay, same. We'll be doing the same way that we do check constraint. So let me quickly change this here. Yeah, or else let me write this. So employee info and then add constraint. Okay. So here, since we're creating a foreign key, so I would like to keep the name as fk underscore. Since it is referring, it is created on employee info table. So I would like to keep it employee info. And then I'm going to refer department info table, right? So I would like to keep, if whenever I create a foreign key, this is how I create. So by looking at the foreign key itself, I can simply tell that, okay, this is a foreign key on employee info table, which is referring department info table. So for that purpose, I would like to keep the name as like this, but it is up to you how you want to keep the name. So now what we wanted to do, we wanted to create a foreign key. So you will just give the, okay, I'll copy this. Now this foreign key is going to be on which column? Department ID, and it's going to reference. So this is going to reference department info table. Okay. On what column in the department info table? Again, department name column. So department ID column. Okay. So here I'll repeat this alter table employee info. Now we are creating the foreign key on employee info table, and this foreign key is going to refer department info table, and which column it is going to refer? Department ID. Okay. Now I'll execute this. If you go ahead and key, you should on department info table. So let me go ahead and first create 2 primary keys on both employee info and as well as on department info table. So we know already how to create a primary key. So alter table. First we'll create it on employee info. Alter table employee info. Add constraint pk underscore employee info on employee ID. Okay. Which constraint it is? Primary key. On which column? Employee ID. Okay. So this is going to create a primary key on employee info table. Yeah, it is saying that cannot define primary key constraint on nullable column. If you see, while creating a table, I made it nullable, right? So let's first alter it to not nullable. So alter table. How do you alter a column? Alter table employee info. Alter column and give the column name. So here in this case, the column name is employee ID. And what we wanted to do, we don't want to change data type or anything. So we want to keep the same column name and same data type. However, we want to make it not null. So simply add not null, which is going to change that column property to not null. Now we can go ahead and create a primary key on it. All right. Now the same case with department info table as well. So how do we, on department info table also, we create it as a not null, right? So let's make it, sorry, null. Let's make it not null. Alter table. Copy the table name. And first, let's alter the column, the existing department ID column. To not null. So I'll make it not null. All right. And I'll execute the statement. So which converts that, alters that column type, from not null to not null. And let's add a primary key on it. Alter table. We want to add a primary key on department info, right? So just department info. And then since we want to add a constraint, we'll be using add constraint. And which constraint it is? Primary key, right? So I would like to prefer pk underscore department info underscore. On which column we want to create a primary key? On department ID. Just copy that column name. And we have to define the type of constraint here. Since it's a primary key, so we will type primary key. And then in the brackets, we'll give the column which we want to have it as a primary key column. So I'll just copy the column name. Now this is going to add a primary key on department info table. Now what happens with this is, now we have a primary key on both the tables. Okay, so on the top table, the primary key is on employee ID. In the second department info table, primary key is on department ID column. Now we are trying to create a foreign key constraint. The department ID is on employee info table is going to refer department ID on the department info table. The reason we are creating the foreign key constraint to ensure the data integrity. Now you can see the foreign key is created on which table? The foreign key is created on the employee info table. If you go ahead and refresh your employee info table, here you can see the foreign key constraints that you just created. Sorry, you can see the foreign key constraint here. Okay. And now if I try to insert any department ID which is not there in the department info table, it will not accept. Let me show it as an example. So I'm trying to insert into employee info. Okay, what are the columns it has? Employee ID, and then first name, and then department ID, right? So there are 3 columns, and let's try to insert values. So let's say first I'll insert value employee ID 1. Okay, and employee name as A, and let's insert the department ID 1. Now in this case, the statement will execute. The reason because when you execute the statement, the department ID 1 that you are trying to insert, first it will go ahead and check whether the department info is there in the department, department ID is there in the department info or not. Since it's already there, this insert will execute without any issue. You can see here, the insert is executed. And if you go ahead and check employee info table, one record would have been added now. One row would have been added for employee 1. Now what we will do, let's insert one more employee. Okay, let's say employee ID 2. And we're going to add him to department ID 2. And as we know that there is the department ID on the department info table, even this insert will execute successfully without any issue. Now, if you go ahead and check back, there will be 2 employees who are on different departments. Okay. Now, what we do, let's insert one more employee, and this time, let's insert his department ID as some other value. Let's say 4. Now we know that. You know that because you know that there are only 2-3 records. We were easily able to figure out there are only 2 departments, 1 and 2. But in real time, there will be a lot of data on the tables, right? So you cannot manually verify all that stuff, right? So that's where this foreign keys will be doing that data integrity check. So in this case, if I try to insert the department ID as 4, which is not there in the department info table, this insert will fail. It will say that the insert statement conflicted with the foreign key constraint, and the conflict occurred on testdb, department info table, and column department ID. So this is how your SQL Server will ensure the data integrity by having a proper foreign keys. Hope you are clear on this now.
aggregate functions. Okay, so what are aggregate functions? As the name suggests, these functions operate on a collection of values and returns a single value. For example, if you want to, so in case you want to get the maximum of salary from the employee table, this is how you write it. You say select max of salary from employee. Let me just quickly change the connection to our own database. Intellipaat 17th, this one I guess. Okay, so if I want to get the maximum of salary from the employee table, I just say max of salary and it gives me 5,000, which means that 5,000 is the maximum salary, that is maximum salary amount present in the employee table. Okay, now if you see here, it shows as no column name. The reason is when you aggregate a column, the column name goes off. So you need to give it an alias name so that you can see the name of it. So here I say max salary, and when I execute it, see, now you get the column name as max salary. Now you can also filter your data. Let's say you want to get only the maximum salary where the address is India. So you say address equal to India. So now it will give you all the maximum salary which belongs to India. Okay, for the employees belonging to India. I think it's IND. Let me see, what do we have in them? So let's start from employee. Yes. Oh, I have a space, my bad. So here India. Let me execute this. You see, so you can also apply your filter conditions before your aggregation. So the where clause works before, or it is executed prior to getting the maximum. So first it filters the data to get all the employees where address is India, and then gets the maximum of salary. Similarly, if I want to get the minimum of salary, I say select min salary from employee, and here I see that the minimum salary is 1,000 for the whole employee table. If I want to see the average salary, I say select average of salary from employee, and it gives me 3071. Okay, which is nothing but, so average is nothing but sum by count, isn't it? So when I say select sum of salary divided by the count of employee ID from employee, it would give me the exact same amount. Let me show you by executing both of these queries so that you can confirm. See, when I execute these two, you see both of these has 3071. Okay, so this is how you can get your average. Now you can either take a count of employee ID or you can do a count star. So there are multiple ways in which you can count it. Like for example, you can say count 1, you can say count star, or you can say select count employee ID, for example, okay, from employee. Now all these will return you the exact same output. See, it gives 7, 7, and 7. The problem with this is that when you say count star, it gets, so this one, it gets all the data into memory and then counts the records. In here, it gets all the employee IDs into memory and then counts the records. Now the problem with this approach is the nulls in the employee ID might not be counted as a row. So that is the demerit associated with counting only a specific column. Okay, if it is a primary key, you can go ahead and calculate it. You can go ahead and count it. But when you count any other column which is nullable, let's say, then if it is null, if one of the row is null, then it won't count it. So basically, let's say in the employee table, if one of the employee ID had null, it would have counted only 6 rows instead of all the 7. So that is the demerit associated with this. The demerit associated with this is it takes the whole table into memory, because we are saying count star, right? So star means the whole table. So it takes the whole table into memory and then counts the rows, which is again a bad approach. I mean, why do we want, for a very simple count operation, why do we want SQL Server? It doesn't make any sense at all, right? But then there is the count 1. Now, what does count 1 mean? 1 is basically a integer value. It's a plain number. Okay. Now here I can say, let's say this. say select star from employee. Sorry, select star from employee. What do I get? I get the whole employee data, right? So if I say comma 1, this is another column, right? 1 is another column. So here I get all the ones. See here? So it basically, you remember we used to derive column here, right? Like we used to say year of something. It used to give us one more column. So similarly here, I'm just hard coding it to 1. So when I run this, it gives me all the ones here. Now, if I remove the star, let's say I remove the star, what will happen? So when I remove the star, it will basically give me ones for every record in the employee table. And then I can do a count of 1 in here. This is the most efficient way of counting it because it is now not taking everything into memory, but just taking the hard-coded ones into memory and just counting them. As simple as that. Okay, so we can use any hard-coded value as an acknowledgement to count the number of records in the table instead of counting the star. So these are all the aggregate functions that are available with SQL Server. Okay, so moving on. So next, let's talk about user-defined functions. So what are user-defined functions and why do we create them? So the user-defined functions are, so we have spoken a lot about the system-defined functions, the functions that the system provides to us. Now let's say we want to create a function for our own use, which is not easily achievable with the system-defined functions. In that case, we create our own user-defined functions. Okay, now what are the different types of user-defined functions that we have? The first is called as the scalar value function, which you already know returns only a single value. Okay, and then we have the table value function, which returns the output in the form of a table. Now, if you have realized, the system-defined functions doesn't have any table valued functions as such. Okay, they are mostly scalar valued functions. User-defined functions, we can create table valued functions, and they are again of two types. One is inline or single line table valued function, and the other is known as multi-line or multi-statement table valued function. Now, what is an inline table valued function? The function in which there is only one single line that returns the table is known as a single line table valued function. Easy definition. Okay, and the second one, which is a multi-line, is a function which has multiple lines that helps us return the output in the form of a table. So clearly the function that returns the output in a single line is called a single line table valued function. The function which returns us the output in the form of a table using multiple SQL statements is called as multi-statement table valued function. So let's start with talking about scalar valued user-defined functions. Okay, and these are functions which we write. Earlier system-defined functions were functions that are provided by default with SQL Server database. Okay, but scalar valued user-defined functions are functions that we write that accepts input parameters and returns a single value. So a single value could be 1, 2, 5, 10, Dinesh, John, anything, today's date, and it can return any data type. That means it can return varchar, it can return integer, it can return date time and whatnot. Also, a single function at a single point in time will return only one data type. That means you cannot use a scalar valued function to return two values with two different data types because it is a scalar valued function. It can only return a single value at any point in time. Now, let me show you how to create a user-defined function. The example that I'm going to give you is how to create or how to generate a full name from two given input parameters. I know you can do it with other system-defined functions, but yes, just giving you an example as to how you can create your own user-defined function. So here you say create or alter. Now, why do I say create or alter here? The reason why I say create or alter is because let's say I'm creating this function for the first time in the server. Our motive whenever we are executing any type of SQL query is that our query should never give us any error. Okay, it should not throw any error at any point in time. So we need to prepare our query which is re-executable. That means irrespective of how many other times you execute, it should not throw any error. Now, when I only say create function, That means every time I run this query, it'll try to create that function. And let's say it created the first time. The second time when you ask it to create, SQL will say that, hey, it's already there. I cannot create it again. So you need to alter the second time. Okay, right. So here, if I say only create, it'll throw me an error if it already exists. But if I say create or alter, SQL will automatically identify if this function is present in the server, in the database or not. If it is present, if it is already existing, then it will alter it. If not, it will create it. Okay, so here I say create or alter function, and then we give a name to the function. Now giving the name is also an art. It's also an art, okay, to be frank with you. Very few people I've seen give good names to their objects. Okay, you need to build this quality in yourself. Okay, you need to make sure that any object that you're creating, it could be a table, it can be a view, it can be anything, any type of object that you're creating, you need to ensure that you give a proper name to your object so that.
Just a quick info, guys. Intellipaat provides Microsoft SQL certification training in partnership with Microsoft. The course link of which is given in the description below. Let's hear what our customers says about the course. Did you get any promotion or appraisal in your current company after completing the course?
Yeah, I just recently become as a lead in my organization. So after completing this course, because I have other 2-3 projects I have completed with a success story. So yeah, I got a promotion.
Now let's continue with the session.
Anyone else looking into that can understand what exactly does it contain or is it going to do. So here, first of all, I prefix it with fn underscore. Now this is also an important aspect. Why? Because here, from here onwards, any object that we're going to create, I would say, except for tables in the database, any object that you create, make sure that you give them a prefix so that you look at it and know what type of an object it is. So here, when I give a prefix of fn underscore, I know that, okay, this is a function. So I give it a name saying fn underscore so that I know it's a function, and then name that justifies the purpose of that particular function. So here I say get employee full name. That is, this function is going to give us the full name as an output. And then you remember when we were executing functions, we were passing input parameters. You remember? So with this, with our function also, we can design it to design so that the user can pass input parameters. So this is where we define how many input parameters can be passed to the function. So here I say the first parameter is first name, the second parameter is last name, and both of these are of varchar 50 characters in length. Now if you have observed, these have @ as a prefix. That's the reason they are called as input variables or input parameters. Remember when we were talking about variables, I said that you need a @ in the front which categorize them as variables. So here I say this function is going to take 2 input parameters, and then is a very important aspect again of the function, which says here I'm going to specify what is this function going to return as an output. So this function I say is going to return varchar 101 characters long. So the first name is of 50 characters, last name is of 50 characters. Now if I'm generating a full name, obviously I'll separate these two with a space. So that's the reason I give 101, 50 plus 50 plus 1 for the space. So this function is going to return 101 characters in a string of 101 characters as begin, and then we specify the core of our function. That means what is this function going to return. So here I say return, and if you see here I say select, I trim off the first name, basically to trim off the spaces if there are any. So let's say there are some spaces in the front of the name or at the end of the name, I just trim off those spaces, and then I concatenate it. I add a space in between and then the last name. Okay, and now let me create this function. So see how many ever times I executed, it doesn't throw me an error because I have the create or alter here. Now where can you find the functions in the server? Go in here, go to the databases. In this database, go to programmability, and in here you will find functions and then scalar valued function. See, this is the function that we just created, function underscore get employee full name. And if you see the parameters, see it accepts two parameters. One is first name, one is last name. Now, how do we call these? You already know, right? How we call this? So we usually say select and then the function name, right? Select and then the function name and then the input parameters, isn't it? We used to pass John and Smith. Let's pass John and Smith as the first and the last name, and I give it an alias name saying as full name. And this, when I run it, it gives me an error.
Just a quick info, guys. Test your knowledge of SQL by answering this question. Which of the following is not a valid aggregate function? A. Count. B. Sum. C. Max. D. Compute. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
It says the function is not a recognized function name. Now, this is something odd, isn't it? The reason is you need to specify the DBO before your user-defined scalar valued function call, so as to ensure that the optimized. So what actually happens is when I say select and then I put the function name, SQL automatically anticipates or assumes that it is a system-defined function. It doesn't understand that it could be a user-defined function as well. So it always looks into the collection of system-defined functions. So how can we force SQL Server to look into the user-defined functions? By specifying the schema name, because no system function will be created or can be created in the DBO schema. This is basically for the users only. So when I say DBO dot, now it should work. But this is not ideal in case of tables, isn't it? In tables, we don't specify the DBO schema name because by default it is the DBO schema. But the case is a little different with only user-defined scalar valued function. So that's the reason we need to put DBO in here. So when I pass John and Smith, see, it gives me the full name as John and a space and then Smith. Similarly, if I pass Dinesh and Kumar, it would give me Dinesh Kumar as output. Now, if I want to probably show you one more example, create or alter function, let me create one more function which will add numbers for us. So the input parameters should be two numbers. Let's say number 1 and number 2, both are integers. And obviously the sum will also be an integer. So I say returns integer as begin. And here I return saying select number 1 plus number 2, because this function is going to add up numbers for us, right? Now this I'm showing you very simple examples, okay, but you can think of any redundant job that you're planning, that you are doing at your job place, and try to put it in a function. But again, you need to remember that no DML operations are allowed. So only redundant select operations can be put in the functions. And now if I run it, I create this function and try to, so this one also is create or alter. And if I try to run it, it gives me 3, the sum of 2. 10 plus 15 gives me 25. Simple. And this is the same notes that I was explaining you earlier. So the next topic that we're going to talk about is on the user-defined functions. I told, so till here we spoke about the scalar valued function, basically the function that returns a single value. Now let's see how can we design a function that will return as a table as an output. So the first one that we're going to talk about is the inline or the single line table valued function. Basically, the table is returned as a result of action from the given parameters, but it is derived from a single select statement. That means, as I told you, the body or the definition of the function contains only one SQL statement. So how do we do it? I say create or alter function. Again, I give it a name, fn underscore get employee details. So this is the name that I give to my inline table valued function. The parameter, it accepts only one, which is employee ID, and it returns, you see here, now I say table. So earlier we were specifying either varchar or integer. Now we are specifying as a table. So it returns a table as an output as, and then in the return, you see here, I don't specify begin and end. The reason is we know that the function has only one SQL statement inside. And when you have only one SQL statement, you don't need to specify the begin and the end. Okay, basically for single line function you don't need begin and end, but for scalar valued and for a multi-line table valued function you will need the begin and end. So only for this one you can skip the begin and the end. I mean, that's not a part of the syntax. So here I say return, and then if you observe, I'm saying select. So this is one select command, you realize, right? So here I say select, and then I can call my scalar valued function inside the table valued function. This is the function that we just created above, didn't we? So here I say select dbo dot this function name, and then I pass two columns that I have, the employee first name and the employee last name as full name. So I first select the function and then salary and then address. So this is something that you can only do with scalar valued function, not with table valued. Okay, and I say from employee, where employee is equal to @employee ID. Now what is @employee ID? Is the input parameter. So whatever parameter the user sends for that particular employee, it would display the full name, the salary, and the address. Audrey asks, what is the purpose of putting the sign in front of the employee ID? As I told, these are input parameters or the variables, right? So for SQL to identify that these are parameters, we need to specify, we need to put in front of it. So this is basically a naming convention. For parameters, you need to put in the beginning. So now let me create this function. It says commands completed successfully. And now how do we call a table valued function? So it's going to return as a table, right? So we are going to call it exactly how we call tables. So I say select star from function name in bracket the input parameter. Remember the scalar valued function, we used to just say select and then the function name, dbo and then the function name. But here, as it returns a table, we say select star from and then the function name. And if I execute, it gives me full name, salary, and address. Okay, because in the function we have specified a full name by using the function, salary, and the address, only 3 columns. So this is how you can execute or call your table valued functions. No DBO is necessary here, because for table valued functions it can easily look it up on the table valued user defined functions. Only for scalar valued functions you need to specify DBO. Let's move on. Okay, next up we have multi-line or the multi-statement table valued function. Now, as I told you, this will have more number of SQL statements in the definition. So how do we create it? The same syntax, create or alter function. We give the name. So here I give fn underscore, which basically represents that this is a function. And then I have get employee details. And you see ML. ML means multi-line. So I give it a name so that I can distinguish. Earlier I gave get employee details. Now I give get employee details ML. And then the input parameter is the same, which is employee ID. And then here, if you remember earlier, we used to say returns table, returns varchar, returns integer. But now here, in case of multi-line table valued function, we need to say returns, and then we have to specify a table variable. When we were speaking about the temporary tables, so here I'm specifying a table variable with the name @emp, and I specify the columns here, which is employee ID, full name, and salary, and the data types obviously. And then I say as begin, and then at the end I specify end, and inside this I specify my whole SQL statements. I mean all of my SQL statements. Now what do I do here? I say insert into the table variable the columns, and then here I select the employee ID goes into the employee ID column, the full name goes into the full name column, and the salary goes into the salary column from the employee, where emp.employee ID is not equal to the input parameter. You see here? So here what I say is, if I pass, let's say 5 as my input parameter, then except for 5, insert all the other employees into the table variable. So first it would do that into the table variable. Next, it would update the employee IDs which are 2 and 5. The salary will be updated to 5,000. So I write a quick update statement here. And then I delete the records which are 6 and 3. All I'm doing it from the table variable, if you remember, if you see here. Because if you remember, I told you one important aspect of functions, that is, it does not allow us to perform any DML operations on the physical tables, right? So in that case, I mean, the only exception in that is that we can do it on the table variables. Okay, so here I say insert into EMP. First I insert all the employees except for that, and then I run an update to update the salary to 5,000 for 2 employee IDs. I delete 2 employee IDs from my EMP table variable, and then I insert one hard-coded record. Okay, I try to insert one record into the table variable, and then I say return. Now what does the return keyword do? The return keyword would basically return this EMP table as an output. Okay, so here I already specified the returns keyword, isn't it? I mean, I specified what should be returned. So when I say return, SQL automatically understands that, okay, that EMP table variable should be returned to the user. So now let me execute this. So we now have multiple lines of SQL statements inside the function, isn't it? And now when I execute it, see, I say select star from function and I pass the ID as 4. And here when I run it, see, this is the output that I get. I get the employee ID, full name and salary, basically the structure of the table variable. And the if you see, first what we did was we inserted everything except for the input employee ID, right? So what did we provide as an input? We provided 4. So it does not have a 4 clearly, as you can see. And next what we have is I updated for 2 and 5, I updated the salary to 5,000. So here if you see, for 2 and 5 the salary is 5,000. Now this is all being done on the table variable, mind it, okay? The table, employee table, isn't touched at all. Here I said delete from EMP where employee ID in 6 and 3. So you should not be seeing 6 and 3 here. And also end of it, I just inserted a record with ID 100, which is here. Okay, so this is how a multi-line table valued function works. So what are the other operations that we can perform on functions using in where clause? So I've already shown you how to use the function in the select. Here I can select after star, I can add one more column like you already know, and pass 2 columns in this, first name and last name. And when I execute this, it would give me a whole of employee data and then 1 column at the end that would say full name. Okay, and next you can also use, so this is only for scalar functions, okay, scalar valued functions. Now you can use scalar valued function in select as well as in the where clause also. You see, in where I specify the function name and then I pass the 2 values as input, basically the columns, and say equal to John Smith. So now it'll return me only that employee which has the full name as John Smith. See, it returns me employee ID 2 which has the name as John Smith. So this is only on the scalar valued functions. You see here, only on scalar valued function you can use them in the select and in the where clause as well. Okay, now for the table valued functions that we have, you can use them to join with other tables. Okay, so to join table with the table valued functions with other tables, there are 2 options. Like we have joins to join tables, we have cross apply and outer apply to join functions to the tables. Now as I told, these are only the table valued functions, so we cannot join the scalar valued functions because those only return a single value, right? But the table valued functions returns a table, so we can join that with other tables. So first let's talk about the cross apply. The cross apply is similar to an inner join. So how do we write it? You need to remember this syntax, okay? It's a little different from how we write joins. Here I say select star from the employee table and then cross apply. Here I say select star from the function and then I need to pass the input parameter. I give it an alias name, say as fn, and this is like your join clause. Okay, this where clause is, it acts like a join clause here. So I say where e.employee is equal to function.employee. So this is like your on clause in the join as x. Okay, so this whole thing I name it as x, And when I run this, you would see that it gives me the data which is an inner join between the employee table and this multi-line function. And obviously without the where clause, it becomes a cross join. See, I commented the where clause, and now if I run it, it will act like a cross join. So it will basically multiply. The Cartesian product will be retrieved. With the where, it is an inner join. See, so this is the employee data, this is the function data. Now the outer reply is similar to a left outer join. The syntax is exactly the same. I say from let's say this is the function, and then outer reply select star from employee as E, where employee ID is equal to employee ID as Y. And when I run this, it basically gives me all the data from the function, and then only the matching records from the right table, which is the employee. And if you remember clearly, the record 100 isn't existing in the employee table, so it shows up as null. If you want to do a right join, you might ask, what do you do in that case? To do a right join, you just flip your tables. There is no right join in case of functions. So you just flip your tables like this. Bring your function in here and get your table in there, and here if I run it, see, it now gets all the data from the employee table. And if you see here, this one is missing in the function because it's 3. You remember 6 and 3, I deleted it knowingly, and then 5 is also missing because, so this is how you can join your system table valued functions with tables in the database. Okay, so in case you want to see the text inside the function, you have a function called sp-help-text, which you can use to see the content of the function. So I can say sp-help-text, and I can specify the name of the function to get to see what is there inside of it. See, I can see the whole structure of the function, is it? But this is not easy to read. So what can you make? How can you make it easier to read? You see here on the top, there are 2 methods in which you can get your output. One is results to grid. The other one is results to text. So here I can choose the results to text, and when I execute it, it'll give me the output in text. See, but by default it is the grid because we are always, most of the times we are retrieving data from tables. But this is one such scenario where text format really makes sense. So once you're done with here, you can see the whole text of the function. But let me switch back to grid. But in case you want to go back and see and you don't want people to see your function definition, you can hide it by using the with encryption that I showed you here. So this will help us in not allowing the function to be scripted out using the sp help text. So let's say I alter it using the with encryption, and it says commands completed successfully. And now if I run the help text again, you will see that it throws me a message saying the text is already encrypted. Okay, that means it doesn't allow us to see the text of the function again. So I was talking about the sp help text. Now before you encrypt it, I use the with encryption, right? And now when I execute it, it gives me a message saying it is already encrypted and you cannot see it. So one thing that you need to remember is when you encrypt something, before you encrypt it, make sure you take a copy of your function, that is the text, store it somewhere safely in a text file or in a SQL file, store it in a repository somewhere, because once you encrypt it, decrypting is a long process again. Okay, I'm not going to go in detail into that, but you need to be a sysadmin on the server. You need to do a lot of things in order to get back your function again. So make sure you store it somewhere safely before you encrypt it on the server, so that I mean, you don't want everyone else to see, so no one else will be able to see it. That's fair enough. But tomorrow when you want to update your function to something else, let's say you want to make a change, you have to get the function that you have stored in the repository and then change it and deploy it back again, because you will not be able to get the function code from the server anymore. Okay, so make sure you save it safely in a repository somewhere before you encrypt it. So that's about functions. Next up, we're going to talk about the case statement. So what is the case statement? The case statement allows us to write conditional statements during the retrieval of the data. Okay, so for example, if you want to while you're retrieving the data, you want to derive a column based on certain condition. That is when you can use the case statement. So how do you write it? Here you can say, let me just remove this complicated stuff from here. So you can say select star from employee will basically give you all the employee records, isn't it? This gives whole of the employee data. Now here, if I say to derive a conditional statement, so what I'm going to do here is I'm going to display a message based on the ID. So if the employee ID is less than 5, so I say case when employee ID is less than 5, then display a message saying employee ID is less than 5. If when employee ID is greater than 5, so this is a single statement. Okay, so when the employee ID is greater than 5, then employee ID is greater than 5 in text. Else, obviously, if it is not less, if it is not greater, then it is equal to, right? So I say else employee ID is equal to 5 end. So this is where you actually say SQL Server that, okay, this is where my case statement ends. This is mandatory again, okay? As the conditional column, this is just a name that I give to my column. And if I run this, it shows me the output in this form. So this is the employee table content, and here the conditional column. You see, here I have the values like this, which is less than 5, equal to is equal to 5, and greater than is here. Right? So when you want to generate a conditional output like this in your select, you use the case statement. Now, for example, let's say if you want to print if a text is palindrome or not. Now, what is a palindrome text? A palindrome text is the same when it is reversed. So mom is a palindrome text, which is basically the same when it is reversed. Wow is a palindrome text, okay, which is wow when reversed. Okay, so these are palindrome text. Let's say I update the first name to wow. Okay, just for an example, so I say set the first name to wow, and here let's update this one. And now what I do here is I say select star case when employee first name equal to the reverse of employee first name, then print it as palindrome, else display as not palindrome. Okay, and as this is my column name. So when I execute this, you will find that, see, this one is a palindrome name now. So it says palindrome, the rest of them are not palindrome. So it shows as not palindrome. Okay, let me update it back to Dinesh. Okay, let me remove this one and let's update this. Okay, so now there is an alternative for case which you can use only when you have two conditions. With case, as you can see, you can write up to as many conditions as you want. You just have to specify when after for each of the conditions. But when you have only two conditions, that is either a true or a false, you can use the if. So with the if, you can say if employee ID is less than equal to 5, then print this message, else print this message. So if is basically a function that accepts three input parameters. First one is the condition, next is the truth value, that means if the condition is true, the last one is the false value, that means if the condition is false, what should be done. And when I run it, you will see that it gives me the output as this. So for all the ones which are less than equal to, it says less than equal to. For the ones which are greater, it says greater than. And this one is the if condition. Okay, so you can use if. It's a function that accepts only three input parameters. One is the condition, second is the true value, third is the false value. Right? Now coming to the if statement. Okay, the if is a conditional flow. Okay, this if and case that you see is usually in the select. Inside the select, when you want to specify your conditional statements, you use if or case. But when you want to execute your queries based on certain conditions, you use the if command. So let's say if I say if 1 equal to 2, then select nice. So if I run this, it doesn't display me anything because 1 is not equal to 2, right? And if I say if 2 equal to 2, select nicer, let's say. And when I run this, it prints nicer because the second condition is true. So let me show you. The second condition is true. Now let's say I make the first condition true as well. So if I run this, you will see that it selects both nice and nicer because both of the conditions are true. Fair enough. But these two are two separate conditions. How do I make this into one condition? I say else if. That means if this is true, then it should select nice. Only when the first one is false, then it will check for this condition. See, the else condition here converts these two conditions into a single condition now, the else part. Because now it says check for this, else, that means if this one is false. So the else part connects these two statements. Else, if 2 equals to 2, then select nicer. And here, if I execute this, you'll see that it only prints nice. Although the second one is true, it doesn't print it because it only selects the first true value. Now, let's say if I make this one false and the second one is true, it prints the second one. Now, let's say the second one is also false. What will it do? It will not print anything at all. This is where the else statement comes in. So the else statement would execute when all the if statements are false. See, it prints nicest. Only when all the statements are false, then the else statement would get executed. So let me remove this. I think I did this one as well for you. Now, the begin and end is necessary in if. If you have two conditions inside your condition, I mean two statements inside your conditions, then you need to use a begin and end. If you don't use begin and end, let me show you. So let's say you just say if 1 equal to 2, then select first and select second. Let's say there are two statements. When you execute these, it prints the second although the condition is false. See, 1 is not equal to 2, but still it prints second because when you don't have a begin and end, only the first statement qualifies to be in the condition. The other one does not qualify to be in the condition. So let's say I remove the begin and the end and now execute it, you will see that it would print nothing at all. The reason is now both these statements are inside the condition. Okay, so when you want to execute two or more statements in your conditions, then you use the begin and end. Okay, I'm going to start this off by copying two tables, okay, from one of the earlier databases with the name ranking and the population. Just a moment. Do I have here? Let's say 10th May. 10th. Let's say ranking maybe. So this one, and then the population table as well. Okay, so I have both these tables with me. Okay, so in case you must be already knowing about this select star from employee. When you specify the table name as a single name, it is called as a single name qualifier. If you specify it with the schema, we call it as a double name qualifier, which means you are specifying two things to be able to for SQL to identify the table. In a three name qualifier, you specify the database name, okay, which is this name, dot the DBO, which is a schema name, dot table name to locate the table. See, if I execute, it gives us the same table itself, but in case you want to get it. See, I was able to copy it from another database, right? So I specified the database name, schema name, and the table name. You can also have a four name qualifier, which is basically, let me just get the server name. So I can specify the server name dot the database name, which is this, dot schema name dot the table name, and this would give me the same exact data. Okay, so this is how you can use or fetch data using a single name, double name, three name, and a four name qualifier, right? And as part of this module, what we're going to talk about is the order by clause, the group by and the having, except and intersect, union, and union all. Okay, so let's start by the order by. The order by is pretty simple operation wherein which we use to sort the data that we retrieve from the table. So in case I want to sort the data that I am retrieving from my table, then I use the order by. Okay, so how do we specify it here? Let's say I say select star from employee. It would give me all the employee data as is. Now let's say I want to sort it by salary. So I say order by salary. Now when I only say order by salary, it sorts the data. As you can see the data is sorted based on the salary, but in an ascending order. That means the default sorting mechanism in SQL is ascending. So if you don't specify in what order it should sort, it will sort it in ascending order. See, here I just said order by salary, right? I did not specify the sorting method. So here, when I said salary, only order by salary, it sorted all the data based on the salary in ascending order. If I want to sort it in descending, I need to explicitly specify the DESC keyword, and it would sort the data in the descending order, you can see. So it also flips the rows as well. Okay, it does not only sort this column, but the whole table itself. Now, if I want, I can apply two column sorting as well. That means I can sort my data based on two columns, but the second column sorting is only used, okay, is only used when the first column has duplicate values. That means, let's say for these two employees, which has the same salary, for these two, the employee ID sorting would be used. Okay, whatever second column you specify. So the second column sorting is only applicable when this first column has duplicate values or the same values. So here it shows 3000 and 3000. That means here it will apply the employee ID sorting in descending order for only these two. For the rest of them, it will still be on the salary because they are distinct values. I mean, they are one value each. So if I run this, you would see that everything is still the same, but only for 3000, if you see internally, the employee ID is first 5 and then 3.
Just a quick info, guys. Test your knowledge of SQL by answering this question. What is the full form of SQL? A. Structured query list. B. Sample query language. C. None of these. D. Structured query language. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
5 is basically higher than 3, right? So it's in descending order. Let's say I make this ascending. let's say make it ascending. So when I make it ascending, you'll find that for these two, the employee ID is now 3 and 5. So you see the difference? So the second column is only applicable when the first column has the same value. Now let's read what I have mentioned here. So I mentioned in the notes, I've said when there is a request from the business to deliver reports or metrics of some analysis, they might need the data to be arranged in a particular order. Okay, sometimes they might need it. So in that case, we use the order by clause, which helps us in ordering the data in either ascending or descending order. And as I showed you, the default ordering mechanism in SQL is ascending order. And if we want to force the sorting to be in descending order, we need to specify it explicitly with the keyword DESC. And we can have the sorting applied on more than one column in the table, as I showed you. But the second column is only used when the first column sorting returns the same value. And you have to specify the sorting mechanism for each column individually. That means, let's say you apply descending, it is only applicable for the salary column. For employee ID, you need to specify it separately. Now, if you don't specify either of these, that means SQL will sort the data in salary in ascending order, employee ID in ascending order. Only if you provide the keyword here, then it'll use these. So let's say I have a third column here. Let's say I have a column X here. This column would be used for sorting only when these two have the same data for 2 or more rows. Only then the X column would be used for sorting. We can also order data or sort data using the column position or the index of the column. Like for example, here if I say, let's say select star from employee. So what do I get here? I get all the data from the employee table, isn't it? Now, if you see here, the salary is the fourth column, employee ID is the first column. So I can say here order by 4 descending. 4 is basically salary in descending order, and 1 also in descending, like I had in the above query. So you can also use the column position and it should work well. But the problem starts when someone messes with the column list here. You see the star here? If someone replaces it with the columns, now the position goes for a toss. See, the fourth position is address now, and the first position is first name now. This is where it goes for a toss. So we don't prefer using, so now although I still have the order by same, but only because the selected columns changed, now it is based on the address and on the first name, which is not something that we want. So that's the reason we always keep it with the same column names. We sort it based on the column names and not on the index or the position of the column. This is not the ideal way. As I said, cases when the select statement is altered might be bad for this kind of sorting method. Right. Now, the sorting is different for integer values and for the string values. So for integer values, it can store only numbers, correct? So when we sort it, it will sort it as a whole number. That means it'll be in, if I put this in ascending order, it'll be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and then so on. And it'll keep increasing like this, 1, 1, 1, sorry, 1, 1, 1, 2, 2, 2, 3, 3, 3, and so on. So it'll keep increasing like this. But for a string data type, what it does is it does not consider for string sorting. Let's say for this one, DINESH and DIANESH. So how does SQL know which one should be put first, which one should be put next? It cannot compare the string as a whole. So how SQL compares it is, it will compare character by character. So D is the same, I is the same, and then it has N when compared to A. So if I sort this in ascending order, this will go on the top and then Dinesh will be stored, only because the third character is A here and N below. Okay, so string characters are not compared as a whole. It is compared one after the other. So the integer values in the string columns are also compared that same way. So it first compares the first value in each of the rows and then moves on to the next one. So that is the reason 2 is considered greater than 1111 because it only compares the first value while sorting it. And if the first value is the same, then it compares the second value. Okay, let me show you with an example so that you're clear about it. So here I'm going to create a table. Let's say the table name is integer sort, and I create two columns. I create one column here, ID, which is of type integer. Okay, and here what I do is, okay, so here let's create a table which is int sort, and it has one column which is ID of type integer. And when I execute it, let me create this table first of all, and then let me try to, now that the table is created, let me insert these values into the table. It's basically 1, 2, 3, and there are a few numbers here. Okay, I'm inserting into the integer sort table. So let me execute. It says 9 rows affected. And now if I try to select from int sort, let me show you. It has the values in it. Let me try to sort them in ID ascending. And if I run it, you will see that it gives the highest value first, and then 111, 44, 22, 12, 11, which is perfect. Let me sort in ascending, and you will see that it is perfectly sorted. See, 1, 2, 3, 11, 12, 22, 44, 111, 222, which is fairly good enough because these are numbers and it should be sorted in this way. Now, let me show you a different thing. Let me create another table called the text sort, and in here I put the column as ID. The column name is ID, and this time the data type I'm putting it as varchar 10 characters. Okay, and let me create this table, created, and I insert the same set of values into the text sort ID column. The ID column is a varchar column, mind it, and let me insert these values. Okay, perfect. 9 rows. Let's see the text sort table. Select, and you have all the values, right? Now let me try to order it based on ascending and see what happens. So let's try to do it ascending and run it. See this. We get 1, 11, 111, then we get 12, 2, 22, 222, and so on. Then we get 3 and 44. So it basically compares character after character instead of the whole number. Okay, so similarly, if I do a descending, you will notice that it has 44 first, then 3, then 222, then 22, and so on. Okay, so the top clause helps us in fetching the top n records during the select statement. So if I just say select star from employee, it would get me only, the whole employee table. Now if I want to see only the 2 records from the top, I just do this. Now if you, let's say you want to see the top 1 salary, highest salary, you can say top 1.
Just a quick info, guys. Intellipaat provides Microsoft SQL certification training in partnership with Microsoft. The course link of which is given in the description below. Let's hear what our customer says about the course. Did you get any promotion or appraisal in your current company after completing the course?
Yeah, I just recently become as a lead in my organization. So after completing this course, because I have other 2-3 projects I have completed with the success story. So yeah, I got a promotion.
Now let's continue with the session.
Star order by salary descending. So it'll give you the employee who is earning the highest salary, because see, I'm sorting it and then I'm picking the top 1. So the order by executes first and then the top. Okay. So next is the distinct clause. The distinct helps us in fetching the distinct records from a table. So let's say I select only the salary column. Let's say I select only the salary column from the employee table. So I get only the salaries, right? But as you can see, there are 3,000. Okay, let's say I want to get the distinct salary, or let's say the address maybe. Okay, this is more meaningful. Let's say I want to select the address. So I get 4 India and 1 Australia and 2 US. Now let's say someone says me, hey, can you get me all the addresses from where our employees belong to? I cannot give them this list, right? Because it has duplicate values. So in that case, I can use the distinct to be able to get only the distinct addresses. Here now I only get 3 values, right? But now let's say I added with the employee first name and execute it. See, I again get 4 India and 1 US and 1 Australia. Now why did I get 4 India again? Because now the distinct works on all the columns that you have put on select. So here I have put 2 columns on select, right? So it fetches me all the records from the distinct of all these, both these columns now. So India and Dinesh is only one record. So it just shows it is not duplicated, as you can see. So the distinct gets us the distinct across both these columns now. Now let me remove the distinct here and you will notice something different. See, for the US record, we have both the employees as US and John. I mean, the address is US, then the first name is John. So when I put the distinct, you will see that I get only 1 US and John because the other one is also the same. So it got duplicated. Now let me put the employee last name here as well. And if I execute, now I get two records for US as well because the last name combination is not unique anymore. So the distinct helps us in fetching the unique records from a table, or in fact of the selected columns. And when the distinct is applied on more than one column, then it removes the record if it is duplicated across all the columns. You see here, it gets duplicated, it gets removed, only it is duplicated across all the columns. So if you want to get the top 2 highest salary from the employee, you can say select distinct top 2 salary from employee order by salary descending. And here if I run this, I get 5,000 and 4,000. Okay. So next up, let's talk about group by clause. Okay. So how does the group by help us? The group by, so you've known about aggregations, right? So if you want to get the maximum salary, you get it by saying max of salary from the table. If you want the minimum of salary, you say select minimum of salary from the table. Now, if you want to, let's say, get the maximum of salary per address, minimum of salary per address, or minimum of salary per department, that is when we use the group by. So the group by helps us in grouping the data based on certain values like the address, the departments, or anything. Okay, so let me show you with an example. So I have the population table here, which is a very simple table with 4 columns: country, city, town, and population. So each country, as you can see, there are 2 countries here. Each country has 2 cities, city 1 and city 2, and then city 1 has 2 townships, T1 and T2. City 2 has 2 townships, T3 and T4, and then city 3 has 2 townships, T5 and T6. City 4 has 2 townships, T7 and T8. Clear enough? So it's a very simple table, and at the end we have the population for each of the townships. So T1 has 100 population, T2 has 23, T3 has 87, T4 is 98, and so on. Now, if I want to get the sum of population from the population, so there is a column called population, and the table name is also population. Okay, so if I say select sum of population as sum of population, this is just a alias name, and if I run this, this gives me the total population in the whole table. If I want to get the population country wise, I use the group by. I say select country, comma, the sum of population from population. This is where I say group by the country. And now it gives me per country what is the sum of the population, right? Similarly, if I want to get the population based on a city, I say select city, comma, the sum of population group by the city. So now I get per city how much is the population. If I want to get it based on the country and the city, I say country, city, sum of population from population group by country and city. Perfect. Grouping the data based on the aggregated, based on the columns that you have chosen for aggregation. I say select city, sum of population as sum of population from population. And here before the group by, I say where city in city 1 or city 2. Okay, so when I run this, it'll only group the data it'll first filter it and then group it. So if I run it, it'll filter the data for me saying, okay, get only for city 1 and city 2, and then group the city to get the sum of population. So see, I get only city 1 and city 2 because I specify I need the data only for city 1 and city 2. This is normal filtering. Now, what if I want to filter my aggregated data? If I want to filter my aggregated data, we need to use the having clause. And the having is usually accompanied by the group by. You cannot use the having without a group by. So here, let's say I want to get only those cities. Let me comment this one. I want to get the first, I want to group it based on the city, and I only want to see the cities which have population less than 150, the total population. So I can execute this query and I get these 3 cities. The other one, I didn't get it because let me show you. I didn't get city 2, correct? So if I execute this, I get only 185. I mean, I don't get city 2 because it is 185. The population is 1, which is greater than 150. Okay, so the having clause helps us in filtering aggregated data, which cannot be done by the where clause. If I put this where sum of population is less than 50, it won't work because the where clause, let me run this and show it to you. See, an aggregate may not appear in the where clause. So you can only use it in the having here. Me execute and I get only city 1 because I've said in city 1 and city 2, and then I'm using the having. But if I remove this where clause and execute it, so the where clause is applicable before the grouping, the having is applicable after the grouping. Okay, now I remember someone had a question as to in what sequence does the query executes, and this is what it is. So we start from a from, right, from where the table has been, what table has been specified. Then we go on to the join, which is the inner, outer, or cross, whichever it is, and then the on clause, that means on what columns it needs to be joined. Then obviously the filtering happens. Then if you have a group by, that gets executed, then the having executes, then the distinct executes, and then the order by the top, and then the select at the end. The select and the column list, it executes at the end. Okay, so obviously the select is on the top, but it executes at the end of it. So this is the sequence in which your queries execute. Okay, so we have already discussed about union and union all, so I'm not going to talk about it much. But one thing that I want to add is, if you see here, I showed you this example, correct? I mean, I showed you how the hard-coded data sets only retrieve or get us the unique records. The union gets us the unique, whereas the union all gets us everything without checking for duplicates. But with union and union all, you can also select from the tables. Like, see, you can here I'm selecting employee ID first name from employee, and here I get what 1 Dinesh, 2 John, and 3 Santosh, and a lot of other employees, right? I can use a union and select from primary key test. So let's see what the primary key test has. The primary key test has 1 Dinesh and 2 John, which is the exact same as the first 2 records in the employee. Let me just show you. See, the employee has 1 Dinesh and 2 John, and then the rest of the employees. But in the primary key test, we have 1 Dinesh and 2 John. So I can put a union here in between both the selects to combine them and get one result set wherein 1 Dinesh and 2 John is retrieved only once. If it was union all, okay, which is right below, you should have ideally got 2 Dinesh and 2 John. See here. So this is how the union and union all works with multiple tables. Okay, earlier I showed you only on one record, only on hard-coded values, but now I just showed you with tables as well. Okay, so you can add more tables as well if you want to do it. I mean, let's say I execute this. See, I get two more records. Sorry, 3 more. Okay, so the union all, but one thing that you need to remember is the columns that you're selecting here should be the same. Now, let's say from the employee table, I get what? 5 columns. Now I cannot say start from employee union all start from primary key test, because the primary key test has 2 columns and the employee table has 5 columns. I cannot do this. See, it throws me an error saying all queries combined using union, intersect, and except must have equal number of expressions in their target list. That means whatever number of columns you have in here, it should be the same number of columns in here as well. But it's not the case. So that's the reason we need to make sure that the columns are exactly the same. Okay, now it works. There is a except operator which we can use to retrieve. Let's say there are 2 tables, default test and primary key test. Okay, let's say there are 2 tables like this. So if I say this except this, what output do you expect? This except this, what output do you think will be coming out? Except is basically these 2 records except these 2 records. So that means get me all the records which are in this table which are not there here in the other table. So it's like this, ID and name from default test except start from primary key. I mean, I can do the same here as well. I mean, it makes no difference because a primary key test has only 2 columns. So if I run this, you will find 2 no name provided because this is the only record that is present in this table but missing in this table. But one thing that you need to remember, the except works like a union or a union all, wherein the columns should be the exact same. I mean, not the name of the column, but the number of columns that you have selected. Here we have 2 columns. Here we should have 2 columns. The first one is integer, second one is varchar. Here also the first one should be integer, second one should be varchar. So when I run this, it gives me the records in this except the records in this, which is 2 and no name provided. Now the other way around, if I say primary key test except default test, I should get 2 and John, isn't it? Because 2 and John is present in this but not in this. So let's say if I flip my tables, I say primary key test except default test. So it'll now give me 2 and John. 2 and John is present in the primary key test but missing in the default test. Okay, next is the intersect operator. The intersect operator fetches the common records across both of them. Now this is different than the joins. Okay, the join helps us in joining the data one next to the other, but this is more of a vertical combination of the records. Okay, this takes into account the whole row instead of taking columns to be joined. Okay, so here I say ID name from default test intersect the primary key test. So it should give us the common record, and the common record is 1 and Dinesh. So if I flip the tables also, it should be the same, right? Because the common record isn't going to change. The except, yes, I agree, it should be different. But when I say intersect, both of the queries should return the same output. Now coming to another interesting aspect, which is the ranking functions in SQL. So what are ranking functions? Ranking functions helps us rank the data. Now, a very common question could be the 3rd highest salary, the 4th highest salary, the 6th highest salary. How do we find them? We use the ranking function. So what are the different type of ranking functions that are available? First is the row number, rank, and the dense rank. These are the only 3 ranking functions that are available with SQL Server. Now, how does each of them work? The easiest thing, the good thing about these is that you have the exact same syntax for all of them. Okay, so how do we write them? Let's say select star from I have a ranking table. If you remember in the beginning of I created 2 tables. One was the population, which I've already shown you. The other is the ranking. The ranking basically has 2 countries, as you can see, A and B, and then it has cities inside each of the countries. Okay, and then the population against it. Very simple table, 3 columns, country, corresponding cities, and the population. Now what I'm trying to do here is, if I want to get let me show you how you can apply the ranking functions on top of this data. So here I say, instead of select star from ranking, I just add one more column here saying row number. Okay, this is the syntax, row number, bracket open, bracket close, over, and then order by the population. So if you're ranking it, you need to basically provide a column on which the ranking should be done. Sounds good? Because so the questions that you get, the queries that you might have is get me the ranks in order of salary. Get me the third salary, get me the fourth highest salary. So you need to sort it based on the salary, and then you can get the ranks, right? So here I want to sort it based on the population and get the rank for each of the country, each of the city. So what do? I say star, comma, row number each of the rows over order by the population in descending order. That means the highest population should be given the first rank, and then the subsequent ones will follow. And if I run this, it will give, see, as you can see, it sorts this whole table in the based on the population, and then assigns a rank value each. The rank value is just the alias name that I've given here, as you can see, RN key value. So it sorts them and gives a row number to each of them. But observe this, this has the same. So the country A has two cities, M and G, which has the exact same population, and it gives them two different rank values, and that's the property of the row number. That is how the row number works. It basically sorts the data based on whatever sorting mechanism, sorting column you have specified, and then assigns a row number to each of the records. Okay. The next is the rank function. The syntax is exactly the same as I told you. I mean, the good thing about these is that the syntax is exactly the same. So I just replace the row number with the rank. Now the rank, let's see what is the difference between the two. The rank function again sorts based on the population, but now if you see, for the same value it gets the same rank, but there's one catch. You see, the next one skips a value. So if there was another city with the same population, it would have got another 3 here, and the next one would have been directly 6. So as many ranks that are used up by the same value, that many row numbers are skipped. So here we had 2 with 3s, so the next one skipped only 1, so it is 5. If we had 3 with the rank 3 records with the rank 3, then it would have been a 6. Okay, now the dense rank works exactly like a rank, but the only difference is that the skipping of the rows is not available here. The ranks are not skipped anymore. You see here, after 3 we get 4 directly. Okay, there is no skipping of the ranks. Similarly, these two values are the same, but this one does not skip any rank. Okay, now you might say, hey Dinesh, so how do I get the highest? So this one I can easily get the third highest or the fourth highest population from the whole table. But what if I want to get the second highest salary per country? How do I get it? So that is where you can use another property of the ranking functions, which is the partition by. So the partition by acts like a group by. Okay, here what we specify is, I say exact same syntax, but here you can say over partition by country.
Just a quick info, guys. Test your knowledge of SQL by answering this question. Which of the following is not a valid aggregate function? A. Count. B. Sum. C. Max. D. Compute. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now let's continue with the session.
That means the country A will have its own set of ranks. Country B will have its own set of ranks. Let me run this and show it to you. So we have the partition by country, and then exactly the same, however it was. So if I run this, you will notice that for all the records of A, you get one set of values. Then from B, it is reset again. See, it starts from 1 again. Make sense? But the property of the row number still stands valid. For the same, you get 2 ranks. Coming to the rank, again, let me show you by adding the partition by here. And if I run this, you will see that the same population value gets the same rank, but the next one skips a value. This is the property of the rank function itself. Okay, the reason it skips 1 row is because there are 2 ones here. Let's say there were 3 ones, the next one would have had 4 directly. Okay, so as many number of rows that have duplicate values, that many number of ranks are skipped in case of rank. Okay, the dense rank exactly works exactly same as the rank, but the only thing is there is no skipping of ranks that happens here. You see here, so we get a set of ranks for A, we get a set of ranks for B. So now if I want to get the second highest salary or second highest population from populated city from A and B, I can say so let's say here, let's say third highest populated state from each country. I say partition by country. Partition by country, and let me run this. So what you will see, you already know how it works. The dense rank, it gives us the same rank, and then the next one doesn't skip anything. So it's as I partitioned it, A has its own set of ranks, B has its own set of ranks, and I put this inside like a subquery. As you can see, this acts like a table. So I say select star from this one as X, where the rank value is the alias name for this one is equal to 3. So if I run this, it gives me 2 records. So for A, city Z has the third highest population. B, for city P, this is the third highest population. For country B, this is the third highest population for country A. Now, if you want the third highest population for the whole table, you don't use the partition by, because then it will not rank it based on the country, but based on the whole table. And if I run this, see, I now see that, okay, country A has 2 cities which has the third highest population across the whole table. Let's move on to another interesting topic, which is about indexes. Okay, indexes are pretty much fun to work with. Why do we need indexes in the first place? The importance of indexes has picked up drastically over the last few years, owing to the fact that we are now using SQL Server to store huge amount of data. Okay, earlier it used to manage like small relational databases, but now that Microsoft has been standing up to its expectations, companies are trusting SQL Server for their go-to RDBMS. So they are pumping in a lot of data, and Microsoft is on top of all these expectations, ensuring that whatever data being pumped in, like irrespective of the volume of data that's been pumped in into any SQL Server, the SQL Server performance should not take a hit. Okay, if not be like awesome. I mean, they don't want the performance to be like great, but it should not at least deteriorate over a period of time. That is what Microsoft's whole motive is behind building indexes. Now, what exactly happens when we write a query? Let's say I write an update, let's say I write a select, let's say I write a delete. Okay, now when I'm trying to fetch data, it could be a plain select. Now, what do you think takes the maximum amount of time? Let's say I say select start from employee where employee name equal to Dinesh. Now, what do you think takes time in the query? Let's say the query takes 5 seconds. 80 to 90% of the time, or I would say to generalize it, maximum amount of the time is taken by SQL Server to locate the employee with the name Dinesh. Displaying it doesn't take time. Okay, but locating the row itself takes the maximum amount of time for any query, maybe. Okay, and with indexes, SQL Server tries to give us a mechanism which we can use to locate the rows faster. And if SQL Server can locate the rows faster for us, obviously our query will start executing faster. You get the link? The whole motive, okay, this is what the base target of an index is. The base target of an index is to be able to locate the rows faster. And if you can look, the earlier the records can be located, either selecting it, updating it, or deleting it isn't going to take any time at all. Okay, so let me walk you through in detail about indexes and see how they are helpful. So indexes are routes to high performances in SQL Server. And as I explained you, indexes help in faster access by providing swift access to rows in the data tables. Now, how does it do that? I'm going to explain you in a phased manner. This is very similar to an index page in a book. Now, let's say you are given the exact same book to you and your friend. Okay, you guys have the same exact book. Now, you know what an index page is, right? The table of contents that we have in the beginning of the book, wherein it says this topic is located at this page number. This topic can be found in this page number. This topic can be found in this page number, right? So what we do is, now let's say I ask to both of them to locate the topic on joins. Let's say, obviously, I mean, it's a book on SQL, so there will be a chapter on joins. So I just wanted to check where exactly is the, I want both of them to locate the page where the chapter about joins is there. Now, in which case do you think the individual will be able to locate the page faster? Obviously, the individual with the book which has the index page in it, because he can directly read through the index page and see which exact topic has the topic on joins, and can directly seek to that part of the book instead of checking one each page. But the other guy, he has to scan through the whole book from the beginning till he locates the topic or the chapter on joins, right? And that is exactly how SQL Server indexes work. If you have an index, it is like a book, it's like a table of contents for the whole table. Whereas if you do not have an index, SQL Server will have to search through all of your records to be able to locate that record for you. Now, you take a call which one is a faster approach. I'm going to show you, okay? I'm going to explain you in detail, don't worry about it. And as I told, Microsoft is on top of this, okay? It's like every release of SQL Server that you get, the maximum amount of changes, you will see a lot of changes, in fact, on indexes that's been done by, or that's been released by Microsoft. Okay, with the growing expectations, with the growing base of customers for SQL Server, Microsoft has to stay at the top of its game in order for it to stay long in the market. Now, the one worst thing that could be associated with the RDBMS is its performance aspect. If there is one organization who starts complaining about RDBMS on its performance aspect, that's the that's the worst that can happen with the RDBMS. Okay, when we store data in RDBMS, I mean, data is very important in today's context. And if you are able to store the data efficiently, but when you're extracting it, you have performance issues, you have data issues, I mean, that's the worst that can happen to any RDBMS. So Microsoft has to ensure that the performance or the experience of the users are always top notch, right? So it does a lot of changes to the way the indexes are structured and organized at in every release that is done for SQL Server. Now let's talk about the structure of the index, basically how the indexes are structured internally. Okay, so indexes are created on tables or views. We are going to talk about views, okay, at a later point in time. They provide, as I told, faster access to the data using the column on which the index is created. Now let's say we create, so as I said, we create indexes on columns in the tables, right? So indexes are created on tables, but internally they are created on the column. So we specify on which column should the index be created. Now let's say I'm trying to fetch the name or the address and my index is on the ID. So it's not always that you need the index to be on the name or on the department to be able to locate them faster. It could be on the employee ID as well. And the moment the employee ID is located, the rest of the data for that particular employee will be very easy to locate. Okay, so they provide faster access to the data. And when I say data, I'm referring to the whole data row using the column on which the index is created, or as we call it as the indexed column. Indexes internally are B tree structures, or as we call it as binary tree. I don't know how many of you are aware about data structures, but we have something called as a binary tree, which has parent and child structure. So basically each parent will have two child nodes. Similarly, that the two childs that we have will have two child respectively, and it keeps going on. So that's the reason it is called a binary tree, because each parent has binary or two children. Okay, so these are binary structures which helps us in flattening our tables and hence providing easy access to the data rows. Okay, now I'm again going to explain this in detail at a later point in time, but imagine this example. Okay, let's say you have a set of 10 t-shirts. Okay, 10 t-shirts which are placed one after the other in a queue, and you are looking for one t-shirt. So what do you do in order for you to search for it? What you do is you search one by one, starting from the first until you reach your t-shirt. But imagine all of them are in a circular pattern and it's been just shown in one line to you. Searching it becomes a little easier, isn't it? So that is a part of how indexes work. Okay, but there are more technicalities to it that I'll be explaining you. So that is what flattening means. So you don't have to like run through the whole queue to search something, but instead you have a more flattened version so that you don't have to recursively loop through all the levels. Okay? Without an index, a table is called as a heap. So any table without an index, we call it a heap. And we can create indexes on most data columns in a tabular view, except for a few, which are the blob data types, image data, text data, and varchar max. Okay, I'm going to explain you, once I explain you how indexes work, you will clearly understand why SQL doesn't allow us, or why it is inefficient, or why it should have been inefficient if SQL would have allowed us to create this, would have allowed us to create indexes on these data types. But indexes are very, very effective and efficient when created on a unique integer column. Okay, so again, you're going to understand both these points once I explain you in detail about indexes. Now let's say there is a table. Let me give you an example. Let's say there is a table with let's consider this as an employee table itself. It has ID, name, designation, salary, department. So 5 columns, and here I've just displayed the ID column. Okay, let's say there are 20 employees in the whole table. Now let's say I write a query saying select star from employee where employee ID equal to 10. Okay, this is a very normal table that you see. Okay, imagine this has no indexes at all. Forget about indexes. This is a very normal table, and on top of this, this has 20 records, and on top of this I fire this query wherein I want to fetch the employees where employee ID equal to 10. Now what will be the expected output? It'll give me all the employees which has ID 10 in it. Am I right? So if there are 5 employees with ID 10, it should give me all the 5 employees. So what does it do to figure out all the employees which has ID 10? It first checks the first row to see if the ID is equal to 10 here. So 1 is not equal to 10, so it skips this row. Next, it moves to ID 2. It checks if 2 is equal to 10. No, it is not. So it moves on to the third row. It continues this way to make sure, or it makes sure that it compares all the IDs with 10 and fetches those records which are equal to 10. Like for example, this record would be fetched. Let's say there is another 10 right before 20. That 10 will also be fetched. So whatever number of employees has employee ID equal to 10, all of them will be fetched and displayed. So in a way, SQL will have to, the optimizer will have to check through or compare all the 20 rows in the table to be able to figure out all the employees which has ID 10, right? So in this case, without an index, the SQL optimizer will have to perform 20 reads. Let's assume that this table has 20 records. It has to perform 20 reads to locate all the IDs, all the employees with ID 10. And this approach is referred to as a table scan. That means the whole table is scanned for it to return the result that I'm looking for. Now let's see what happens when we create an index on it. So let's say I create an index. The index, as I told you, it creates a binary tree structure. So let's say I create an index on the ID column. So what happens is when I create the index on the ID column, it tries to create a binary structure internally. So how does it do it? The parent will be 1 to 20, so there are 20 records, right? So there will be two nodes for this. So 1 to 10 can be found on the left hand side. So every node will have an upper range, will have a lower range. So here the lower range is 1, upper range is 10. On the right hand side, I mean on the other node, the upper range is 20, lower range is 11. And then 1 to 20 might have another two child nodes, okay, very similar to how the first level went. And the same thing can be for 11 to 20 as well. And then these are basically the bottommost leaf nodes where you will find the data for those particular rows, right? So let's say here after 1 to 5 it has two children, 1 to 2 and 3 to 5. That means you will find all the details for employee ID 1 and 2 in this leaf node. You'll find all data for employee ID 3, 4 and 5 in this leaf node. Now let's try to run the same query using this approach. So what does SQL do now? In case there is an index present, what it will do is it will know that, okay, I'm looking for ID 10. So all the 10s, I'll find it here because the left hand, the first node, child node, has a lower range of 1 and higher range of 10. So all the IDs will be, all the 10s, I can find it in this part of the node. And from here, I traverse here and then ultimately it'll locate here where all the 10s can be found. So with an index, it takes up to what, 1, 2 and 3 reads to locate the whole data or the whole record for ID 10. So maximum, I would say it would take up to 3 reads, and this approach is called as the index seek, wherein the data is directly seeked. Okay, SQL directly seeks the value that it is looking for. Instead of scanning everything, it just directly seeks through the nodes to be able to locate those particular IDs that you're looking for. Okay, and this is what flattening of a table means. Now, this has up to 20 levels, so it has to scan all the 20 levels, but here it has to scan maximum of 4 levels. Now this the current when I'm talking about the real SQL Server, I mean this is just an hypothetical example, okay, of 20 rows that I'm giving, but SQL Server has a more sophisticated, I mean a hugely sophisticated mechanism to handle this, and I don't think for 20 records it will have at least these 4 levels. It'll be way less than let's say thousands of records, you might have only 1 level. It doesn't even go to more than 1 or 2 levels. Okay, so that is how SQL does it internally. But again, this is just an hypothetical example so that you understand this clearly. And this is what the B tree structure looks like. And as you must have noticed, the whole onus of this particular structure being created by SQL Server lies in the fact as to how easy it is to sort your data, how easy it is for SQL Server to arrange your data, right? And integer sorting is very easy and comprehensive. But when it comes to varchar sorting, the limitations that are there. Plus, varchar sorting is a lot more memory extensive, lot more time taking than integer sorting. Okay, so greater the varchar value, greater the string value, bad is going to be the index performance. I mean, the impact of the index is going to be negligible because creating the index and then sorting it like this and arranging it like this is going to be a huge task for SQL Server. So I'm not a big fan of creating indexes on varchar values at all. Okay, SQL forbids creating it on varchar max, which is when you have a column of 8,000 characters long. It only forbids that. So you can create it on columns which has varchar 100, 200, 300, up to 7,999. But I'm not a big fan of creating it on varchar values at all, varchar columns at all. So this is the reason SQL forbids creation of indexes on a few column types. Now the second thing is, I told you why integer is preferred, why integer data type is preferred. But the best thing could be if you can create an index on a unique integer column. Now, why do I focus on unique keyword? Because the uniqueness of your column determines how your index structure is balanced. Now, let's say you have 10 records with ID 10. That means you have duplicate values in there. So now what will happen is when you have 10 records with ID 10, this particular node will be heavier when compared to this particular node. Am I correct or wrong? Because here, as I said, the upper range is 10, sorry, the lower range is 10, upper range is 10, lower range is 1, upper range is 10. So that means we'll have 1 till 10, all the records in this part on the left hand side of the node. So that means if let's say there are 10 records with ID 10, I'll have 19 records on the left hand side and 10 records on the right hand side. So obviously this part of the node will perform slower. The left hand side of the node, the left node will perform slower when compared to the right node, because on the right node there are only 10 records, on the left node there are 19 records. Okay, so this node becomes heavier, ultimately this node becomes heavier, this node becomes heavier. So when the query hits this node, okay, or any of these nodes, it works faster, the data is retrieved faster comparatively when compared to this part of the node, the left hand side of the node. So that's the reason, if you want to keep the index performance consistent, make sure you create your index on a unique integer column. That's the best. Okay, it's not like SQL doesn't allow you to create it on non-unique columns, but it's just that the index might not be efficient enough. Okay, now that you understand the indexes, let's just understand what are the, let's just go read about what are the different types of indexes that are involved. Okay, and then I'll show you the demo on how indexes enhance the performance of queries. So let's talk about the types of indexes that are available. The two important types of indexes that you have are called as clustered indexes and non-clustered indexes. Now the clustered indexes, in the clustered index, the complete data row is actually stored in the leaf node of the index. Now when I say that, what I mean is, you see this is the leaf node, the bottommost leaf node. So here what you will find is, let's suppose this node. So this node will have the whole of all the data or information for employee ID 8, all the information for employee ID 9, all the information for employee ID 10. That means all 5 columns that I was talking about: employee ID, name, designation, salary, and address, let's say. So you'll find all the data in here itself, and that is what I have mentioned here. The complete data row is actually stored on the leaf node of the index in case of a clustered index. Okay? The index column is either arranged in ascending or descending order. As I told, it requires sorting, and that is where it is more efficient. The better the sorting is available, the better the sorting, the better is the performance. And this sorting is done physically in the data drive itself or in the table itself. That means, let's say you have inserted records in the order 1, 5, 4, sorry, 1, 5, 4, 9, 7. Okay, when you create an index, let's say on this column, you will now get the data. I mean, whenever you select the data from the table, you will get it in this format: 1, 4, 5, 7, 9. So that means the data will be sorted like this. So
just a quick info, guys. Intellipaat provides Microsoft SQL certification training in partnership with Microsoft. The course link of which is given in the description below. Let's hear what our customer says about the course. Did you get any promotion or appraisal in your current company after completing the course?
Yeah, I just recently become as a lead in my organization. So after completing this course, because I have other 2-3 projects I have completed with a success story. So yeah, I got a promotion.
Now let's continue with the session.
When you create a clustered index, whenever you create a clustered index, the indexed column is physically sorted in the table itself. I would say in the table. Okay, that means when you select the table, you will see that the data will automatically come sorted. You don't have to put the order by, and that is done by the clustered index. Okay, when you create a clustered index, it automatically sorts the data. So whenever you select the data, it will come by default sorted. And that is the reason you can have only one clustered index per table. Remember, because the second column ordering has negligible impact, right? So that's the reason you can have only one clustered index per table. Now, you can include multiple columns in the clustered index, right? As I told, you can have only one cluster index, but you can include two columns. Like let's say the combination of name and ID is unique. You can include two columns in your or name and address is unique. You can create name and address as a clustered index on name and address both together. Okay, there'll be one index, but internally it'll have two columns. Now you can do that, but I don't usually recommend it. Again, imagine this structure being built for two columns. Obviously it will not be efficient when compared to a single column, right? So I usually say create it on one column which you think is a primary key, and that's the reason I always say that whenever you create a table, create a primary key in it, so that you can create a clustered index. In case that table grows to a lot many records, you have the liberty to create the clustered index on the primary key, because the primary key is both unique and not null, so it's easier that way. Table with a clustered index is usually referred to as a clustered table. That means any table with a clustered index is usually referred to as a clustered table. Now coming to the non-clustered index, there's a slight change. There are a few things that are different from the clustered index. Unlike the clustered index, here the leaf nodes does not store the actual data row. Now here what happens is, so as I was saying, in case of a clustered index, the whole row is stored in this leaf node, right, for 8, 9 and 10. But in a non-clustered index, what we'll have is we'll have the indexed column, which is 8, and then there will be an address pointer that will point to the actual row of the table, okay, where exactly in memory that row is present. Similarly, 9 will also have a pointer that points to the memory location of that row. The same applies for 10 as well. This is how the non-cluster index works. So SQL has to perform one extra operation after locating the row, wherein it has to take the pointer, go to that particular address and fetch the whole row. And that is what makes non-clustered indexes a little slower than clustered indexes, because in clustered index, the optimizer can locate the row in the leaf node itself. So it doesn't have to go anywhere else. But in a non-clustered index, it has to take this pointer, go to the memory, and then fetch the record from there. So locating the row is still fast in case of a non-clustered index, but taking the pointer, finding it in memory, and locating the row takes that extra little bit of time, which makes non-clustered indexes a little slower than the clustered indexes. As I said, instead it stores a pointer or memory address to the row in the memory, so that SQL optimizer can extract that whole row. Now the non-clustered index column, the data is sorted but on the fly. So you will not find the data sorted as I showed you in the non-clustered index. You will not, that is not how the data would be sorted in the disk. It would be sorted but on the fly. Okay, so the structure will be created on the fly only for that particular fragment. It won't do it for the whole thing. It won't sort it on the table itself. And that is the reason, as it does not physically sort the data, you can have more than one non-clustered index on a table. To be specific, till SQL Server 2005 used to Microsoft used to provide 249 non-clustered indexes, but 2008 onwards you can create up to 999 non-clustered indexes. Not that I would recommend you to create that many, but yes, you have the liberty to create up to 999 non-clustered indexes per table. Okay, this is per table I'm talking about. So let's get into an example. Let me explain you with an example as to how this actually, how the indexes actually speed up the performance or make the performance better for the queries. Okay, so what I'm going to do is I'm going to use the same table which is on a different database. I'm going to extract it or copy it into two tables in our database, one with the name index test, one with the name index test underscore CI. That means the table names will be different, but the content will be exactly the same because I'm copying from the same table from a different database. So let me execute this. So I get 10,000 records each. Let me comment this back again. And if I show you this table, it has only two columns, ID and name. Okay, ID is 1, 2, 3, 4, 5. It's an auto increment value, and then the name is nothing but Dinesh appended with the ID itself. Okay, and we have this for 10,000 records. Let me show you. See, it is there till 10,000 records. Okay, and the same is for the other table as well. As I told, both of these have the exact same structure and the exact same data. As you can see, this is the one. Now, the reason why I gave this a different name is because I'm going to create a clustered index on this table. This is underscore CI. Now, none of these have indexes in it because these are normal tables, right? I just created them. So how do I create a clustered index? So I say create clustered index, okay? And then you give a name to your index. So here I say ix underscore, and then to make it, as I always say, name your objects so that you can look at it and know or tell a lot about it. Like here I say ix underscore, which from which I can know that okay, this is an index. Then I have the table name here, and then on which column am I going to create the index. So I have ix underscore table name underscore id, and then I say on, that means create the clustered index on index test underscore ci. This is the table on which I'm going to create the index, and the column name is id. So I'm going to create the clustered index on the id column in index test underscore ca.
Just a quick info, guys. Test your knowledge of SQL by answering this question. What is the full form of SQL? A. Structured query list. B. Sample query language. C. None of these. D. Structured query language. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
And let's create this. So it says commands completed successfully. Now, how do you know if there is an index or not? You can double click on the name, use Alt F1 again, and if you scroll to the bottom, you will see that there is a clustered index. You see, there is an index name, clustered index on the ID column. But for the other table, now we have it for the index test underscore CI, but for the index test, you will see that there are no indexes. See, there are no indexes. So this table has no indexes. This table has an index, which is a clustered index on the ID column. Now, let me open another query window here and get this parallel to this. And what I do is I run two exact same queries on two different parts on the two different windows. Okay, so in one of the window I say select star from index test where id equal to 7748. On another part of the window I say select star from index test underscore ci. Okay, so this is the table with the index, this is the table without the index, right? And I'm trying to run the same query on the same table with the same amount of data, but the only difference is one of them has an index, one of them doesn't have an index. Okay, now before I execute these queries, let me enable the execution plan. Now, what is an execution plan? I'm going to explain this to you in detail when we talk about stored procedures, but just to give you a brief about it, execution plan. So every time we execute a query in SQL Server, the optimizer generates an execution plan before executing the query, or before in fact returning the data to us. Now, what does the execution plan do? The execution plan would, so the optimizer, based on what tables are being joined, what columns are being used to join, what filter conditions are used, so using all of those, it generates a plan as to how that query should be executed efficiently, or what route can SQL Server use to execute that query, okay, and give us the result. So that is known as an execution plan. I'm going to explain that in detail, okay. Now there is a way in which we can see what is the execution plan underlying the query that we are executing. So that can be seen here. You see here there is a include actual execution plan. You can include the execution plan. Click on here, and whenever I run this query now, it'll show me the results along with the execution plan as well. And let me do it on this query window as well, because this query window does not have the option turned on. You see, it's not highlighted. So let me do it for here as well. Now let's run both these queries. So this one is done, and let's execute this one as well. So I have both these query executed on two sides of my window. Now, if you see here, the output that we get is exactly the same, isn't it? 7748, Dinesh 7748 on both sides of the window. It's a very simple select command. Okay. Now, if you observe, there is one more tab. So earlier we used to see only results and messages. Now you see one more tab here, which is called the execution plan. Now, this is what I was talking about a little while earlier. Okay. Now, what is the first thing that you see as a difference? The first thing that you clearly see is if you hover on top of this, you see on the top, you see the operation is a table scan. That means this query would have scanned the whole table to locate the records with IDs 7748. And on the other side of the window, you can see that the operation is clustered index seek. That means it has fetched it from the binary tree structure. It has seeked the value instead of scanning the whole table to locate it. So without the index, I have created two blocks here. One is without index, one is with the index. So without the index, the operation is table scan, whereas with the index, the operation is an index seek. Let me just reduce the font a bit, maybe. So this is the first visible difference that you can see. Now let's see some more statistics here. Okay, let's just hover on top of this, and if you see the 1, 2, 3, 4, 5, sixth number metric from the top, look at the sixth metric from the top. It says number of rows red. You see the number of rows red is 10,000 here in the table scan, because it scanned through the whole table. So it would have basically gone through or checked it would have read all the 10,000 rows to retrieve only this record. Okay, so the number of rows read are 10,000. Now let's check on the table with the index. Here, if you see the same metric, the sixth metric from the top, you will see that the number of rows that are read is only 1, right? So it did not even bother to check the other records, because by using the binary tree, it was able to pinpoint or seek directly to that value or that row instead of scanning the whole table. So you see clearly there's a difference here, and it is on the number of rows read. On the number of rows read for without an index in a table scan, it looks through all the records, but here it only fetches one. Now this is only on 10,000 records. Imagine a table with millions of records in it. Is going to be huge, right? It's going to be saving you a huge amount of time and resources. Now, obviously, when we are reading more number of rows, when we are performing an operation, these are basically on SQL. Okay, but do you know that whenever we execute a query in SQL Server, it also takes a part of your system resources. That means, let's say my SQL Server is installed, the SQL Server that I'm working on is installed on my laptop. So every time I execute a query, it consumes a small bit of my computer resources as well, of my laptop resources as well, like the input output. Okay, if I again hover on top of this, you will see the estimated input output cost, which is the 7th, 8th, 9th metric. You see the 9th and the 11th metric, estimated input output cost and estimated CPU cost. It's 0.027, the IO cost, and the CPU cost is at 0.0110. So the input output and CPU in case of in a table without an index with 10,000 rows is this. Okay, which is a very small number, to be honest. But let me show you the numbers when it is running on an indexed table. When the query is run on an index table, you can see that the estimated IO cost is at 0.003125, and the estimated CPU cost is at 0.000158. Now here I have put all the numbers for you. You see this on the top is the other numbers for the non-indexed table, and this is for the indexed table. Now these are system resources I'm talking about. Okay, this one it took 0.027, this is 0.0031, so it's almost 50, I would say what, 1/10 of what it took here. Again on the CPU, if you see it is 0.011, it is here, it is 0.00015. So this is also 100th time of the resources of the CPU that the earlier query took. Imagine this is the improvement that I can get on a table with only 10,000 records and with a very simple select, with complicated selects, with complicated updates, with complicated deletes, and on a much higher or in a much bigger table, the improvement is going to be huge. Okay, and this is how you read it. Basically, whenever I look for optimization, I see my query, the operations I see. So if I see that there is a table scan somewhere, I know that there is a problem. I know that I have to fix it, because table scans are never good in the SQL Server context. I mean, there are a few scenarios, but that is too complicated for you to understand now, so I'm going to skip that part. But yes, most of the times table scan are bad compared to index seek. Okay, so let me close this one, say no. Again, as I say, indexes, I always say, are a necessary evil. Okay, that's the reason I say, although you have the privilege to create a lot of indexes, a lot of non-clustered indexes, don't blindly go ahead and create them. Okay, indexes are a necessary evil. The fact that the reason behind it is the whole performance of your table now completely depends on this structure. And when you add more rows, when you remove rows, when you update rows, this structure goes for a toss. Let's say you add 10 more records on this table. Those 10 records is not a part of the index unless you refresh the index, right? So until you refresh your index for the new records, it will still run slow. So try to limit your indexes to as less number of columns as possible. Do it only on the columns that you really need, because DML operations are going to get slower with the more number of indexes. Because as I told, sometimes, I mean, when you, let's say, consider inserting, updating, or deleting small number of records, SQL Optimizer tries to rearrange your index to fit in those small number of records. For huge number of records, I mean, it cannot do it. But for small number of records, it tries to update your index structure. It tries to adjust your index structure here and there. So that's the reason more the number of indexes, more time SQL takes to perform your updates and deletes, because internally, although your operation is finished, it is trying to rearrange your index, do minor adjustments on your index structure. Okay, so these 2 points are something that you need to keep in mind when you are creating indexes. Okay, create indexes on columns which are very rarely updated. So here, that's the reason I say, for heavily updated table, keep the index columns to as few as possible. Okay, when there are not much updation happening, you can create as many indexes as required, because there is no DML operations happening, there is no insert, update, delete happening, so you can happily create as many indexes as you want. But is it practically possible? There cannot be a scenario wherein you don't insert, update, delete into a table and the data keeps growing. I mean, it's practically not possible, right? So there will be DML operations done on the table. So make sure you limit and create only the required columns as indexes. And as I said, for clustered index, create it on the unique integer column, preferably the primary key, because the primary key has, as you know, only unique values and not null values. So the primary key is an ideal candidate for the clustered index. Okay, and just for your information, whenever you create a primary key on a column in a table, by default SQL Server creates a unique clustered index on that column. As I've been saying, SQL also knows that the ideal column for a clustered index is the primary key. So if you create a primary key, automatically SQL Server creates a unique clustered index on that column. And when you create a unique column, I mean a unique constraint on a column, SQL by default creates a unique it creates a non-clustered index on that column. Okay, so these are the default indexes that are created, but you can obviously choose to override them if you want. Right, so let's start by talking about stored procedures. What are stored procedures and how are these important in the SQL Server context? Stored procedures, let's start with an example maybe. Okay, let's say you are asked to design queries to calculate the salaries of the employees. Okay, that means let's say you are given an assignment or a task saying that, hey, we want you to build queries that would calculate the salaries of our employees in the database. So you need to follow certain number of steps or perform multiple operations to successfully calculate the salary, right? I have tried to list out a few of the steps and let me guide you through each of them. First, you might need the list of active employees from the employee table. This is very, very important. Now, why do I say this? It is important because let's say there are 10,000 employees in your database, and out of that, let's say there are only 1,000 active employees. So there is no point or there is no need for you to calculate the salaries for the rest of the 9,000 employees. Is it? It's not needed, right? So you first need to take the active list of employees from the employee table to start off your calculation. I mean, you can consider each of these as a or put them into a temp table, maybe. Okay, you can do it any way that you wish to do it. Next, you would fetch the leaves from the leaves table. Let's say there is a employee leave table, and in there you might want to fetch the leaves of each of the employees, obviously. Now, once you have the leave balance summary for each of the employees, you might have to calculate the LOPs or the loss of pay. Now, loss of pay is something wherein, let's say you are eligible for 5 leaves in a month. Okay, let's say you take 7 leaves in that particular month. So you are qualified to, or the company can deduct, the organization can deduct 2 days worth of leaves from your salary. Okay, 2 days worth of salary from your whole monthly salary because you have taken 2 extra leaves, which is something that you are not eligible for, which is beyond your allotted leaves. Okay, so those are called as loss of pays, okay, or LOPs. Now there can be the other way around also, right? The other way around is also possible, wherein there can be 5 leaves allotted to each employee, and some of them might have taken less than 5 leaves. Let's say there is an employee who has taken only 3 leaves. So you might want to credit the rest of the 2 days worth of leaves in the form of 2 days salary to the employee. So either you do a loss of pay or you can encash their leaves into their salary. So this is something that you need to add to the salary of that particular employee. Next, you would want to get the salary components, the different components of salary from the salary table. Like there can be multiple components like the house rent allowance, there can be the dearness allowance, there can be the basic amount. So all these multiple different components can be used or can be extracted from the salary table so that we can calculate them together. We can sum them together so that we can derive the salary. So first we take the leaves so that we can either choose to either add the extra leaves or deduct add the remaining leaves or deduct the extra leaves that has been taken. Then we take the whole salary components, and also we can add the bonuses or the incentives to the calculated amount. Let's say an employee is eligible for some bonus or for some incentive, that can also be added to the final amount. And end of it, the funny part is you'll also have to deduct the taxes that has been that particular employee is eligible for. So now that you have everything calculated till here, the final step would be to calculate the tax on top of the salary that they are going to be paid. So this is also a deductible amount. So you see, this is a very constructive and a thought through approach to calculate the salary. Now you cannot bring this active list of employees step to the end of the calculation, can you? Because you would then end up calculating the salaries for all the employees, which is not a good idea. So it should be performed in a sequential approach or in a constructive approach so that you save on system resources, plus you also make or calculate the data efficiently. Okay, now this is just an example. Okay, this is just an example that I'm trying to give you. Now when you have situations like these wherein there are multiple steps involved in sequence, okay, you might end up having, let's say, 50 or 30 SQL queries to perform all these steps. Now let's say that query, or let's say there are multiple departments who wants to reuse it. Okay, let's say there is another department which wants to reuse this calculation. So what do? Do you give them the query for them to execute on their department? Let's say there is a third department tomorrow who wants to use this same salary calculation procedure. So let's say end of the day or end of the month, you have 10 departments where the salary calculation should be implemented. So do you pass on this query to all the 10 departments? I agree. I mean, you can still do that. Okay, you can pass the 30 SQL queries that you have written to perform all these operations, and they could plug it on their department. But is it efficient enough? Is it maintainable enough? The answer is a strict no. Tomorrow, let's assume that the company says, okay, when we want to change the policy of the encashment of the leaves. Okay, earlier we were paying 1 day salary per leave, but now we want to only pay like half a day salary of the for each leave. Let's say, I mean, any such change. So in that case, what do you have to do? You have no choice left but to change in all the 10 departments the calculation logic. Am I right? Because you have used the same query across all the departments. So it's very bad on the maintainability aspect. This is where stored procedures comes into picture. So you put all your queries, all the 30 or 40 queries that you have inside a stored procedure, and wherever you need them, whenever you need them, just call that procedure and it would do or perform the internal operations on that particular object. Okay, and also when it comes to the maintainability aspect, let's say tomorrow there is a logic that has been changed, there's a new bonus or a new incentive that has been added to the salary component. You just have to change it in the procedure where you're calculating the salary. Automatically everywhere else that the table is being used, or the procedure is being used, will now calculate the salary using the new logic. So what are stored procedures? Stored procedures are blocks or batches of SQL statements. Batches in the sense there can be multiple queries together that are executed together in a specific sequence to serve a definite business purpose. And it can be reused as and when required, and it is accessible to everyone who has access to the database, provided they have execute permission on the stored procedures. I mean, as I've told you earlier, the security privileges is very beautifully defined in SQL Server. So you can control who can execute your stored procedures and who cannot. Okay, you can also restrict people or users. You can give them access to view the data in the tables, but can restrict their access to execute stored procedures. Okay, but yes, I mean, it can be reused at multiple different places and is accessible to everyone who has permissions to view and execute them. Now, what can a stored procedure do? This is where I'm going to give you a few examples, a few differences between the stored procedures and the function. Now, what can a stored procedure do? A stored procedure, unlike a function, can perform all kinds of operations. It can be creating a table, dropping a table. It can be also updating data, deleting data, inserting data, taking backup of the database, restoring the database, any kind of operation that can be written in SQL, okay, can be put in a stored procedure. Whereas a function, it can only perform selects. It cannot even perform DML operations as well. Now, where are the stored procedures created? The stored procedure is created and becomes a part of the database. So wherever we create the procedure, it is created on that particular database and it is stored in the schema where it is created. Obviously, the default schema like other database objects is DBO, unless we specify another schema where it should be created. So let's say it's created, if you want to create it on the food schema, you can create it there. If you want to create it on the clothing schema, you can create it there. Any type of schema, but the default is DBO, obviously. Now, why do we have to prefer? The big question is, why do we go with stored procedures instead of the normal queries? Is it just because of the reusability and the maintainability factor? No, there is in fact more to stored procedures than what it looks like. The first main reason as to why we use stored procedures is because of the encapsulation property. Now, what is encapsulation? Okay, encapsulation is a OOPS concept. It's an object-oriented programming concept. Okay, let me give you an example so that you're clear about it. Let's say you go to let's say you're sick. Okay, I mean you have food poisoning or something. Okay, we'll not go with flu or fever or anything given the circumstances, but yes, let's go with stomach upset. And you go to a doctor and you tell what your problems are, and he gives you a couple of tablets, maybe a couple of capsules to take. Are you really worried about the chemical formula or the combination or the content of that particular capsule, or are you really bothered about how to consume it, when to consume it? I would obviously worry about when do I eat it and how do I eat it, rather than asking what are the contents of the capsule or what is this capsule made of. This is a classic example of encapsulation, wherein we are just bothered about how to consume something, how to utilize something, instead of understanding the internal complexities that are involved in it. And that is what a stored procedure exactly does. We write all of our business logic inside the stored procedure, and when we share it with someone, we just share the name. So they just execute the name, and automatically the logic that is placed inside of it is calculated or is performed. Okay, that's what encapsulation means. It binds complicated business logic into a single unit without exposing the internal content. So no one even knows what is there inside the stored procedure. They just execute it, and let's say the calculation of salary itself. So I just share the stored procedure name, and every department just executes it so that it calculates the salary for their specific department. Coming to the reusability aspect, I've already shared this with you. The SPs are reusable and can be called multiple number of times based on our need by users having execute permissions on them. As I mentioned earlier, you need to have execute permission on the database to be able, on the stored procedure to be able to execute them. Maintainability aspect is also something that I've already explained to you about, wherein any change that's been made on the data, on the calculation, or on the way the data has been transformed, you can always change it only in the stored procedure once, and automatically when the procedure is called the next time from any of the departments, it would automatically use the new calculation to calculate the salary. As simple as that. Okay, now coming to the most important factor that clearly differentiates or clearly puts stored procedures way ahead of SQL queries. This is called as the execution plan caching. Now, to understand this, let's understand what the optimizer actually does when we try to write and execute a query. So let's say you write a query and execute it. There are three main functions, or there are three main steps that the optimizer follows. First, it parses the query. So what does it parse? It basically checks the query for any syntax errors. If there are any syntax errors, obviously it'll throw you an error message that you are missing something here or here. That's the first step. Second, it compiles that query to generate the execution plan. Okay, that means if everything looks okay, if the syntax is okay, if you have written the query properly, it compiles that query to generate the execution plan. And third step, it uses the execution plan that is generated to fetch the data, perform the actual operation. Okay, now what is an execution plan? Let me give you an example so that you understand this clearly. Let's say that you have you have got a new job in your city. Okay, you have got a new job, and the distance, there are three main routes. There are three main, let's say routes. Okay, there are three routes that you can take to reach your office on a day-to-day basis. So for commute, for daily commute. Now, what do you do in the first week? Let's say you have never gone to that part of the city earlier, so you don't know clearly about the routes that are available. So
Just a quick info, guys. Test your knowledge of SQL by answering this question. Which of the following is not a valid aggregate function? A. Count. B. Sum. C. Max. D. Compute. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
Let's say you found out from Google Maps that you have 3 routes that you can take. The first route, when you take it, you see that you can reach office faster. It is 10 miles from your home, where you're staying currently, where you're put up, to your office. It is 10 miles, but you reach office a lot faster, okay? Because there is very less traffic in this route. Or let's say it is 12 miles, okay? Let's say the distance between your place of stay and your office is 12 miles, and you reach office faster because there is very less traffic. So what do you compromise on in this route? You burn more fuel because of the extra distance, but what do you save on is your time. Okay, so one pro and one con with the first route. Let's talk about the second route. Let's say the second route, when you take the second route, the distance between your place of stay and your office is 8 miles, but there's a lot of traffic in that route. So you might end up saving a bit on your fuel on the to and fro commute, but you are compromising on the time that you are spending to reach office. Okay, so again, one pro and one con in the second route as well. Let's talk about the third route. Okay, let's say that the distance from here, when you use the third route, the distance from your office, from your place of stay to office, is still 8 miles. There is hardly any traffic, win-win situation, but the condition of the road is not that great. You have a lot of potholes, there are construction work going on, they have let's say there's some patchwork that is going on here and there, and what happens is, end of the day, you save money on fuel, good enough. You save on time because it is closer, so it takes hardly much time, but you're compromising on the condition of your vehicle, right? You know that if you go in that route for, let's say, a month or so, you might get a hefty amount of service charge on your vehicle. Okay, so here also you have a con associated. Now, based on your priority, you choose which route do you want to take. If you are comfortable to shell out more money but don't care about the time, then you take obviously the second route because you want to save money on the fuel, right? But let's say you want to you don't care about the money but you want to save on time, you take obviously the first route. Now let's say you don't care about your car, okay, you want to sell it anyways after a month or two, so you take the third route. It's all depending on your priority that you choose which route you have to take. Now how do you decide? Only when you take each of the routes for, let's say, 2 days in a week. So in 1 or 2 weeks you get used to the routes, and then you decide, you take an educated decision as to which route do you take for the commute. This is exactly what execution plan means in SQL Server. To execute a particular query, there can be multiple routes that SQL Server can take. Okay, so this is where the compiling factor comes in. So when the optimizer tries to compile the query, it identifies an ideal route that the query is going to take to be able to fetch the data or perform whatever operation has been asked to perform. Okay, now this is with normal queries. Okay, now what happens with stored procedures? With stored procedures, the advantage that we have is, the first time when we create the stored procedure, it is parsed once and for all. Okay, so it is parsed and we know that there are no syntax errors, so it does not parse or check for the syntax every time it is run. So we are saving on parsing the query. Second step is the compiling, right, where the execution plan is generated. Now what happens in case of a stored procedure is that after 3 or 4 runs, SQL optimizer tries to identify the best plan out of the all and caches it in the memory, in the SQL Server memory. Okay, so for the next times, let's say from the 4th or the 5th time, it doesn't have to compile it anymore, which doesn't happen in case of queries. Every time you execute a query, let's say you execute the same query over and over again, it will every time get parsed, it will every time get compiled to generate the execution plan. But in case of stored procedures, parsing only happens the time when we create the procedure, and the compiling, where the execution plan is generated, is cached in the first few runs, and this saves a lot of time on the query processing. Okay, so the same query when executed normally versus when executed inside a stored procedure makes a lot of difference on the time and the performance. Okay, so that is what execution plan caching really means. The SP when created is parsed and compiled, so it does not compile every time it is run. It also caches the best execution plan in the first few initial runs, which makes it stand out from normal queries. Now, what is an execution plan? An execution plan is the path used by SQL Optimizer to execute your query and return the result. Now, SQL Server creates the execution plan during the query execution, and obviously the SQL query takes that extra bit of time to compile and create the execution plan, which is avoided or which is not necessary in case of a stored procedure after the few initial runs. Okay, and this is what makes stored procedures stand out from normal queries. Okay, now let me show you how to create a stored procedure. Okay, it's very simple. I say create or alter procedure and then give it a name, like so that you understand or you look at it and know that it's a stored procedure. So I give it a name saying CSP underscore. So CSP stands for custom stored procedure. Okay, so custom stored procedure is basically when we create one for our own need. CSP underscore and then obviously a name that justifies the purpose of the procedure. So I say CSP underscore get data as begin, and then here let's say I'm creating a procedure that would just select me the data from the employee table. Okay, as I told, you can do anything that you want, but I'm just keeping it very simple so that you understand it. Okay, here I'm trying to say select me the data from the employee table. Very simple one, right? So let's execute this. It says commands completed successfully. Now, how do you know if the stored procedure is created? Obviously, you can do Alt F1 on this, Alt F1, and you will see that this is the name. This is the type is stored procedure, and it's created on 4th of October at 9:52 in the evening. Now that the procedure is created, let's see how to execute it. Again, executing it is also very easy. You say exec and the procedure name, and when I run this, see, it gives me the whole data from the employee table. I'm not executing the query, right? I'm just executing the stored procedure, but internally the stored procedure has that query, so it runs and selects me the data. Okay, now let's say you don't want to see the salary column maybe. Okay, so you can alter the same procedure CSP underscore get data as begin, and instead of star you put the ID, first name, last name, and address from the employee table. And if I run this, it says commands completed successfully. And now when I execute the same stored procedure, it would give me everything except for the salary column. You see, I get the ID, first name, last name, and address. So except for the salary, I get everything else. Now, this is more of a static stored procedure, which means every time you run it, it will give the exact same output, okay, or the result set. Now, can we make it dynamic for the user to input a value and based on that, it returns the output? Yes, we can do that by adding parameters. You remember how we used to add parameters inside functions? We can do the same in procedures as well. So here I say create or alter procedure, CSP underscore get data. I'm using the same procedure, okay? And in here, I put the parameter inside the bracket. So I say employee ID parameter of type integer as begin. And here, as you can see, I'm selecting only those columns from employee where employee ID equal to employee ID. Okay, so this would so the user will be asked to input a value here, and that value will be used to filter the employee ID from the employee table. So whatever ID we give here, that ID will be filtered and the details will be returned for that particular employee. So let me create this procedure, and now if I just say execute procedure name, is going to throw me an error saying that procedure or function expects parameter employee ID which was not supplied. Okay, so here I need to pass the value of the parameter which is employee ID. Now if I run this, See, you see, it gives me only the details for John.
Just a quick info, guys. Intellipaat provides Microsoft SQL certification training in partnership with Microsoft. The course link of which is given in the description below. Let's hear what our customers says about the course. Did you get any promotion or appraisal in your current company after completing the course?
Yeah, I just recently become as a lead in my organization. So after complete this course, because I have other 2-3 project I have completed with a success story. So yeah, I got a promotion.
Now let's continue with the session.
I mean, the ID 7. So similarly, if I give, let's say 5 here, it would give me the details for 5. Now, let's say you are said, okay, if I don't pass any value for employee ID, give me all the employees. If I pass any value, send me the specific employee details. That means if I pass a 5, get me the details for 5. If I don't pass any value, just give me all the data. Okay, so in that case, what you can do is you can pass a default value. Okay, like this. So when you give a default value, let's say I give a default value of 4. Okay, so what will happen is let's alter this, and now if I just execute this much, okay, just execute the procedure, it would give me the default employee details, which is 4. Remember, I gave 4 here as the default employee ID. Okay, but if I pass the value from here, let's say I pass 5, it will now give me the 5 details. So if I pass a value from here, it will take this, else if I only execute this, it will use the default value. Now let's say when I execute this, I should not get 4 but should get all the employees, and when I pass 5, I should get only the details for 5. How do we achieve that? For that, what I do is I set the default value to 0. Okay, and here I put or employee ID variable is 0. That means fetch me all the employees where employee ID equal to whatever value comes in, which is, it could be 1, 2, 3, 4, 5, 6, 7, or fetch me the record if @employee ID, the variable is 0. And you know that the OR condition would return the records if at least one of these condition is true. Okay, so let's say employee ID, I pass it as 5. That means it will only evaluate this condition to true for ID 5. So it will return only 5. Now let's say I pass employee ID as 0, then this condition will be evaluated to true for all the records, isn't it? So let me alter this, and if I run this with 5, see I get this particular employee. If I run with 6, I get with 6. If I run with 0, I get everything. Or I can also choose to not run it with the parameter and I should get everything. This is all being handled by this condition. If I pass the variable value to 0, that means it'll return me everything. Okay, so you can make your parameter optional by adding a default value here. So the default value to the parameter makes it optional. I know the OR condition is a little complicated for you guys for now, but I mean, when you practice it more, you will get to know it. Okay, you will understand this better. Okay, next, let's see how to add multiple parameters. So till now we have been only playing around with what, one parameter only. So how do we add multiple parameters to our procedure? So here I say create or alter procedure, the same one. Here I pass the employee ID integer. I give an optional value which is 4, and I also add the address here. This is a mandatory parameter because this does not have a default value. Okay, if it had a default value, this also would have been an optional parameter, but this does not have a default value, so it's a mandatory parameter. That means the user has to provide a value for the address. And then here what I do is I say as begin. Here if you see, I'm selecting employee ID. Instead of selecting first and last name, I'm selecting the full name by using the function. This is one other difference between the procedure and the function. In a procedure, you can call a function, but inside a function you cannot call a stored procedure. Okay, and then obviously I select the address from employee. Let me just give it an alias name because it does not have an alias name. from employee table where employee ID is equal to ID and address equal to address. Okay, so I'm using both the parameters to filter my data now. If I execute, it says commands completed successfully. Now I can execute only this and you'll not see any data because, let me show you, because when I don't pass any value to the employee ID, it uses the default value, which is 4, and for 4 the address is Australia. So if I pass Australia here, then it'll return me the data because I'm not passing any value to the employee ID, so it uses the default value, which is 4. And there is an AND condition here. That means it'll only return me the employee which has ID is 4 and address as Australia. Okay, and if I say, if I pass this as India and I pass employee ID as 1, this will give me only that particular record. So this is how you can control your optional parameters and mandatory parameters. So we can also create a procedure with output parameters. Till now what we have seen is we pass input parameters. That means we pass inputs, we pass parameter values as input to the procedure, and then we can also create stored procedures with output parameters. I'm not a big fan of using the output parameters because this is mostly what a function is supposed to do. Okay, but yes, I just wanted to share with you that this feature is also available. Okay, so here I say create or alter procedure, the same procedure name, and I pass 2 parameters as input. One is the employee count, which is of type integer, and the output keyword. So that means this is a output parameter. And then I have the employee address, which is varchar 100. So basically what I'm going to do as part of this procedure is I'm going to count the employees that reside in the input address and return this count as an output. So this will basically be returned to the users, okay, the end users. And what I do is I say as begin, and here I say select employee count is the output, okay, the output variable equal to count1 from employee where address equal to employee address. So the count for all the employees residing in this address will be stored in the employee count variable. Okay, and let me create this. Now executing this is slightly different. What we do here is we need to catch the output value, right? First let's create a variable of the same data type, which is integer. Now this is where I'm going to store my output value, the value that I get as an output. So here I say execute the procedure name, and then I put the variable name here, the new variable that I've created, saying output. That means whatever value this output parameter returns from here will be stored in this variable. So the output keyword helps us map this variable to this. So that means whatever value comes as an output will be stored in this variable, and obviously the employee address I'm passing the parameter here. So I'm executing it, right? So I'm saying okay, store the output in this and take this as input, and ultimately what I do here is I select the value as an alias name. So let me run this and show you what the output looks like. So it gives me 2. That means there are 2 number of employees who reside in the US. Similarly, if I change it to, let's say, India, and let's see this now, it gives me 4. That means there are 4 employees from India. So this is how you can use input parameters as you can use output parameters with procedures. But again, as I said, this can be easily used with a function. Okay, so you don't need procedures for that. I'm to be honest, I have never used a parameter, output parameter with a procedure. But yes, we use input parameters a lot. I've spoken to you about the SP help text when we were discussing about functions, right? The same thing is applicable here as well. So if you want to see the content of a procedure, you can always use SP help text, and then you can write the procedure name, and it would give you the whole structure of the procedure, the whole definition of the procedure. And obviously if you want to hide it, if you don't want people to see it, what you can do is you can say with encryption, and when I execute this, it's altered And now when I run the sp help text, it would not return me anything. It says the text is encrypted, right? Obviously you can call your procedures conditionally. That means if the condition is true, then you can execute a procedure. See, 1 is not equal to 2, right? So it won't return us anything, right? It just says commands completed successfully because there's nothing to execute because the condition is false. But let's say I make it 1, which means it's true. Now the procedure will get executed and it returns me the output. Okay, so this is how you can execute your procedures conditionally, right? Views. Okay, all right. So what are views and how are these important in the context of SQL Server? So let's say with the growing amount of data, okay, when the data grows exponentially in our database, obviously we store a lot of, in fact, all of the relevant data, which can be game changers at times. The importance of data can be realized when you hear the terms like when they say the data is the new oil. That means data is so important in the context of the business, the domain, and the application. There's nothing matching that level. I mean, if your UI goes for a toss, you can always fix it, but your data is something that is always dear and close to any company. Now when you have data which is like quite important, you can do a lot of things with it. You can do some analysis, you can do some probably you can use it to predict something. You can do, I don't know, maybe derive metrics out of it, like how did the past go and how is the current year going. You can do derive comparisons out of it. You can derive what do you call standard numbers or standard metrics for your company. I mean, there are a lot of things that you can do on data, and I guess with what we are doing these days, I mean, a lot of them revolve around data. I mean, you talk about machine learning, artificial intelligence, a lot of things can be done with data. So coming back, I mean, when I talk about data, there are a lot of important data that we store that might also be relevant for a few other applications or a few other projects in our organization. Okay, but end of the day, they might be internal consumers, they might be external consumers. Okay, so you can also I mean, if companies are tied up, they could also share data between themselves, right? If they are a parent or a child company or a sister company or any related companies which have an agreement, okay, I mean, there cannot be direct sharing of the data without any agreement or such. That would be clearly a theft. But again, if there is an agreement, is a pre-decided agreement, then yes, data can be shared between companies, organizations, between projects, and between teams as well. Now, whenever you get such requests, okay, I always say this to people that I train: whenever you are given a database, make sure you need to work as if you own it, because any change that you make on it, any additional objects that you create in it, you are responsible to manage it. So the more objects you have, the more effort it is going to take from your end to maintain and manage it. So that's the reason I say, whenever you are given a database or whenever you own a database, make sure you act like a miser. Okay, that is, I mean, whatever I am outside of office, but inside, when I am on my database, I need to, talking about myself, I'm a big time miser. Anyone comes back to me saying, hey Dinesh, we wanted to create a table, we wanted to add 2 columns, we wanted to modify this on the database, we wanted to modify that on the database. Ask them questions until that is the only option left. Okay, ask them if there is an alternate. Ask them, what if we don't do it? What happens if we don't do it? If you do not have any other option than doing that, find out an efficient way to do it. Because if you just keep making changes as per the suggestion that you get from your team members, you will end up with a very, very bad database. It could be on the design, it could be on the storage, it could be on the maintainability aspect. Okay, so always make sure that whenever you do something, okay, make sure that you know what you're doing. Okay, take your own time, analyze it, and then implement it. But before implementing, see if there is any other better way that you can do it. Only if it is the last option, update your database. It could be your table, it could be your column, it could be adding new tables or anything of that sort. Okay, I mean, this is a fact. Okay, trust me. I mean, if you go that line, if you walk that lane, you will understand how hard it is. If you have like 10 developers working on the UI, and let's say you are the one taking care of the database, imagine 10 people telling you how to design a database, or 10 people asking you to modify the database. It's going to be really, really bad. Okay, so that is one aspect to it. The same thing applies when someone asks you access to the data. Okay, you will, when you have, and this happens mostly when you are in high visible project, okay, or project which has the core data of the organization. When you have the core data of the organization, okay, you are very frequently contacted by teams and projects. It could be inside your company, outside of company, that comes back saying they might need access to your data. Could be because of any reason, could be to run some analysis, could be to take something and use it in their system, could be to integrate into could be they could be building an integration tool between the two applications. You never know. So there could be multiple reasons why they might be asking you for the access to your data. Now again, the being a miser still continues. Okay, when they ask you for access to the data, make sure you get all the details or understand why they would need access to your database. Why would they need access to your data? Is it clearly justified? Now again, only grant them access when you are completely satisfied with their response, or if you have your management's approval. Okay, I would say both of them are necessary. That is what I do, because tomorrow you never know. I mean, you could feel that the answer that they've given is justified, but the management might not agree to it. Okay, so it's always better to make sure that you understand their point of view as to why they need the data, and also at the same time have proper approvals before you actually expose your data to the outside users. Okay, now they need data. I mean, okay, everything is decided. They need data from your database, but then you know that there are some very critical information, let's say user information, that at no cost you can share with them. It can be phone numbers, it could be social security numbers, it could be Aadhaar numbers in case of Indian users, it could be salaries of the employees. Okay, there are a lot many things that are quite sensitive and quite critical that can that you might not want them to have access to. Okay, you need to grant them access, they need to view the data. At the same time, you want to have control on your data so that you can hide or show whatever columns you want to expose. Okay, this is where views comes into picture. Okay, views we looked at, in fact they are an additional layer on top of a table which helps us protect sensitive information based on our need. Now they need data, I mean, we completely understand it, but sensitive information is something that is very, very, as they say, I mean, sensitive, right? So you cannot just go ahead and share them. You need permissions from the users, you need a lot of things before you could actually share those details. Okay, and to do that, to accomplish both these things, there's a concept that we use the views. Okay, view is nothing but an additional layer on top of a table which enables us to protect sensitive information based on our need and only expose the columns that we want to expose for the outside users. Now a view is just a query on the top of a table. So like as we write a select, right? So we can name that query, as simple as that. A view is basically we write a select statement and name it. So whenever you call that view, the query that is written inside, the select statement that is written inside is executed and it gives you the data back. Okay, and the view, as I said, is just a query on top of the table. That is all that it has. It does not store any data of its own. Okay, and that is the reason they are very, very lightweight on the server. It is just a physical object created on the database, but internally it just has a query plugged on top of one table or multiple tables. As this is just a layer on top of a table, views do not store any data physically in the server. That means it does not have to store. It in fact is very lightweight on the server and does not store the data. Again, the one good thing that I like very much about the views is this. Okay, it is so lightweight on the server that it doesn't take any physical memory on the disk. Okay, and it makes absolute sense as well, because as I said, views are connected to tables and the data is already there in the tables. We don't have to maintain the same data in the table as well as in the view. The query is always there inside the view. Every time you call the view, the query is executed and it gets the data directly from the table itself. So it's a win-win situation. I mean, you don't have to store duplicate data, plus you get whatever data you want to get. But again, you can control what data goes from the table to the view. Okay. Instead, so the data is not stored in the view. Instead, the data when requested. So let's say I want to view the data from the view. I want to see the data that is inside the view, or consume the data that is inside the view. I just when I execute it, the data when requested, that means when someone requests from the data from inside the view, the query that is running in that is defined in the background is executed and the data is returned. Okay, so let's say someone executes the view 5 times, the query that is written inside will be executed all the 5 times. Okay, there is no concept of caching or anything like it happens in procedures. Okay, this is a completely different object altogether, which is just a replacement or an alternate to a table. Okay, so moving on, let's see how to create a view. Okay, so I've already explained you what views are basically. Okay, let's see how to create a view. Let's start by talking about how we create a view. And to begin with, I'm going to create a very simple view which replicates exactly the table. Okay, like how the like all the data that the table has is just going to be exactly the same. Okay, so here I say create or alter view. Okay, this is a syntax that we usually use for procedures, functions, indexes, and everything. And then here I say vw underscore. Vw is the prefix that I give to all of my views. Okay, so that I see it and know that okay, it's a view. vw underscore get employee data. Okay, so I just name my view as get employee data, and then I say as, and as you can see here, I have just put a select star from employee. So no manipulations, no filtering, no column exclusion. Okay, just a very simple select, and I'm selecting all rows and all columns from the employee table. Okay, so if I execute this now, oh sorry, I'm in the master database. Just connect to.
Just a quick info, guys. Test your knowledge of SQL by answering this question. What is the full form of SQL? A. Structured query list. B. Sample query language. C. None of these. D. Structured query language. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
September, and let's execute this. And now this view is created. So where are the views created? Let me show you. You expand the databases, go to the database that you use, and then if you see here, there is a option called views. When there's a subfolder called views, expanding that, you will find the view that has been created. Now, how do we consume a view? Like how do we extract the data from a view? It's exactly how tables work, because as I told you earlier, it is just a replacement of the table and also helps you in filtering what data do you want to push to the view. But in this case, no filtering, no exclusion of the columns, no exclusion of the rows. It is a very simple select from the employee table. So the view basically should show all the data that the employee table has. Now, for me to fetch the data from a view, I just use it like I consume data from tables. I say select star from, and then the name of the view here. So when I run this, you will see that it gives me all the columns and rows from the employee table. Okay, now as I told you earlier, the view does not store any data. So all the data that you're seeing here right now is a result of the query that was executed that is inside the view. So when I say select star from view name, it executes the query that is there inside, which is the select star from employee. And obviously the select star from employee gives us all these rows and columns back. Okay, so if I execute this, let's say 4 or 5 times, 1, 2, 3, 4, 5, 6, all the 6 times this query is only executed because the view does not have any data of its own. Now the advantage of this concept is that every time you execute this view, you will always get the latest data in the employee table. So if someone executes this now, it'll that particular user would get all the employee data till this current time. And that's a good thing, right? I mean, with the view, you're always getting the latest data that is there in the table. There is no lag at all. Okay. Now, looking at this, what you see is, I mean, the only thing that I'm concerned about, hey, I don't want to expose my salary column. Okay. So let's say I don't want them to see my table. So what I do now is I give them this view. Okay. The outside users, I give them this view. I'm going to talk about a little bit more. I mean, when I give examples, you will understand how these views are helpful. Okay, so here, let's say I show you this column, and I see that okay, the salary column is not something that I want to share with people from outside of my team or outside of my project or outside of my company. Now, how do we restrict those data, or how do I create a view to exclude a few columns? So in order to do that, okay, what I did is, you see here it had a star, but in this condition, I mean in the same view, I'm going to alter it, the same view name. Here, instead of specifying star, I specify all the columns that I need or that I want to expose to the outside users. So I'm fine exposing the employee ID, first name, last name, and address, but not the salary column. So I can say select employee ID, first name, last name, address from salary. And let me just not filter it yet. And let's say run it. So it says commands completed successfully. And now when I try to view the data from the, see the data from the view, you will notice that it still gives me all the records. But now it only gives me the employee ID, first name, last name, and address. It doesn't give the salary column anymore. So anyone who is executing this view, whom I have shared this view, will only be able to see these 4 columns of the employees and not the salary column. Okay. Now, let's say you want to show, or someone has a request saying, hey, can you give me the records of the employees only from India? Okay, so in that case, what you do is you can say where address, so you can create a view as address equals to, sorry, in single quotes, address equals to India. Okay, and let me alter this view, and let's say, let me run the select again. And now whoever is using this view, whoever is consuming the data from this view, will only see the employees, or it will see the list of employees who are from India only. Okay, so this is how you can filter rows and columns so that you only expose the required amount of data. Now, if you think about it now, I mean, this is the most feasible solution, isn't it? Let's say you have a sales table. Okay, you have a sales table, and there are 5 or 6 users in different regions requesting for data. Okay, so how do you accomplish it? I mean, you cannot give them the same table name, because everyone will be able to see. If you give them access to the table, everyone will be able to see all the data from all the regions, and that is something that we would not want to happen. So in that case, you can create 4 views for 4 different stakeholders and use a filter for that specific region. So let's say you're creating one for Europe. Maybe you can say where location is Europe, or any other column that you can check to filter out only the European data. Similarly, if you are requested for the UK data, you can create a view which will only expose the UK data. So There are multiple advantages associated with the view. The one more advantage that I love about views is that in views you can also join two or more tables. Let's say someone requests saying, hey, can you share me the employee data and the employee date of birth data as well? So instead of sharing both the tables, what you can do is you can create a view. Okay, I'm using the same view itself, wherein you can join the employee and the employee date of birth together, obviously on the employee ID like I showed you earlier. And here I can select the employee ID, first name, last name, address, and date of birth as well. So instead of sharing two tables with them, or in fact all the data from employee and all the data from employee date of birth with them, I can easily expose only the columns that I wish for them to see. Plus I can also filter this query. Let's say I only want to show India's data. I can always put a where clause after this saying where address equals to India, and it should work absolutely fine. They will just have to call this view to see the employee data and the date of birth corresponding to each of the employees. So let me just run this, and if I try to run a select from the view, you will notice that it shows the employee ID. I mean, the users can see employee ID, first name, last name, address, and date of birth as well. Although these two are not, this column and these columns are not in the same table, but inside the view I have managed to join it. So this is like another layer that we apply on top of the existing tables to I don't know, facilitate sharing of data from tables. So let's move ahead then. Now, by now you must have realized that views are very tightly coupled with the column names and the table names. Okay, now let's suppose that I change one of these column names. Let's say I change it to employee ID of employee. Let's say in the employee table I change this column name to ID of employee. Now, do you think this view would still work? As I told you, the view, every time we call it, it just executes this query to get the data. Now, let's say you modify the column name to ID of employee, right? Do you think this view would still work? It wouldn't, because it's going to throw an error saying that the employee ID column doesn't exist. And why it doesn't exist? Because it has been renamed. It has been renamed to ID of employee. So this situation wherein the underlying columns or tables of a view has been modified, okay, and I'm only talking about renaming. Okay, so renaming of any of these columns or renaming of any of these tables is going to cause the view to become orphan. Okay, those will be called as orphan views because the parent table or the columns are no more to be found. So views for which the base table or column has changed or has been altered is known as a orphan view. Now, can we do something in order for us to preserve a view, in order to ensure that the view works at all times? Yes, to prevent such scenarios, we can choose to schema bind our view. Okay, now what happens when we schema bind our view? When we schema bind, SQL ensures that none of these columns, okay, only the dependent columns, that is employee ID, first name, last name, okay, address, employee date of birth are not modified. SQL ensures that. Also, the employee and the employee date of birth table are neither allowed to be dropped nor renamed. Okay, so that will ensure that the view will work at all time. Okay, so schema binding binds our views to the dependent physical columns in the table, columns and table as well. Columns, column and table, columns, sorry, columns and tables. Okay, now for example, here if you see the salary column isn't used, correct? So the columns that aren't used in the view, they can be altered, they can be modified. Okay, so schema binding is only applicable to the columns which are binded in the view. For the columns which are not binded in the view, although they are in the same base table, you can still alter them. You can still remove them. You can rename them. Whatever you want to do, you can do with them. But only the columns that are intact or that are referenced inside the view, that are there inside the query, those cannot be touched. Okay, so let me show you with an example how it actually works. Okay, so I'm going to create a view, create or alter view. Okay, I'm going to use the employee backup table. You remember this employee backup table that we created some time back? Let me just show you what it has. It has all the data from the employee table. Okay, now what I'm going to do is I'm going to create my view on top of this now, because I'm using the backup table for my demonstration now, because I'm going to do a lot of changes on this table, like removing columns, altering columns and stuff like those, which I don't want to do with the employee table. Okay, so I'm just demonstrating it with the backup table. So let me create a very simple function view which says create or alter view, and here I name the view as vw underscore get employee backup data. And let's say I don't enable the schema binding. Okay, I just say as, and then select all the columns from the employee backup table. Okay, let's just go ahead and create this without the schema binding. Mind it. Okay, it's a very normal view like we have been creating till now. Forget about the schema binding for now. So right, this view is created. Now if I want to select from this view, let me run a select from this view, and you see that it works perfectly all right. Now let me try to drop the first name column. The first name column is used right in the view. Let me say alter table employee backup, drop the column employee first name. Now remember one thing, the first name column has been inside the view. Let's see what happens when I run this. So I say alter table this, drop the column first name. It works, and it allows us to drop the column although that column is referenced in the view, which is this one. So now this view has become orphan. Let me show you what happens. If I try to execute this view now, see, it throws me an error saying invalid column name employee first name, because that column has been removed by us just now, a little while earlier. Okay, and this is an ideal example of an orphan view. Orphan view is a view for which the base table or base column is missing. Okay, now let's try to do the same thing. Okay, let me try to drop the employee backup table. Okay, I'm trying to drop the employee backup. Now this is the parent table, mind it, of the view. Okay, and if you see now, let me execute this. It works. It allows us to drop the table as well. And if I run this again, obviously the backup table is not there, so it says invalid object name dbo underscore dbo.employee backup. So the view was orphan earlier, now also it is orphan, but the base table is also missing. Now how does schema binding help in this case? So let me recreate the backup table again. Control KU, recreate the backup table because I just dropped it right. Now if I execute the view, it should work because the backup table is back again with all the columns. So the view works fine now. Now let me alter the view to include the schema binding. Okay, so you use the schema binding option here. Okay, right after you define the name, you say with schema binding and execute. It says commands completed successfully. So now our view has the schema binding option turned on. And now let's try to drop the column employee first name. Let's try to repeat whatever we did earlier. So let me try to alter the table to drop the first name column. Wonderful. See, what does it say? It says the object is dependent on the column employee first name. So the drop column does not work. This is SQL checking for us. Okay, only because we have enabled the with schema binding option, SQL is checking if this column is used in any of the views, and it finds that okay, it is used in the view underscore get employee backup data. Now perfect, it doesn't allow us to drop the column. Does it allow us to make some other modification? Let's say you want to change the size maybe. Okay, so let's say from 100 I want to make it 120 on the first name column itself. this also is not allowed. The object is dependent on column employee first name. So you're not allowed to make any alteration on this column. Now I'm only talking about the design changes, guys. Okay, the data is allowed. I mean, it absolutely makes no sense for SQL to stop or prevent the data from getting updated, inserted, or deleted. I'm only talking about the alteration on the column itself, which is not allowed. So it doesn't allow us to drop it. It neither allows us to modify it or alter it to add or increase or reduce the column length also. Okay, now let's try dropping the salary column. Okay, you know we had a salary column in the backup table. Let's try to drop the salary column and see what happens. It works. It allows us to drop the salary column because the salary column is not being referenced in the view itself. So it is free to be dropped off, and it allowed it to be dropped. So the with schema binding is only applicable for the columns that has been specified in the select and also on the base tables, obviously. Okay, and now if I also try to drop the main table, the base table, it doesn't work. It says it is being referenced by the object view get employee backup data. As simple as that, right? Now if you want to view the definition, if you want to see the definition of a view, you can use the SP help text. This is something that I've explained to you while working with functions and stored procedures, so I'm not going to spend much time on this here. If you run this, obviously you will get get employee backup data. Copy this one and paste it here, and this one, if I want to see the content, I can easily use the SP help text in front of the name of the view to see the definition of the view. That means what query has been specified inside the view. But as I said, this is for outside users, so it's always good that you encrypt it. But again, we don't usually encrypt it because the SP help text can be run by people who have higher privilege than a read permission. Okay, and for people who are going to use the views, we usually give them read permissions only. And for SP help text, you need a higher privilege than the read permission. So there's no harm or there's no fear of the query getting exposed as well. So here, if you don't want your views to be scripted out, obviously you can use the with encryption option. And if let's say I create a function with a view with encryption, and let me just copy this and paste it here, and you will notice that it says the object is encrypted. Okay, so it doesn't allow this to get inserted. I mean, it doesn't allow us to see the content of the view. Okay, all right, so let's continue. Now you already are aware of the null and the not null concept, don't you? So let's say I have an employee table and I have 3 columns in it, A, B, and C. Let's say the column A is nullable, B is nullable, C is not nullable. Okay, this is nullable, this is nullable, this is not nullable. That means A can hold nulls, B can hold nulls, C cannot hold null values. Now let's say I say insert into employee A and B and then select the values here. Do you think this is going to work? This won't work. The reason is, if you remember, I explained to you how the...
Just a quick info, guys. Intellipaat provides Microsoft SQL certification training in partnership with Microsoft. The course link of which is given in the description below. Let's hear what our customer says about the course. Did you get any promotion or appraisal in your current company after completing the course?
Yeah, I just recently become as a lead in my organization. So after completing this course, because I have other 2-3 projects I have completed with a success story. So yeah, I got a promotion.
Now let's continue with the session.
Nullable columns are optional during insert. That means if you don't provide a value for them explicitly, it will store null in them. Okay, it will store nulls in them. Whereas if you don't provide a value for the not nullable columns, SQL Server wouldn't know as to what value should be inserted into that column, right? So that's the reason you need to specify, or that's the reason the columns which are not nullable are mandatory. So at any point in time during the insert into the employee table, you need to provide for sure the column C. Without C, you cannot insert a row in the table. If I exclude A and B, that's perfectly okay. SQL can store nulls in them because these are nullable columns. But for C, I cannot exclude it during the insert, right? Now I'll tell you why I was trying to explain this to you. Okay, talking about the DML operations on a view. Just increase the font. I think it's a bit too small for your liking. Yeah. Okay. So let's talk about the DML operations on a view. Do you think we can perform DML operations, that is insert, update and delete using a view? Yes, we can. Okay, views are not only meant to read data, okay, but we can also perform DML operations on them. That means we can also write into them. Okay, now here, as you already know, views do not have any physical data stored explicitly. So any DML operation that we perform on it is directly executed on the base table. So any insert, update or delete that we do on the view, it directly impacts the base table. Okay, so here we can perform insert, update, delete on the table using the views, but there are two main assumptions that we need to go with. Okay, we can perform DML operations only if these two conditions are satisfied. First is the view should always have a single select. That means it should have only one table from where it is selecting the data from. It cannot have multiple tables joined together. In such cases, we cannot perform DML operations. Next up, all the not null columns are to be selected in the view. The reason is what I just explained you earlier. If the column C, let's say I create a view on the employee table, I don't select the column C in the view, there is no way I can insert a value into the column C. So all the not null columns should be selected in the view. If you don't, then it will not work. The DML operations won't work, especially the insert. Okay, so these two are the criteria for which only then we will be able to insert, update or delete on the table using the views. Now, if you remember, we had a view called view get employee backup data. Sorry, you remember this view? I just created it above. And then the base table for this is this one, the employee backup table. Okay, and if you see, both of them are exactly the same. The only difference is that I have not selected the last name column in the view. As you can see, in the view, I only have ID, first name and address. The last name column is in the table, but I haven't selected it in the view. Very, it's fairly understood. Now, let me try to insert something into the view. So the two conditions that I was talking about, first one, the view should only have a single table. That is true because my view, the get employee backup data, if I show it to you, let me just show it to you so that you remember. This is the view, okay, and it has only one table. It has only one base table, right? So the first condition is true, and the next condition, talking about the next condition, there are no not nullable columns here. All of these columns, if you see, are nullable columns. So there is no problem with the second one as well. Okay, the second criteria said only all the not null columns are to be selected in the view. Okay, I mean you can have the rest of them, but all the not null columns should be mandatorily there in the view. But here, as the base table has no not null columns, so we are good on that aspect as well. Okay, so that angle is covered too. Now let's try to perform an insert on the view. Okay, so carefully observe, okay, what I'm trying to do here. I'm trying to insert into the view. If you can notice, I'm trying to insert into the view get employee backup data, and I can only insert into ID, first name and address. I cannot insert into the last name column because the last name column, although is there in the base table, but it is not there in the view. Okay, and that is the reason why we said that all the not null columns should be selected in the view, because if it is not, then you cannot insert into that column. And obviously, if you cannot insert it from here, SQL will try to insert null into that column and it would fail. So here I say insert into the view and I specify all my columns. I select or I specify three values, 9, Tom and US. So 9 is the ID, name is Tom, and address is US. And let's execute this. So it says one row affected. And if I show you the view, obviously the view gets the data from the table, right? So let's check the table first. Okay, so if you see here, this record has been newly inserted. I mean, only because of our insert that we did. So I did the insert on the view, but I selected the data from the backup table. That means the base table of the view. And as you can see, the record is already here. Okay.
Just a quick info, guys. Test your knowledge of SQL by answering this question. Which of the following is not a valid aggregate function? A. Count. B. Sum. C. Max. D. Compute. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
And here, if you see, the last name is stored as null because the last name is not a column in the view. So I can no ways insert value into this column using the view, because this column does not exist on the view at all, right? So the inserted directly into the table. And also, as you know, the view gets the data from the table, right? So you will see the data also shown up in the view. Now let me update the view. So I say update the view, set address equals to India, where the employee ID is 9. So for the new record that I just inserted, I want to update the address to India. And again, as you can see, I'm updating the view, okay, not the table, the base table. Okay, I'm not updating the base table, but this update will subsequently update the table itself. See, it shows one row affected. And let me show you the base table. See, for this one, the address has been updated to India. Earlier it was US when I inserted it, but now it has been updated to India, right? So any insert or update that we do, it directly impacts the base table. And obviously now when I run the view, as the view fetches the data from the table itself, so you will find the address of this record as India. Now let's see the delete as well, last of the DML statements. And let's say I delete this and I delete from the view again, where employee is equal to 9. So the new employee that I created, I'm trying to delete it. So let's delete. It shows one row affected. And now if I select from the backup table, you will notice that there is no record for ID 9 because I just deleted it. But I deleted it for your information from the view, but it automatically deleted it from the table because, as I said, the view does not have any data of its own. All that it has is the data from the base table. And if I run this view also, you will not find the ID 9 anymore. Now you might ask, the views are meant to be shared with outside users. Can they update the data on our tables? No, because whenever you create a view, we mostly grant read access to the outside users. Okay, so they cannot make any modifications through the view, because if they have read permission on the view, they will never be allowed to run insert, update, or delete on the view. So they can only run selects on this view. That is all about views. Okay, all right. So let's talk about transactions now. So what is the first thing that comes to your mind when we talk about a transaction? The first thing that at least comes to my mind is a bank transaction. Okay, that's a very common term in the banking domain and in the masses as well, right? So an ideal transaction would look like, let's take an example of transferring an amount worth $100, okay, between two parties. So obviously the first step that is involved is the initiation, wherein the request is placed. It could be a check deposit, it could be an online transfer request, or anything. And then what happens is $100 is deducted from the payer's account, okay, and it is end of the day or end of the transaction is when the $100 is credited to the receiver's account. Only when all these steps are completed, that is when it is said that the transaction is complete. Okay, and in fact completed successfully. Okay, now let's suppose that the initiation went well. I mean, the request was well placed. $100 was deducted from the payer's account, but then the $100 never got credited to the receiver's account. Okay, so let's say it was not credited due to an internet issue or a link failure or anything. As a matter of fact, I mean, there was some downtime on the bank data, on bank application, bank website, or anything, as a matter of fact. Now what happens in that case? So the $100 is already deducted from the payer's account and it did not get credited to the receiver's account. So what happens in this case is the bank would revert back the $100 that was deducted from the payer's account. All right. Now the transaction began, but it failed at a certain point. So it was reverted back to the previous state it was in. Now, one very important property of a transaction is that the transaction should leave the database or the application in a consistent state as it was before the transaction started. Okay, so now if it would have left the $100 deducted from the payer's account, but it never got credited to the receiver's account, and the bank never bothered to return back the $100 to the payer's account, obviously there is inconsistencies in the data. There is $100 worth of amount that is nowhere to be found. It got deducted from the payer's account but never got credited to the receiver's account, and it never got reverted back into the payer's account at all. So clearly the transaction that happened or that got initiated left the database in an inconsistent state, and which is never the case, right? Ideally. So a transaction is either all or none. Okay, so in a transaction, either everything goes through fine, or if there is a problem with any of the steps, the rest of the steps are reverted back. And this is exactly what transactions mean in SQL Server as well. Transaction are a set of operations when performed in a sequence such that all operations are guaranteed to succeed or fail as a single unit. So either everything goes well without any issues, or if one of them fails, everything else, all the other changes that has been done are reverted back or are rolled back. Okay, so that's the reason it is said that the transactions is either all or none. That means either it works for all the steps or everything goes well, else nothing is executed. Okay, now you might be curious as to, okay, where do we exactly use these transactions? So a transaction, so in here, now when I talk about SQL, in here in a bank transaction, we have different banking activities, right? But in a SQL transaction, we have multiple SQL queries that needs to be executed. Okay, so a transaction might have 50 queries, might have 100 queries, might have 3 queries, but end of the day, they are all told to be in a single transaction. So either all the 50 queries go through fine, or let's say if the first 49 queries work fine, but the last one fails, every other change that was made before the 50th query needs to be rolled back, because as I said, the transaction will never leave a database in an inconsistent state. Now you might be curious as to when exactly do we use a transaction. These are a few examples that I'm sharing from my own experience. So when multiple number of rows are inserted, updated, or deleted in a sequence. Okay, so let's say that there are a set of 5 employees that are joining the organization today. So in the first place, what you would need to do is add those employees to each of the departments, like the transportation, the food department, the IT department, the admin department. So all the employees should be added to each of the departments. Now, only when they are successfully added or onboarded to all the departments in the database, then we can say that, okay, the employee is onboarded now. So let's say he gets an identification number from each of the departments. I think that is where we say, okay, the employee is onboarded now. Now let's say the employees were added to 3 departments, and the 4th department, while adding them to the 4th department, there was some technical issues, okay, or SQL issues. Now in that case, we cannot leave the onboarding midway, right? We cannot say, okay, let's start all over again. That might not be a feasible option. Or let's leave it as it is, cannot also be a feasible option, because you don't want the employees to be onboarded to only 3 departments and the rest of the departments are not onboarded. I mean, the employee is not onboarded to the rest of the department. It makes no sense at all. There is no partial thing in a transaction. Okay, this is where a transaction is used. So when we want to insert something which is pretty much related into a set of relational tables, that is when we use the transaction. So either that related data gets inserted into all the tables or nothing at all. Everything else is rolled back if there is any issues. If there are any issues, the changes that has been done are rolled back. The other instance where we use transaction is when the changes to one table require the other table data to be kept consistent. Okay, now let's say for some reason, okay, for some given reason, your employee ID needs to be changed. Okay, let's say, I mean, due to some reason, the company decides, no, this employee's ID needs to be changed. So in that case, your employee ID column is a very critical column, right? It could be used as a foreign key in multiple different tables. So in that case, what you do is you need to modify all of the tables in a sequence so that you can remove off the old employee ID and update with the new one. Okay, and when can you do it? When all the child tables are updated with the new ID. Because if you don't do that, then there are high chances that some related data might get missed. Let's say for my employee, let's say my employee ID is 10 and the new employee ID that is given to me is 15, and there is a date of birth table where for ID 10 it has my date of birth now, and tomorrow my ID is changed to 15 but that table is still pointing to ID 10. First of all, that record is orphaned. Okay, if it is a foreign key reference, I mean, SQL wouldn't allow you to do that, but I'm just saying, okay, let's say there is no foreign key, so that record is left orphan. Plus Dinesh now doesn't have a date of birth because Dinesh's ID is 15 and that employee date of birth record has ID as 10. So there is no relationship left now between the tables. So in such cases where you are needed to change the data in a sequence of tables, okay, but this time the major changes on one, but you're changing only the related tables, that is when you also use a transaction. So either you update all the tables, related tables, with the new ID, or you just don't update anything. The next instance, the next example is when we are working on modifying data across 2 or more concurrent databases. So let's say there are 2 databases which are pretty similar to each other and we want to keep them in sync. So what we do, any change, any update, any delete, any insert that we perform on the first database, we also perform the exact same operation on the second database as well. Now imagine that one of the database got updated. I mean, I ran an update query. One of the database got updated, but the second one did not get updated and the query failed due to some reason. Now the data is no more in sync between both the databases, right? So that's a big problem. So in such cases where we have concurrent databases which should be kept in sync, so for those kind of operations, we put them in a transaction. So either the update works in both the databases and it is perfectly all right in that case. But if say the update was done on the first database but is failed on the second, then we revert back the update that was done on the first as well. Okay. Now talking about a very important aspect which is about transactions, I've already given a hint about this to you earlier. So it is categorized by 4 properties. Each transaction in SQL Server is categorized by 4 properties, often referred to as the ACID property. Okay, ACID is an abbreviation of atomicity, consistency, isolation, and durability. So the transactions are identified by these 4 properties, each transaction in SQL Server. Now, what does atomicity mean? Atomicity property states that the transactions should be regarded as a single unit irrespective of the number of steps that are involved. So the transaction might have two queries, two SQL queries or 50 SQL queries. But end of the day, all of them should be considered as a single unit, which would either succeed together or fail together. The next one is consistency. The example I've already given regarding the amount that was not credited into the receiver's account, but it was never reverted back to the payer's account. So in that case, the data was left in the bank database was left in an inconsistent state where there is no account for the $10, so the $100, right? So the consistency property in a transaction states that the transaction should always leave the database or the table in a consistent state after commit or rollback of the changes. So right after the transaction is committed or rolled back, then the database should be in a consistent state. There should not be any loss of data, or there should not be any data discrepancy whatsoever. The next property is called as the isolation, which says that each transaction has its own boundary and do not interfere with each other with other transactions. Okay, like let's suppose that there are two transactions, bank transactions, that are supposed to add $100 and $100 to my account on the same day. So let's say the transaction one finished first and the $100 was credited to my account, and then the second transaction, which is also running parallelly, comes to my account and checks that okay, the $100 is already added, so it could be because of me, and it doesn't credit the other $100. So ideally, end of the day, I should have had $200 credited for the day, but I ended up having only $100 credited, which is a bad thing. And that is what the isolation property states, that each transaction has its own boundary and it should not interfere with other transactions. If it does that, it's going to be a big problem. Okay, durability, this states that any data modifications that are done after the transaction is finished should be kept permanently in the database or in the system. It should stay permanently on the system. That it should not vanish after a few minutes or a few hours or a few days. Okay, the data is there to stay and it should stay. Okay, so these are all called as the ACID property, which is ACID. So let's move on to the different types of transactions that we have. So the first one is called as the auto commit transaction, which is a pretty normal query window where I write my insert, update and delete, and it automatically gets saved in the tables, right? I mean, I just write an insert or a select or insert or a update or a delete, and the moment I run it in front of you, it directly gets written to the table permanently, right? So these statements are written as part of this are automatically treated as a transaction and is committed or rolled back once the statement is executed. Okay, so it's a very normal form of query writing. Okay, next type is called as explicit transaction, where we specify the boundary of the transaction. Okay, saying these is where the transaction is going to start in the SQL query, and these are the queries that needs to be inside, and this is where the transaction should end. So I specify the begin of the transaction, I specify all the queries inside of it. So if I place, let's say 500 queries after the begin transaction, and then I say end the transaction, so all these 500 queries will be a part of this particular transaction, as simple as that. And this is known as an explicit transaction, where we define the boundary of the transaction. Okay, so we manually specify the begin and the end of the transaction. And the third type is called as the implicit transaction, which I have never used. Okay, but there's a setting where you can enable it for all the statements that you have in your query window. So this is a query window, right? So all the statements that are there in this query window are treated as a single transaction, and I don't see a reason why would someone use that. Okay, but yeah, I mean, it's just there. All right, so now let's talk about, let me show you how a transaction actually works. So here in an example of an explicit transaction, here I say begin transaction, and then I put all my queries below this. Okay, so what do I do here? I'm trying to update the employee table, where for employee ID 1, I'm trying to update the last name to Yadav. Okay, so if I run this select, you will notice that the last name is set to Kumar. right? Now, let's say I want to set it to Yadav, okay, and I want to do it inside a transaction. Now, this is only one SQL statement, but ideally we have more than one SQL statements, but let's try to just do this, okay? Let's say employee, I want to update the last name to Yadav, where employee ID equals to 1. And if I execute this, now I need to execute with the begin transaction so that SQL knows that this query is inside a transaction. Okay, so let me execute this. It shows one row affected, right? And if I run the select, now I haven't ended my transaction, mind it, okay? I've just begun the transaction and run my update. Now, if I run my select from the employee table, you will notice that the first record has the last name as Yadav. Okay, so the earlier it was Kumar, but now it is Yadav. But we haven't finished the execution yet. How come is it visible? This is called as dirty read. Okay, dirty read is when, oops, sorry, why does OneDrive want to sync? Okay, anyways, so this is called as a dirty read, and dirty read is when we read data that is not yet committed to the database. This one is not yet committed, neither rollback, but we are still reading the new data. This is dirty data because this is still inside a transaction and SQL is allowing me to read it, right? So now what exactly happens when a transaction begins? So when a transaction begins, right, all the changes that you make here stays on the log file. Okay, you remember when we created a database, I told you that there are two types of files that gets created. One is MDF, one is LDF. The data is stored in the MDF, master data file. But in the LDF, we only have the logs, okay, the transaction logs. So when I put the queries, all the queries that are there under the begin transaction, all these changes reside in the log file. Okay, only when I commit it, okay, then this data is permanently written to the MDF, the master data file. If I roll it back, it is wiped off from the log file as well. So there is no trace of it anymore because, I mean, we didn't do anything. We just began the transaction, made some modifications, rolled it back. So that's all right. I mean, it gets wiped off from the log file altogether. But let's say I put this in a transaction, all the changes are there in the log file right now. And if I say commit, it'll move those changes permanently to the MDF file and ultimately to the table. So that data is proper committed data. But when I try to read something which is in a transaction, it is called as dirty data. Now let's say I roll it back. So as I told, if I roll it back, it would get wiped off from the log file altogether. So let me run this. It says commands completed successfully. And now if I see the employee table, you will notice that the last name is set to Kumar back again because I choose to roll back my change. The query, the data that I updated or the operation that I performed as part of the update has been rolled back now. Okay, if I would have said committed, then I would have seen Yadav here. Okay, but that time Yadav must not have been a dirty data. Right, now is there a way in which I can choose or set saying that I don't want to read dirty data? Yes, those can be controlled by using isolation levels in the transaction. Okay, or as we call it as the transaction isolation levels. Okay, and this we can use to control if we want to see dirty data from the tables or not when we are running the selects. Okay, so what are the different transaction isolation levels? Now there are multiple types, but I'm going to talk about the two important ones and I'll leave it up to you to explore the rest once you feel confident on these. Okay, don't just go in and read about the rest of them because those are a little too complicated. I'm just going to talk to you about the two very basic regularly used isolation levels, and the rest of them you can explore once you have a good hands-on experience on these. The first one is called as the read committed isolation level. Now the read committed isolation level will only read committed data in the table. That means all the data that is committed in the table will be read as part of the read committed. Now, how does it ensure that it reads only committed data? So, in order for SQL to obey the read committed isolation level, if there is a transaction running on the table, the query will wait till the transaction is complete. So automatically, if there are no dangling transactions, if there are no transactions active on that table, obviously it will not, I mean, we can be sure enough that all the data that is there on the table are proper data, are actual data. There is no dirty data in it because there are no transactions. So obviously all the data that we have are permanently written data on the table. There are very less chances that they might be rolled back because there are no transactions to be rolled back. That is how it ensures and works at the read committed isolation level. Okay. Now coming to the read uncommitted isolation level, in this case, in this level, the uncommitted data from the table is also read. So it brings dirty data as well. Now we did not specify, right? We did not specify the read uncommitted isolation level, but the select still gave us the read uncommitted data, that is the dirty data. So this is because the default isolation level in SQL Server is read uncommitted if you are running the select on the same query window where the transaction has been run. So let's say, so I ran the transaction on this query window and I ran the select also on this same query window, right? So in that case, the transaction isolation level at default one is read uncommitted. But how can I specify it explicitly? Let me show you with an example. Okay, so here let's see what does the employee table have for employee ID 4. So for employee ID 4, the first name is Steve. Let me try to update it to David, but this I want to put it in the transaction. Now for your information, I'm going to paste the original name here, which is Steve. Okay, this is the original name. I'm going to say original. Okay, so this is Steve is the original name. I'm trying to update it to David. Okay, now let's run this inside a transaction minded. It says one row is affected, and if I say select star from employee, look what it gives me. For 4, it gives me David. David is the one that I just updated, but this table already has a transaction, right? I just begun the transaction and run the update. I've neither committed it nor rolled it back. That means there is a dangling transaction, that is an active transaction on this table right now, but I'm reading dirty data. That's the reason I said when it is in the same query window, then the default transaction isolation level is read uncommitted. Now let's see how to explicitly specify the isolation levels. So let me copy these two queries. The transaction is still active minded. Okay, I've not committed or rolled it back yet. So let me put a vertical tableau and paste it. So this is how I specify it. I say set transaction isolation level read uncommitted and then select query. So this one will read dirty data, right? Because this is uncommitted isolation level. So it'll read the data, ignoring the fact that there is a transaction running on the table. Let me run this and show it to you. See, it reads the data and it reads David. And David is the one that David is the one that I updated just now. Make sense? So it updated it to David, although, I mean, it reads me as David, although this is not permanently written to the table yet. So this is how the uncommitted works. But let me show you the read committed one. Okay, and I just run this. See, it keeps executing it. It does not return the result, which proves the point that I told earlier. I said that it will wait. The only way it can ensure that it is reading committed data to ensure that there are no dangling transaction or active transaction on the table. Now, when I ran this query, it found out that there is an active transaction on the table. So it is waiting for the transaction to be ended so that it can read the data. Now, let's say I roll it back. So ideally, what should it read? It should read Steve, right? Because this was the original value. I updated it to David inside the transaction, but then I'm rolling it back. So it should ideally read Steve. So let me try to roll it back, but let me do it with a countdown so that you see the moment this transaction is rolled back, you will see the data right at that moment itself on this part of the query window. So keep an eye on this part of the query window, okay, on the right hand side of your query window. And I'm going to roll back this transaction. So in 3, 2, 1, and here we go. See, the moment this was successful, this returned me the data, and now it returns me Steve, which is the original name prior to the transaction. So this is how SQL reads the committed data. But this has a lag because every time there is a transaction, it will keep executing the query. Okay, which might not be a good thing. But again, if you are very concerned about your data that you are reading, you can use the read committed isolation level. Okay, in banking industry, it is very prevalent. Okay, you don't want to use any uncommitted data in a banking database. Okay, because it involves a lot of money again. I mean, that's a big factor. Let's talk about error or exception handling. So what happens when we get an error in SQL Server? We get a red color message and the query ends there itself, right? But is there a way in which we could handle the errors, like store it in a variable or store it back into a table or something of that sort? Can we efficiently manage our queries to not fail when there is an error, but at the same time catch that error? So the try catch block helps us do that. It helps us in handling the errors. Now, the try block is where all the SQL statements are placed, okay, that we want to execute. We place all of them in the try block. And if there is any error from any of the SQL queries in the try block, the catch block is automatically hit. Okay, let me show you a quick example so you can relate to it. Okay, so you can understand it better. So here, what I'm going to do is I'm going to say begin try, and then all our SQL statements goes in here. If you want to write updates, deletes, inserts, anything that you want to write, you can write everything inside the try. And then once all your statements are done, you just end the try block. Okay, so all your SQL statements that you want to run goes here. Now let's say the first one runs fine, second one runs fine, third one runs fine, the fourth one has an error. That very moment the catch block is hit. You see the begin catch? The cursor moves to the catch block and it executes whatever is there in this catch block, right? So let me show you an example. Okay, let me comment these. And what I'm going to do here is I'm going to say, let's say select Dinesh, very simple one as name. That's it. So I begin my try, I select something and then end my try. And then in the catch, I just print catch block is hit and then end the catch. Very simple stuff. Okay, let me run this. So what should be executed? So you need to remember one thing, that only when there is an error here, then the catch block is executed. If there is no error here, then only the SQL queries are executed. Okay, so let me run this and show it to you. Let me run this, and you see it just selects my name as it selects Dinesh as the name. Okay, so there is no error whatsoever. But let me try to divide 1 by 0. Now 1 by 0 is a fatal exception in any programming language. You talk about SQL, Java, .NET. Okay, you cannot divide a number by 0. Okay, it's a fatal exception. So let me run this independently and show you. See, it throws an error saying divide by 0, error encountered. So now let me run this whole thing and let me show you what happens. So if I run this whole thing, see, now it doesn't throw me any error. It doesn't give me any error because it went into the catch block and printed this message. So it proves the theory, right? That if there is any error here, the catch block is hit. And see, I printed the message saying catch block is hit. So the catch block is now hit because of this query, because it has a error in it.
Just a quick info, guys. Test your knowledge of SQL by answering this question. What is the full form of SQL? A. Structured query list. B. Sample query language. C. None of these. D. Structured query language. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
Now, let's say that I want to do and I want to catch the error that was thrown from here. So there was an error, right? Obviously, it was throwing divide by 0. Now, can I store it in a variable somewhere? Yes, I definitely can. So in here, what I'm going to do is I'm going to create a variable. I told you what variables are earlier, right? Variables are just memory, are just containers which reserves a space in memory to hold a value. So I'm creating a variable. The variables are usually prefixed by @ symbol, and we declare them. Okay, so the variables we declare. So I create a variable with the name error message of type varchar, and it can hold up to 1000 characters. Okay, and here I say set error message. You see this variable, I say set the error message equal to the error message function. Now what does the error message function gives me? It'll give me the error that's been thrown from the try block. Okay, that is how this function works. So it'll give you the error message that's been thrown from the try block. So we store that message in the error message variable, and then end of it I just select the message, the error. Okay, so let's run it now and see what happens. See, it now shows me the message saying divide by 0 error encountered, and it is coming from where exactly? It is coming from this part of the catch block. So when SQL started executing the query, it started from the begin try, perfectly okay. It came here. Now that it is, now this throws an error. Only because it is inside a try block, it directly goes to the catch block, prints this statement. Let me show you where it is printed. If you go to messages, see it says catch block is hit, and then it runs these queries as well. And in this, I declare a variable, I store the error message in here, and then display the error message. Okay, simple. And now, although the query has an error, but it does not throw an error. You see, it says query executed successfully. So now if you want, you can either use this message to send it to the UI, because the application will not know, right, if there is an error. So you can either store it in a table for logging purposes. It's up to you. You can store this with the date and time saying, so you know that at this date and time this error was encountered. Okay, so you can do a lot of things with this, but the main purpose of the try catch is to handle the errors well, handle our queries to run in a better way. Okay, because when it throws an error, there is no control on what SQL does. It just throws the error and then it gets lost. I mean, there's nothing that we can do. We have no trace of it. We cannot store the value of the error or anything at all. But this gives you a more controlled approach to it. Now let's say you have more than one queries. Okay, let's say I have another query and this one also throws an error. Let's suppose this one also throws an error. You already know it will not be able to add a string and an integer. We need to use the cast, right? So it throws an error saying conversion failed when converting varchar value Dinesh to int. Okay, so now if I execute this, what will happen? Okay, so now I have two statements with two different errors. So if I execute this, it still throws me the same error, and the catch block is hit only once. Why? Because you need to understand this thing. So it goes query after query. So the moment the first query fails, it has an error, it goes to the catch block already. So it doesn't execute any other queries after the error is encountered. So if the error is encountered here, it will not execute any other queries below it, because it already goes to the catch statement or the catch block in the first query itself. Okay, so obviously it would only display me the error message from this query. Okay, so this is how a try catch block helps us have more control and more authority on the errors that are being encountered on our queries. Perfect. Now let's try to see how this can help us with the transactions. So as I told you,
Just a quick info, guys. Intellipaat provides Microsoft SQL certification training in partnership with Microsoft. The course link of which is given in the description below. Let's hear what our customer says about the course. Did you get any promotion or appraisal in your current company after completing the course?
Yeah, I just recently become as a lead in my organization. So after completing this course, because I have other 2-3 projects I have completed with a success story. So yeah, I got a promotion.
Now let's continue with the session.
the transaction. So we begin the transaction and we commit or roll back based on what. So let's say if the transaction has 10 queries, okay, and if 5 of them ran fine and one of them throws an error, then we roll it back. If all the queries run fine, we commit it. Now this is all manual, right? I mean, we run this query and then if there is no errors, we commit it. If there are some errors, we roll it back. Okay, but how can we automate the commit if everything is well and roll back if there is an error? This is where the try catch block is going to come in handy. So with the try catch block, okay, I can combine this with the transactions to make it even more effective. How? You know about the begin try and the end try, right? And inside this we specify all our queries. Now what I do is I also begin my transaction inside the try block and then place all the queries in here. Let's say there are 3 queries that I want to run, and then end of it I say commit transaction. This is all happening in the try block, mind. So I begin my transaction here, I commit it right after all the queries are done, and then in the catch I roll it back. I roll back the transaction and then end catch. Now let's see what happens. Okay, there can be 2 situations. One, everything runs fine. So the try begins, transaction begins, everything runs fine, the transaction is committed because everything ran fine. So there's no harm in committing it. And then the try is ended. The catch isn't executed because there was no error at all. Now let's say the other situation wherein we begin the try, transaction is begin, the first 2 queries ran perfectly okay, but by the time the 3rd query was running, there was some error. So what happens? Right when the error is encountered, the control goes to the catch block now. Okay, it does not execute the commit anymore. It goes to the catch block and it rolls back the transaction. That means it rolls back whatever changes was done for queries 1 and 2, although they did not have any errors. But if you remember, transaction is either all or none. So either all of these 3 queries get executed successfully or none of them execute. There is no partial execution in a transaction. So this is how we can leverage the error handling with the transactions to make it automatic now. So when I execute this query, it will automatically check if there are no errors, it will commit it. If there is an error, it will roll it back. You see, it looks very complicated, but when you understand the concepts, this is the beauty of SQL Server. Okay, this is the beauty of the language SQL. It is, I mean, there are no complex statements at all. It is just that the placing of the queries makes it look a little bulkier. Okay, but if you understand the concept, it is as easy as learning, I don't know what is the easiest thing to learn, but yeah, I mean, I just wanted to compare it with that. Right? Any ABCD? I mean, if you ask, ABCD is difficult for a kid. So there's nothing that is easy in this world, but I'm just trying to say. All right. So let's see how do we leverage this in a procedure. Okay. So here, I mean, it might look a bit long, but bear with me. Okay. I don't want to use these. Okay. So here, what I do, you already know, create or alter procedure. Let me just reduce the font a little bit. So here I begin my procedure as begin, right? So this you already know. You know what this one does, right? The set transaction isolation level read committed. Okay, this helps us in reading only the committed data from the tables. Now here, if you see, this is where the try block starts. I begin my transaction, and if you see, observe carefully here, I have all my statements here, all the update statements that I want to run together as part of the transaction, right? So begin transaction, all the queries in here. Then I commit my transaction and print a message saying transaction is committed. And then here, sorry. So I commit my transaction, print a message and try. And then in the catch, I just have a rollback as I showed you earlier, and then just print a message saying that the transaction was rolled back. And I end the catch, and this end is for the procedure that I begin here. This is for the procedure. Okay, I had a procedure begin, right? Now, what do we have in the update statements? Let's check it here. So what does the first update do? It sets the last name to Yadav for employee ID 1. Good enough. It inserts a new record into the employee table with ID 10. Perfectly all right. Now the third query is I'm trying to update again the employee table, setting the employee ID to 1 by 0. You know this is going to throw an error, right? Because it's you already know it throws a divide by 0 exception where employee ID equals to 1. So this query is going to throw an error now. Okay, that means obviously none of these changes should happen when I run this procedure because all of these are in a transaction. So the first query will run fine, the second query will run fine, the third query will throw an error, and hence the the cursor will go to the catch block and it will roll back the transaction. If everything would have run fine, then the commit would have run. Simple. Now let's create this procedure. Okay, let's create this procedure. Okay, fantastic. Let's execute this procedure now. Okay, see, it says transaction is rolled back. Why? Because as I told you earlier, the queries had a problem, right? The third query had a problem. Now, if I show you the employee table, you will notice that the last name will not be Yadav for employee ID 1, and this record will not be there in the table. Let me just show you by selecting. So you see, for ID 1, the last name is Kumar and there is no ID 10 here. That means none of the changes are performed on the table. Although the first two queries are okay, but only because all of these are in a transaction, that's the reason it rolled back the first two as well. Okay, now let me comment this for you. Okay, let's comment this. And now let's alter this procedure. So now the procedure should run fine, right? So it should commit the data this time. So let me run this and it says transaction committed. And now when I run from the employee table, see here, the last name has got updated to Yadav and there is a new record with ID 10. Okay, so what are CTs? CTs are commonly called, are known as common table expressions. So you remember when we spoke about global temp tables, local temp tables, table variables? CTs are also like that, exactly like that. They are temporary storage that helps us store data in them. Okay, so the scope of a CT is different when compared to temp tables, table variables and stuff. Okay, so let me show you first how to create a CT and then I'll explain you the scope of it. That means till when can we access a CT. So to create it, we start with a semicolon and then say with the name of the CT. And then here I specify the columns only, not the data types, only the columns. So this CT is going to have 4 columns, first name, last name, address and date of birth. And then as inside my bracket, I specify what data should be stored in the CT. So here I select the first name, last name, address, date of birth from the employee, inner joined with the date of birth, and I'm only storing the Indian employees in the CT. You see, I use a where clause here. Now let me create this CT. Whoops, it throws an error. The reason is with the CT, you will have to select from the CT right after it is created. Okay, you cannot just create a CT without selecting from it. The first query should be select from the CT, and now if I run this, it should work. See, it now gives me these details. Now, one thing that you need to understand here is that the scope of a CT. Okay, the scope of a CT is only till the first select inside the same batch. Now, see, let's say I create and select the CT. Okay, I see the data. I run the select also with it, right? Now, if I run the CT separately, I cannot find it. So it's same as that of the table variable. But the table variable, we can use it multiple times, whereas a CT can be only used once. Let me show you. See, I have a select from the CT here. I have another select from the CT here. Okay. Now, if I run this, you will notice that only the first select will give me data. But the second select that I have, it says invalid object name CT employee. Okay. So this one throws an error, but this one works. Is because the CT, the scope of a CT is only till the first select. inside the same batch. So you cannot use a CTE more than once after you create it. I mean, in more than one statements. You can join them like this. See, you can let's say cross join. Okay, if you want, you can use the CTE multiple times in the same query, but only in the first query. You cannot use it again in the second query. So it is only available in the first select right after it is created. Okay, now where exactly is this CTE created? The CTE is created in the memory, like the table variables. Okay, these are not created on the temp database. So these are faster, but as it is stored in the memory, we usually store only a very small amount of data like table variables. But these, we just can use them once. So for any type of data that we want to use only once, we create them as CTEs. Okay, so it's like a temp storage itself, but it is meant for very small amount of data that we want to use only once. That's it. Okay, that's about CTE.
Okay, so we've seen that. Next we'll look into the skills to have as a SQL developer. So we saw what are the requirements and the roles of an SQL developer. Now the skills. First of all, data management, obviously, because database manages has data in it. So to manage that, you will need to know a very good knowledge of SQL so that you will be able to manipulate it and also manage the data accordingly. Software programming is required. It is not mandatory that you can only become an SQL developer having a very thorough knowledge of a programming language, but having the basics or having the intermediate knowledge of software programming. So let's say your company uses Java, then learning how Java works will obviously help when you build a database for that company. So because that database should be compatible with Java. And yes, so that's what you should also know, software programming. Server development and maintenance. So this again, you can learn on the go. So server development in the sense to run virtual machines and to create databases on it and also maintain it. Problem solving, if there is a problem arise, if there is a problem, so this particular person should be able to create a query which solves that problem or should be able to make the database more compatible. And then TSQL, which is basically related with transactions. So learning this is not compulsory at the beginning for an SQL developer, but learning this will also improve their chances of getting a job. Then process enhancement, this is to make better business decisions. So you can be an SQL developer and also be involved in process enhancement. That is, a company might go with a set of processes which is already organized and they go with that flow. So let's say an SQL developer can go ahead and change that process if that benefits the need. Okay, so these are the basic skills which you need. First of all, learn SQL. So that is the most basic thing. So if you learn SQL, you'll be able to manage data and understand software programming, because without software programming, without knowing how an application works, you will not be able to build an compatible database with it. Development and maintenance, problem solving, SQL, and process enhancement. So make sure to go by the flow. Start off with SQL, software programming, and then move ahead with the other tools. And then the career path. So once you have all these skills, you can obviously start applying for a job. Then as an SQL developer, there are various profiles. It is not just developer. There are so many different profiles within a company. So as I told you, a database, an SQL developer should be able to maintain, should be able to build, should be able to manipulate. So let's say if you want to maintain a database, so you can become a database administrator. So the basic task of a database administrator is to administer the usage of the database in that particular company. So you will be the head of the entire database system. You will be able to administer every single transaction. So it's basically maintaining. And then a database developer is a person who builds and also manipulates databases. So you can also become a database developer by having the skills. So let's say for a database administrator, you should go with
more of a view that you'll be able to manage any kinds of problems which are arising. You should be able to solve any kinds of problems which are arising. A database developer should go with, let's say, this person should be able to create SQL queries for any scenarios given in the company. Okay, so next is data scientists. So obviously data scientists need SQL. Without SQL, it will be very hard for them. So SQL is a need for data scientists as well. So learning any SQL, that is any SQL engine, will help the data scientists. And then ETL developer. So this basically involves big data, extract, transform, and load. And again, you can also become an ETL developer by learning databases. Then BI developer and administrator. So BI is business intelligence. So in business intelligence, you obviously need to create visualizations, and to create visualizations, you need to manipulate or query data. And to do that, you should obviously know SQL, and it will help in becoming a BI developer. So to become a BI developer and an administrator, you should not just know these skills which I showed you for an SQL developer. You should also learn BI tools like Tableau or Power BI. So only then you can move ahead with BI. Okay, so now we've seen that. We'll look into the certification path for an SQL developer. First of all, what are certifications and why do you need it? First of all, it's a stamp of excellence. That is, if you have it on your resume, it adds value, so that you don't need to even explain that you know database. If they see that you have a certificate from Oracle, or let's say a certificate from Microsoft, they will understand that you have prepared and cleared that exam and you know well enough. And then substantial increase in pay. So once you get earning certifications, obviously you are putting in time and effort to make yourself better in your career. So that will obviously give you a good hike. Clear corporate requirements. So as I told you, every single company needs a database developer. So for that, for clear corporate requirements, that is, few companies might have a requirement of having a particular certification, and that will help if you're going to go for that particular job and helps get you hired. So obviously everything goes back to that point. So these are certifications. Why do you need a certification? And also, while you do certifications, you'll be able to understand a lot, and also will be able to experiment with a lot of projects before you enter the corporate career itself. Okay, so these are some SQL developer certifications. First one is the IBM Certified Database Administrator, DB2. So this involves the database called DB2. Then Microsoft SQL Server Database Certification. This involves Microsoft SQL. And then Oracle. Under Oracle, there are two. One is Oracle Certified Professional, or MySQL Database Administrator. So MySQL is one of the most popular databases in the world, and you can go ahead with MySQL Database Administrator without any hesitations. But the one more thing you'll have to remember is there are n number of MySQL Database Administrators or Oracle Certified Professionals. Also, Oracle Database 12c Administrator is also one more certification which you take up to go for a particular role. So these are some of the most popular certification courses. So for SQL developer. So if you want to, it is not just, so let's say if you complete the IBM certification, it is not just you can go for IBM. The thing is, you can go for any company which uses DB2. Or if you do the Microsoft SQL Server, so any company which uses Microsoft SQL Server needs a database developer or an administrator with an apt certification, and you can be eligible for that, and same goes with Oracle. So these are some of the popular certifications. You can check out more if you want to check out other, so let's say MariaDB, or there is a number of database engines out there. You can go ahead and check them out. So these are some of the popular certifications and highly recommended. Okay, so we've seen that. Now let's look into the most important part, which are the job trends, because obviously at the end of the day, you will need a job, and also salary. So first of all, SQL developer in the USA, they are getting about $72,282 per year as an average. So this is the average amount. There is a low, there is a high to this. And in India, it goes around 6.5 LPA. So these are the two variants in US and India. So This is for an SQL developer role, and this is totally relative because this data is collected from Glassdoor or Payscale, and those data is based on the salaries which other let's say there are 100 users in Glassdoor who are SQL developers. If they post their salary, it is aggregated and the mean is given to you as the salary which is provided here. So it can vary. It can be it can be lower than this for a beginner, and it can be higher than this for a experienced database professional. So we've seen that. So who's hiring? So every single company which uses the database. So that puts under Uber, Spotify, Netflix, Instagram, Dropbox, Airbnb, Twitter, and any other company. So you can go ahead, learn this, and you will have to pick out. You will have n number of companies to pick out. You can attend a lot of interviews, and if you're talented enough, you will be able to bag a job in a couple of days or maybe weeks.
So what exactly is SQL? So this is a very basic question. So to answer this, SQL stands for the Structured Query Language, and according to ANSI, it is a standard query language for relational database management systems, which is used for maintaining the relational database and also to perform different operations of data manipulation on different types of data. So SQL is widely used language for maintaining relational database, and in the year 1986, SQL became the standard of American National Standards Institute or ANSI. So basically it is a database language which is used for creation and deletion of databases, and it can be used to fetch and modify rows from the table and also multiple other things. So let's head on to the next question. So we are supposed to explain the different types of SQL commands. So the SQL commands can be divided into 4 categories.
Just a quick info, guys. Test your knowledge of SQL by answering this question. Which of the following is not a valid aggregate function? A. Count. B. Sum. C. Max. D. Compute. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
So we've got data query language, data definition language, data manipulation language, and data control language. So the data query language comprises of just one command, select, though it can be accompanied with many clauses to compose queries on a database. Then we have the data definition language. So DDL is that part of SQL which defines the data structure of the database in the initial stage when the database is about to be created. So it is mainly used to create and restructure the database objects. So you can see commands like create table, alt table, and drop table in DDL. And after that we have the data manipulation language. So DML is used to manipulate the already existing data in the database. That is, it helps the user to retrieve and manipulate the data. And it is used to perform operations like inserting data into the database through the insert command, updating data in the database through the update command, and deleting data from the database through the delete command. And finally, we have the data control language, which is used to control access to the data in the database. So these DCL commands are normally used to create objects related to user access and also to control the distribution of privileges among users. And you see commands such as grant and revoke in DCL. Right, so this is the next question. So what exactly are constraints? And we are supposed to explain about the default and the unique constraint. So constraints are basically used to specify some sort of rules on the data and limit the type of data that can go into a table. Alright, so let's understand about default constraint. So the default constraint is used to provide a default value for a column. So the default value will be added to all the new records if no other value is specified. For example, if we assign the default constraint to this e-salary column and set the default value to be equal to 85,000, then all the entries of this column will have a default value of 85,000 if no other value is assigned during the insertion. So similarly, we can also assign a default value of analytics to this eDEPT column. Right. So now we'll go to SQL Server and we'll work with the default constraint. Now I'll start off by creating a new table and I'll add the default constraint to one of those columns. So I'll create a new table and I'll name this table as stu1. So the syntax would be create table stu1, and this would comprise of these columns. So there would be SID, which basically stands for the student ID, and the data type of this column would be integer. After this, there is SName, which stands for student name, and the data type would be varchar, and the length of the string, or the maximum length of the string, would be 20. And then I'll finally have the marks scored by the student, which would be SMarks, and this would be of integer type. Now after this, I will give in the default constraint, and I will set the default value to be equal to 50. Right, so I have successfully created this table. Now let me have a glance at this table first. So select star from stu1. So this is our table, which is empty as of now. Now what I'll do is I will go ahead and insert some values into the table. So I'll type in insert into stu1, and then I'll give in the name of the columns. So this needs to be insert. So the name of the first column is SID, and then I've got SName. Now I'll type in values and give in the values for these two columns. So let's say the first ID is 1 and the name of the student is Sam. Now I'll click on execute. Now let me have a glance at this modified table now. Select star from stu1. So now we see that we have this default value of 50 in this SMarks column, and this is because we had assigned the default constraint to this column. Now similarly, let me add 2 more records into this table. So insert into stu1, SID, SName. I'll give in values. So it'd be 2, and the name of the second student is Bob. Right, so I've also added the second record. Now let me add in the third record. So the student ID is 3 and the name of the student is Matt. Right, so now I have 3 records in this table. Select star from stu1. So these are the 2 new records, and the default value is 50 for these 2 new records. So this is how we can work with the default constraint. Now comes the unique constraint. So the unique constraint ensures that all the values in a column are different. For example, if we assign the unique constraint to this ename column, then every entry in this column should have a unique value. So here we see that all the names of the employees are different. Now again, let's go to SQL Server and work with a unique constraint. So again, I'll create a new table and add the unique constraint to one of the columns. Create table, and this time the name of the table would be stu2. Again, there would be the ID, and this is of integer type. Now I would be assigning the unique constraint to this SID column, and there would be a second column which is basically the student name, and this is of varchar type. Again, the length of the string would be 20. Right. Now let me have a glance at this table again. So select star from stu2. So this is our new table which is empty as of now. Now let me go ahead and add values into this. So insert into stu2 values. I'll add in the first record. So 1, which would be the student ID. Name of the student is Julia. Now let me look at this table. Select star from stu2. Right, so we have successfully inserted this record. Now let me add a new record. So insert into stu2 values. Now what I'll do is I will again give the ID of the student to be 1 and the name of the student to be Matt, and let's see what happens. So this time we get a message or a warning message, and this states that violation of unique key constraint, and we cannot insert duplicate key in object dbo.stu2, and that is because we had given the unique constraint to this SID column. That is why this has to be different. So let me change this to be 2. Now let me again run this, right? So now since this is a unique value, 2 is not a duplicate. That is why we were able to insert this record. Now again, what I'll do is let me add another record with the ID 2. So let's say now the name of the student is Annie. Now again we get this warning message because ID number 2 is already present. So let me change this to 3. Now let me run this again, right? So now we are able to insert this record. So this unique constraint basically makes sure that there are no duplicate records inserted into this column. So now we have the next question. So again we have this employee table with us and we are supposed to find out the second highest salary from this table. So let's go to SQL Server and find out the solution. So let me start off by having a glance at the employee table. Select star from employee. Right, so this is our employee table over here and we see that the highest salary is 159,000 and the second highest salary is 125,000. So we are supposed to extract this particular value from this data set. Now let's see how can we do this. So we can perform this operation with the help of subquery. Now let me just type in the command select, and since we want the maximum value, I'll use the max aggregate function and this would be E salary. So I want the maximum salary from the name of the table is employee. I'll give in the where clause and given the condition where E salary is not in. After this, I will give in the subquery over here. So the subquery again would be the same. So select max of E salary from employee. So now if you have a glance at this, you would see that both of these queries are same. So select max of E salary from employee and select max of E salary from employee. Now this subquery would give in this result, which is 159,000. So and then this main query would make sure that this salary does not lie in this. So this would give us the 125,000 result. So select max of E salary from employee where E salary is not in 159,000. That would mean 125,000. So let me click on execute, right? So we have successfully got the result, which is 125,000. And this is how we can extract the second highest salary. So we have our next question over here. So what do you understand by normalization and denormalization? So this is a question which is very frequently asked during the interviews. So let's get to the answer. So normalization and denormalization are basically methods used in databases. And normalization is the process of reducing data redundancy and dependency by organizing fields and tables of the database. So it involves constructing tables and setting up relationships between those tables according to certain rules. And the redundancy and inconsistent dependency can be removed using these rules in order to make it more flexible. So I'm repeating it again, guys. So simply put, normalization is the process of reducing the data redundancy. And we are able to do this by organizing the fields and tables of the database. And then we have denormalization, which is a contrary process to normalization. So in denormalization, we basically add redundant data to speed up complex queries involving multiple table joins. So in denormalization, we attempt to optimize the read performance of a database by adding redundant data or by grouping the data. Right, so this is our next question. Now we are supposed to find out what exactly is wrong with the SQL query. So this is the SQL query over here. Select gender, average of age from employee where average age is greater than 30. And again, we are grouping this with respect to gender. So this is our employee table over here. Now let me go ahead and just type in the command, which would be select E gender. And then I would want the average of age. So average of E age from the name of the table is employee, where again the average of E age needs to be greater than 30, and this is being grouped with respect to gender. Now let me go ahead and click on execute. So let's see what is the error. So this warning message states that an aggregate may not appear in the where clause unless it is in a subquery contained in a having clause or a select list, and the column being aggregated is an outer reference. So this basically means that whenever we are working with aggregate functions and we are using group by, we can't use the where clause. So instead of the where clause, we would have to use the having clause. Now let me change this to having and let me click on execute. So now again we get an error over here, and this error says that incorrect syntax near the keyword group. And this is because if we are using the having clause, then group by would come first and having would come second. Now let me cut this over here and let me paste this before having. Right, now I'll click on execute. So this has to be gender over here. Now we've successfully got the result. So just to reiterate, the error was whenever we are working with aggregate functions, we cannot use the where clause and we would have to use the having clause. And if you are also using group by with having, then group by would come first and having would follow it. So next question. So what do you know about the stuff function? So the stuff function deletes a part of the string and then inserts another part into the string starting at a specified position. So this is the syntax of the stuff function. So stuff, this takes in these 4 parameters: string 1, position, length, and string 2. So this string 1 is basically that string which would be overwritten. Position would basically indicate the starting location for overwriting the string. And length is the length of the substitute string. And string 2 is that string which would overwrite the string. So again, let's go to SQL Server and work with an example with the stuff function. So now let's say I have this string which basically stands like this: SQL tutorial. Now I'd want to replace this SQL tutorial with Python tutorial, right? So for this purpose, we can actually use the stuff function. So let me go ahead and write the syntax for that. It would be select, I'll give in the function stuff. So let me start with the first parameter, which is the string which is to be replaced. So the string which is to be replaced is SQL tutorial, and then I'll give in the second argument, which is the position. So the position would be 1, that is I want to replace this. So this is position number 1, and then I would have to give in the length of the string which is substituted, right? So the length of SQL is 3. I'll just type in 3 over here. And then finally I will give in string 2, which is basically that string which would replace this over here. So I would type in Python over here. Now I'll execute. So initially our string was SQL tutorial, and with the help of the stuff function, we were able to change this from SQL tutorial to Python tutorial. So next up, we'd have to explain about views in SQL. So what exactly is a view? And then we'd have to give an example of view. So you can consider views as virtual tables which are used to limit the information that we want to display. And these are actually nothing but the result of an SQL statement which have a name associated with them. And since views are not virtually present, it takes less space to store. So let's take this example. From this employee table, let's say we wanted to perform multiple operations on the records where the gender is female. So we can create a view only for the female employees from the entire employee table. So let's go ahead and perform this in SQL Server. Now let me type the syntax for this. So I would want to create a view which would comprise of only the female employees from the entire employee table. Now let me just have a glance at the employee table first. So select star from employee. Now I would want a view which would comprise of just these 2 records. Now let me go ahead and write in the syntax for the view. So it would be create view, and the name of the view would be female employee. And after this, I will give in the keyword AS. After that, I'll type in select, and then I'll give in the condition. So select star from employee, where after the where clause I will give in the condition which actually matters. So gender needs to be equal to female. Right, so I have successfully created this view with the name female employee, which would comprise of only the records of the female employees. Now let me delete this and let me have a glance at the view which I've just created. So select star from female employee. Right, so this is our view which comprises of these 2 records, and the names of the employees are Anne and Julia. Now similarly, let's say if I wanted a view which would comprise of only those employees whose age is greater than 25. So let me go ahead and write the syntax for that. So create view, and then let's say the name of the view is age, and then I'll type in the keyword AS, select. Now over here, let me give in the statement. So select star from employee, where, and then the condition would be age needs to be greater than 25. So we have created this view. Now let me have a glance at this. So select star from age. Right, so this is a view which would comprise of only those records where the age of the employee is greater than 25, and we've got 4 records over here. So Sam's age is 45, Julia's age is 30, Matt's age is 33, and Jeff's age is 27. Right, so what is a stored procedure? And then we'll have to give an example of stored procedure. So a stored procedure is a prepared SQL code which can be saved and reused. Or in other words, you can consider a stored procedure to be a function consisting of many SQL statements to access the database system. So we can consolidate several SQL statements into a stored procedure and execute them whenever and wherever required. And stored procedure can be used as a means of modular programming. That is, you can create a stored procedure once, store, and call for several times whenever required. So this supports faster execution when compared to executing multiple queries. Now let's look at the syntax of a stored procedure. So we'll give in the keywords create procedure, and then we'll give the procedure name over here. After that, we will give in the keyword as, and then we'll give the SQL statement for which we'd want to create the procedure. And then we'll end the procedure with the go keyword. Now, after we create a procedure, we need to execute it. So this is the syntax to execute the procedure. So we'll type in exec and then give the name of the procedure which is to be executed. Right, so again, let's have an example with the stored procedure. So now I'm going to create a stored procedure which would help me to extract the age of the employees in a very easy way. So let me type in the syntax for that. Create procedure. And then I'll give in the name of the procedure. So this would be employee age. After this, I will type in the keyword as, and then I'll give in the select statement. So select age from employee. Now that this is done, I'll give in the go keyword. Right. So now I have successfully created this stored procedure with the name employee age. Now I'll go ahead and execute this. So it'll be exec or execute employee age. Right, so we have created the stored procedure which would help me to easily access the age column from this employee table. So next question, what do you understand about join, and explain about different joins? So a join clause is used to combine rows from 2 or more tables based on a related column between them. So there are various types of joins which can be used to retrieve data, and it depends on the relationship between tables. So first we have inner join, which basically returns records that have matching values in both the tables. Then we have left join. So left join returns rows which are common between the tables and all rows of the left hand side table. That is, it returns all the rows from the left hand side table even though there are no matches in the right hand side table. Then we have right join. So right join returns rows which are common between the tables and all the rows of the right hand side table. That is, it returns all the rows from the right hand side table even though there are no matches in the left hand side of the table. And finally we have the full join. So full join returns all rows from the left hand side table and all the rows from the right hand side table. So now we'll have to explain about inner join properly. So the inner join basically gives us those records which have matching values in both the tables. So we've already learned this. Now let's say we have two tables, table A and table B. And when we apply inner join on these two tables, we'll get only those records which are common to both table A and table B. So this gray portion which you see over here, so this would be the result of the inner join. Now let's look at the syntax of inner join. So we'll give the keyword select and then we'll give in the list of the columns. Following which we'll give the from keyword and then we'll give the name of the first table. Then we'll use the keywords inner, join and then give the name of the second table. After which we'll give in the on keyword. So this on keyword tells SQL that this inner join needs to be done on some condition. And the condition over here states that the values from column X of table 1 should be equal to the values of column Y from table 2. So let me just reiterate this. The values of column X from table 1 should be equal to the values of column Y from table 2. Now let's go to SQL Server and work with this inner join. So I have two tables over here. So the first table would be the employee table and the second table would be the department table. So let me have a glance at both of the tables. So select star from employee. Now The second command would be select star from department. So this is the employee table over here, which we've already seen, and then we have this department table. Now I'd want to have an inner join on both of these tables where the EDEPT column from this table is equal to the DNAME column from this table. That is, wherever the values from these two columns match, I'd want only those records. Now let me go ahead and write the syntax for this. So I will type in select and then I'll give in all of the columns which I want. So I want the ename column and eDepartment column from the employee table. So this would be employee.ename. Then I would want employee.eDepartment. After that, I would want the department name and the department location from the department table. So I'll type in department.dname. And then I also want department.dlocation. Right, so these are all of the columns which I want from both the tables. Now after this, I'll type in from, and then I will type in the name of the first table, which is employee. And then I'll just type in inner join, and then given the name of the second table, which would be department. Then I'll give in the on keyword and then given the condition. So here the condition is the values of the DNAME column should be equal to the values of the EDEPT column. So employee.ename should be equal to department.dname. Now I'll execute this. Right, so this is the result. So we have our employee table over here. This is the department table. And finally, this is the result of the inner join. So here we see that we've got only those records where the departments match in both of the tables. So the matched departments are support, analytics and sales, right? So we've got support, analytics and sales from over here because only those departments are present in this department column. So next question. Well, what do you understand about temporary table? And then we'd have to write a query to create a temporary table. So simply put, temporary tables basically help us to store and process the intermediate results. Now these temporary tables are created in the testdb and are automatically deleted when they are no longer used. So the temporary tables could be very useful in cases where we need to store temporary data. Now let's look at the syntax of a temporary table. So first we will give in the keywords create table, and before we go ahead and give the name of the temporary table, we'll have to precede it with a hash. So again, let's go ahead and create a temporary table. So now what I'll do is I'll create a temporary table and I will name this as, let's say, book, and then before the name of the table I'd have to precede it with a hash. Right, now this would have two columns. So first would be the book ID and this would be of integer type, and then this would have book cost, which is again of integer type. Now let me execute this. Now I'll refresh over here. I'll click on the plus sign. I'll go into system databases and I'll go into testdb, and over here let me click on the temporary table. So we see that we have successfully created this temporary table with the name book. Now let me see what is present in this table. So I'll type in select star from, I'll put in the hash symbol over here, and then I'll give in book. Right, so as of now this temporary table is empty. Now let me go ahead and insert something into this table. So the command would pretty much be the same. So insert into, and then lb book. I'll type in values over here. So the only difference which you see when you're creating or working with a temporary table and the normal tables is you would have to precede the name of the table with a hash. So as simple as that. Rest everything would be the same. And over here let me give in the values. So the book ID is 1 and the book cost is 100. Right, now let me also add another record. So the second ID would be 2 and now the book cost would be, let's say, 232. All right, now let me have a glance at this modified temporary table. So select star from hash book. Right, so we have added 2 records into this temporary table. So now we'd have to explain the difference between OLTP and OLAP. So let's start with OLTP. So OLTP basically stands for online transaction processing, and you can consider it to be a class of software applications capable of supporting transaction-oriented programs. And an important attribute of an OLTP system is its ability to maintain concurrency. So OLTP systems often follow a decentralized architecture to avoid single points of failure. And these systems are generally designed for a large audience of end users who conduct short transactions. And queries involved in such databases are generally simple, need fast response times, and return relatively few records. So the number of transactions per second acts as an effective measure for such systems. Then we have OLAP. So OLAP stands for Online Analytical Processing, and it is a class of software programs which are characterized by relatively low frequency of online transactions. So queries are often too complex and involve a bunch of aggregations. And for OLAP systems, the effectiveness measure relies highly on response time. So such systems are widely used for data mining or maintaining aggregated historical data. And this is usually used in multi-dimensional schemas. So then we have the next question. So what is the difference between the delete and the truncate command? So again, keep this in mind, guys. This is a question which is very frequently asked in interviews. So let's start off with the delete query. So the delete query is used to delete or remove one or more existing tables. So let's have a look at the syntax. So we'll start with the delete keyword, and then we'll put in the keyword from. Then we'll specify the name of the table. After that, we'll specify the where condition, but then that's optional. So let's see an example of this delete command. So we have this table. So the name of the table is STU, which basically is the student table. Now from this table, I'd want to delete the record where the name of the student is Bob. So let me write the syntax for that. So delete from, and then I'd have to give in the name of the table. So the name of the table is STU. So delete from STU. After that, I'll give in the where clause and give the condition where S name is equal to Bob. Let me execute this. Right. So we have successfully deleted that record from this table where the name of the student was Bob. So similarly, let's say if I want to delete that record where the student ID is 3. Right. So over here, the condition would change. So delete from STU where SID equals 3. So now this time we have deleted that record where the student ID was equal to 3. Now let's look at the truncate statement. So the truncate statement deletes all of the data inside the table. So here we'll give in the keywords truncate table and then give the name of the table. So let's go to SQL Server and work with this truncate command. So now we have this stu1 table. So let me go ahead and use the truncate command of this table. So I'll type in truncate and then I'll give in the name of the table, which would be stu1. So before that, I'd have to type in table. So truncate table stu1. Let me run this. Right, so we have deleted all of the records from this table. Right, so this is how the truncate command works. Now let's understand some differences between the delete command and the truncate command. So when it comes to the type of language, truncate would be a DDL command or a data definition language command, and delete is a DML command or a data manipulation command. Now another difference would be we can't really execute a trigger in case of truncate. While with delete, we can accomplish a trigger. Now, also if a table is referenced by any foreign key constraints, then truncate won't work. So if you have a foreign key, then you'd have to use delete and you wouldn't be able to use the truncate command. So next question. What is the difference between union and union all operators? So the union operator is used to combine the result set of two or more select statements. For example, if the first select statement returns these 3 fish, and the second select statement returns these 3 fish, then the union operator would return the result of these 2 select statements. And if there is a record which is present in both the tables, we'll get only one of them in the final result. So here we see that this blue fish is present in both the tables A and B. Now, when we apply the union operator on these 2 tables, the final result of A union B would have only one of these blue fish. And this is the syntax of the union operator. So we'll give the first select statement. After that, we'll give in the union operator, following which we'll give the second select statement. Now you also need to keep in mind that the number and the order of columns must be same in both the select queries. So let's work with this union operator now. So we have these two tables over here. So the name of this table is student details 1 and the name of this table is student details 2. And if we have a glance at the columns, we see that both of the tables have 3 columns and the names of the columns are same and also the order of the columns are same. So here we have SID, SName and SMarks. Similarly over here we have SID, SName and SMarks. Now let's go ahead and apply the union operator on this. So I'll type in the first select statement. So it'll be select star from student details 1. So let me change the spelling to student details. After this, I will apply the union operator and then give in the second select statement. So select star from student details 2. Now let me click on execute. So this is the result over here. Now let me also print in the first 2 original tables. So select star from student details 1 and then I'll also put in select star from student details 2. So let me just change the spelling to student over here. Let me also change this over here. So this will be student. Right. So this is student details 1, this is student details 2, and this is the result of the union operator. Now, if you have a glance at these two tables, then you see that these two records are repeating over here, right? So there's Anne, Julia over here in the first table, and there's also Anne and Julia in the second table. Now, when we apply the union operator, then we'll just have one record coming from each of these tables, right? So we've got Anne over here, we've got Julia over here. And then we finally have Matt, which comes from the second table. This is how the union operator works. Right, now let's look at the union all operator. So the union all operator gives all the records from both the tables, including the duplicates as well. So here, since this blue fish is present in both the tables A and B, the final result of A union all B would also have the duplicate value. So here we see that we've got both of the blue fish from table A and table B. Now let's go ahead and implement this in SQL Server as well. So here we have these two tables already ready, which are student details 1 and student details 2. Now what I'll do is I will copy this, I'll paste this over here and just type in union all. So union all, I'll click on execute. So student details 1, student details 2. Let me just expand this over here. Right, and this is the result of union all operator. Right, so if you have a glance at this, you'll see that these two are repeating. So we would have duplicate values. So we've got Anne twice over here and also Julia twice over here. So next question. Well, what is the use of the intersect operator? So the intersect operator helps to combine two select statements and returns only those records which are common to both the select statements. Right, so if we've got table A and table B over here, and if we apply the intersect operator on these two tables, then we'll get only those records which are common to the result of the select statements of these two. Now let's look at the syntax. So over here, this is the syntax. So we'll start off by giving the first select statement and then we'll give the intersect operator, following which we'll give the second select statement. Now let's see an example on this. So again, we have these two tables over here, student details 1 and student details 2. Now let me apply the intersect operator on these two. So let me just type in intersect over here and I'll click on execute. Now let me maximize this over here. Right, so student details 1, student details 2, and this is the result of the intersect operator. So we see that since Anne and Julia are common to both of these tables, this is the resultant of the select statement, right? So the select statement on the first table gives out Anne and Julia, and the select statement from the second table also gives out Anne and Julia. So the intersection of these two would be this. So we have our final question. Now let's say you're given a table. Now you'd have to copy the data of this table into another table. So you have this employee table. Now you'd have to go ahead and copy the data which is present in all of this table into another table. So let's see how can we do this. So this is our employee table over here. Now we'd have to copy all of this into another table. So for this purpose, we can use the insert into select operator. Now before we go ahead and do that, we would also have to create another table which would have the same structure as this table. So if the table doesn't have the same structure, then you wouldn't be able to copy the data. So let me go ahead and create the table first. So I'll type in create table and I'll name this as employee duplicate. And then I'll give in all of the values over here. So my first column would be EID and this would be of integer type. Second column would be ename and this would be of varchar type. And the length of the string would be 20. And then I would have the eSalary over here. This would be of integer again. After this, I would have the E8, which is of integer. Then I would have the gender of the employee. So the gender of the employee would again be of character type. Now I'd have to make sure that I give in commas after all of these. So let me just put in a comma after this as well. And then the final column would be EDEPT. And this again would be of variable character of length 20. Right. So I've successfully created this employee duplicate table. Select star from employee duplicate. Right. So as of now, we see that this table is empty. Now I'd want to copy all of the table present in the employee table into this table. So let me write in the command for that. So I will start off by giving the keywords insert into. Now after that, I'll give in the name of the table into which I want to insert. So the name of the table would be employee duplicate. Then I will type in select star from, and then I would have to give in the name of the original table. So the name of the original table would be employee. Right. So 6 rows have been affected. Now let me have a glance at the new table, which would be select star from employee duplicate. Right. So we have successfully copied all of the data which was present in employee table into this employee duplicate table.
Just a quick info, guys. Intellipaat provides Microsoft SQL certification training in partnership with Microsoft. The course link of which is given in the description below.